What are data structures? The reason we are talking about this is because if you look at the internet, everyone says if you want to get into this company or that company, they will ask you a question based on data structures and algorithms. So first of all, why such a hype and what exactly data structures are? So before we get into data structures, let's talk about data. See, the entire software industry is based on data. When you do a course on IT, which we call information technology, it's not about technology, it's about information because we work with information. So data is everything. So it doesn't matter what technology you learn, you basically learn or you work on it so that you can work with data. Example, think about programming languages. Why do we use programming languages? To process the data. Why do we use database? To store the data. Why do we use AI? To generate data or to understand data, right? I mean, just to bring it down, everything is data. Now then question arises, what is data structures? Now if we talk about any programming language, we have something called primitive data types. If you want to store a number, we store that in integer. If you want to store a text, you store that in a string. If you want to store a character, you store that in a character. Of course, depending upon different languages, the term or the way you store it changes, but ultimately you have some types to it where you store the data. But what if you have a bunch of data and if you want to store them? It's not just about storing data. Anyone can do that. It's about how do you store data efficiently, and you can also save some memory. The thing is, if you simply dump the data, you are expanding the memory, and if you want to search something from the data, will be difficult. And that's why storing that data efficiently is very important, and that's where data structures comes into picture. So data structure is a way to organize and store data efficiently. Okay, so when you say efficiently, it means two things. First, in terms of performance, and also in terms of the memory. Now, what about performance? Now think about this. If you talk about any software application which we use, it can be a normal calculator, or it can be an application like Amazon website, or any application which we use, a banking application as well. Now, what we do in that application is we use some features using which you can compute something, you can process something. Example, on calculator, you calculate. On the banking website, you transfer money. So what you're doing is you are basically building an application which will do some processing. And the way you build an application is through algorithms. Now, what are algorithms? Set of instructions. Let's say if I want to add two numbers, it's very simple. What you do is you say, take two values from the user, then perform the operation and give the value back to the user. Now those are the steps, right? Those are instructions. Now what I have mentioned, the instructions, those are called pseudocode, because we're not actually typing a code here. We're not being specific to a language, let's say C, C++, Java, Python, JavaScript. What we are simply saying is, these are the steps you have to follow, and that's your algorithm, right? But yes, when you want to make it work, you have to convert that into a code which will run on the computer, right? That's your actual software code. And you can use any language, doesn't matter, right? But the pseudocode will remain same. Now, when it comes to processing of data for any task, it's important for us to make it fast and also save memory. Now, most of the companies are focusing on this concept of data structures is because they want to give a good experience to the user. Of course, right? If I'm using some application, I want it to be fast. Now you will say, okay, to make the system faster, you can increase the CPU speed, you can increase the amount of RAM. You can do that. But what if with the same amount of memory, same amount of CPU power, you can still make it more faster, right? And that can be done with the help of data structures. Now, if you know how do you store that data efficiently in a proper structure, and by doing that, you can make your application faster. Because in data structures, we have different type of data structures. Example, let's say if you have a bunch of data, you can store that in an array. But apart from array, we have other types as well. We have set, we have linked list. So when to use what? It's not that this is best or that is best. It's all about when to use what. And to understand when to use what, you have to first understand what those things are. Right? How do you decide that this time you have to use array, this time you have to use set? And that's where understanding these concepts are very important. Now, these are not the only options we have. We have tree, we have graph, when to use them. So when you understand those concepts, then we can think about, okay, for this situation, we will use this. And this is why companies are preferring candidates who knows DSA. It will help them in multiple ways. First, it helps them to reduce the cost is because every computation, see, I know you might be thinking, most of the applications which we use are free, right? Think about Instagram. Now, when we use Instagram, of course, we are not paying for it, but then companies are paying for it, right? So the Meta is paying for you to use Instagram. So because those computations will be happening somewhere. Maybe Meta is using some cloud service. Let's say Amazon is in this case. So Meta is basically paying to Amazon for every computation which you do. Okay. Of course, they earn from ads, but then they are paying for it. So what they will do is they will try to optimize it. They will say, okay, if one query takes, let's say, $1 or maybe half a dollar, can we just reduce it more? Can we just make it 10 cents? So that's the thing they are trying to do. And the way you can do that is by making sure you use a proper algorithm with a proper data structure. So why companies are doing it? To reduce the cost. Second, to give a better customer experience so that it will run faster. And if I search something, it should be faster for me as well, so as a customer. Next, when companies want to hire people, they have so many candidates, right? How will they filter those candidates? Now, data structures algorithm becomes one of the way to filter the candidates. Because if you know data structures, that means you have worked a lot on that particular language and you understand how a particular system works. On the other hand, data structures are not the only thing you need to know. If you want to be a good developer, if you want to get hired, there are multiple things needed. Example, you need to have a good hold on a particular language, a particular technology. You should have worked on few projects, understanding the entire ecosystem, not just one language. Working with databases, working with networking, but then DSA becomes one of the important things there. So just to summarize, what are data structures? So data structures is basically a way to organize and store your data in the efficient way. And there are multiple data structures option available there. And you will understand that in the upcoming sessions we're going to talk about. In the upcoming videos, we will talk about what are the types of data structures we have, how to use them, when to use what, and what are the algorithms available there. So I hope you got some idea regarding data structures. So of course, entire series is important to understand that properly. Welcome back, aliens. My name is Navin Reddy, and in this video, we'll talk about ADT, which is Abstract Data Type. Now, before we move towards ADT, let's talk about data here. Of course, in the previous video, when we talked about what are data structures, we have talked about data. And we also mentioned that in the software industry, everything is about data. So whatever you do, you're doing it for data, right? Now, with this data, basically you get the data from the user, you process data, you also give the output to the user, or maybe you want to store this data in the database for the permanent storage. But the thing is, it's all about data. And whenever we use any language, doesn't matter which language you use, what you do is you store that data in your code somewhere. And to store that data, we use something called a variable. Now, imagine variable as a box and you are keeping your data inside that box. The problem is every box need to have a type. Of course, there are languages which are dynamically typed language where you don't actually mention the type for the variable, but in general, this box will have a type. So that means if you want to store the data, you need a box, which is your variable, and this variable also needs a type to it, or this box needs a type to it. Now, example, let's say if you want to store a number, so we can use something called an integer. Or if you have any other point values, you can also use float or double. Now, it depends upon the languages, how they work. But in most of the languages, we have something in common. We have integer for the normal numbers. We have a float for the point values. And what if you want to store a text? That's why we have string. And in few languages, we don't have all these types. We have limited types. And in other languages, we have many, but that doesn't matter, right? In general, we'll be having a variable and a type to it. Now, all these types are called data types, and they are system defined data types. Or you can also call them as primitive types, is because it's there in the language itself. You can directly use them. But sometimes you want to use some complex data type. And we can create that with the help of some other concepts. Example, let's say if you want to represent a human, or if you want to represent a phone. Now, I love phones, so I'll be using that example. So if we talk about this phone here, now this phone will have a name to it, right? So it will have a name, it will have a brand. Of course, name is model number, then brand, then the configuration, the amount of CPU, RAM, all this are your data, right? So if you want to represent any physical thing in the virtual world, we use objects there, right? Now, in some languages which are object-oriented programming, we do that with the help of objects. Example, in C, we use something called structures. So we can define a structure name, let's say phone, and inside that you can specify what are the properties there. In the same way, in the object-oriented languages, we use something called class. In this class, you create different variables with primitive type, and then the box itself or the class itself is your complex data type, or you can say user-defined data type. User-defined because system is not giving you, we are defining our own type, right? So that's about data and data types. But let's say if you want to store a bunch of data, how will you work with that? And when it comes to data structure, how will you store this data in a proper way? See, what happens is when you talk about primitive types as well, every type will have a way to store data. Of course, that's why we are getting them, right? So example, if you are creating a variable called num. Now, let's say this num is of type integer, and then you are storing a value to it. Now with this variable num, you can perform operations as well. Now what are the operations you can do with integer? You can add two values, you can subtract two values, you can divide, multiply. So you can perform those operations on the number. But let's say you have a string there. Now with string, of course, you will not be adding to string. That doesn't make sense, right? Why you will add two names, let's say Navin and Kiran, you will get a new name. Okay, a lot of parents are doing that for their kids, but that's not the idea here, right? We can't add string, we cannot subtract strings. But yes, with string you can do something else. Maybe you want to see the size of a string. Maybe you want to concatenate two strings. Maybe you want to cut two strings. So string has different operations. In the same way, if you are creating your own type, this will have data, of course, but also you have to mention the operations which you're going to perform. So we have two things, right? We have data and we have operations. Now let's say in data structures, you want to store a bunch of data, as we mentioned, and you want to store, so there's a concept of array. So if you have multiple data, instead of showing them in multiple variables, let's say you have 5 numbers, 2, 6, 12, 21, and so on. Now, if you have all these values, you basically store that in 5 different variables. Or you can create a single array and you can store all the values there. The advantage would be you just have to use one variable name there. So instead of saying A, B, C, D, E, you can simply say nums. You can use any variable, doesn't matter. So what's important is you can use array here. Now when we use array, we are not basically using a primitive type here. We are creating our own type here, own data type, which is an array. Now in this array, basically you should be also able to perform some operation. Example, let's say what if you want to read some value, you want to fetch a particular element, you want to search the array, maybe you want to add an element, maybe you want to delete an element. So this operation should be possible on that type. So in the concept way, when you have a type where you can perform some operation, we call them as abstract, is because the implementation for array changes from language to language. And we don't just have array, right? So let's say if you want to store a bunch of values, we can use list, we can use set, queue. Now when you talk about a queue here, let's say. Now inside queue, we have one more option for that, which is stack. They follow different concepts. So let's say if you want to add an element in the queue, which follows last in first out, which means you have to insert from the end and you will get it from the first. Of course, you can reverse it, you can insert from the start and you can take it from the end. The thing is, you will insert from one end and you will remove from the other end. So that is first in, first out. In stack, it is reverse. You do last in, first out. Example, let's say, to give an example, let's say for queue, we can say a queue which you follow, right? Example, if you want to buy a coffee from a cafe shop, of course, there's a queue there. You have to stand in a queue and then when your number comes, you will get the coffee. So basically the first person who went there first will be getting the coffee first, right? In terms of stack, it is different. So when you keep multiple books, the first book which you can take out is the last book which you have kept there, right? Which is last in, first out. That is your stack. Now, we have different way of implementing in different languages. The concept remains same, right? So when you have a concept and the associated operations to it, and of course with data, which we call them as abstract data type. We also have map, but we'll talk about those things later. At this point, the point to remember is we can create our own types, and which is a concept. And if you want to have data inside that, and also you want to specify what operations you can perform, that is your abstract data type. Of course, in the subsequent videos, we'll talk about how do you create them, how do you work with them, and it will be fun. In this video, let's talk about arrays. So let's say you have a bunch of values, let's say 5 values. Now, instead of storing them in 5 different variables, we can store that in one particular sequence, right? Or one variable you can say. Now in this array, you can store 5 values. So let's say we have this array here, and then this will have a name to it. Now, of course, this data will be stored in a memory, right? And every memory will have something called a memory location. So let's say we are storing this data at a location 101. Now what happens is every time you store a normal variable, let's say a primitive type, let's say int, and depending upon how much size it takes, so every type will have a different size to it depending upon a language, but let's say we have 2 bytes. Now inside your memory, let's say if you create a normal variable which is int a equal to 5, now this particular a variable will take some space in the memory, of course let's say 2 bytes, and it will also have an address to it, right? So every time you, in your programming language, you say, hey, I want a value for a, the program will jump to the memory location by searching for the address and it will get the value. But the problem is when it comes to array, we have multiple values, right? And we only have one address. Now that's tricky. Of course, each element here will take the same size. If you say int take 2 bytes, the complete array will take 10 bytes. Is because every element will take 2 bytes. How will you allocate memory now? That's an issue. So what you do is, the array will have a memory, but that is only pointing to the first location, right? So if you say the memory for this is 101, the first element is 101. What about the second element? Now that's where we have to use something called index values. So let's say the first element is at 101. So it will have an index value which is 0. The second element is 1, then 2, then 3, then 4, right? Now for 5 values, the index value starts from 0 and ends at 4. Now why 0 is because we have a memory allocated, right? 101, which represents the first element. So we don't have to give 1 to it. So what you do is the next element is plus 1. That's why 1, 2, 3, and then you can just get it, right? So 101, let's say if you want to get the third element, you have to say plus 2. That's how you do it. So you got the values, you got the index, and you also got a memory address to it. Now with this array, as we already talked about ADT, which is abstract data type, we should be able to perform some operations. Now what operation you can perform on this array? Now we can perform something called a read operation. So what is read? So let's say you want to get the value of an index number 3. Now what you do in this case is you say, okay, my array name is nums, and then for this nums, I want the value at index 3. So in different languages, we have different representation for this, but let's say this is common one. So nums bracket of 3. Now what your computer will do is it will directly jump to the memory address. It's very simple for that, right? So you will say 101 plus 3, you will get the value. So that's how you do it. Now reading is very easy, and computer takes very less time to jump to that particular area is because the computer knows the memory, right? Because you are mentioning the index value. Reading is good. It's fast also. What about searching? Now this is tricky because when you're searching, you're not searching for an index. You are basically searching for a value now. So let's say from this array, I want to search where is 17. Now in this case, your computer has no idea where 17 is because computer only knows about the memory address. Of course, the values are there, but computer has no idea in which location we have that value and do we even have that value. So what a computer will do is it will start from the first location. So basically you have to write a code to search from the first location. You have to check, is the first one 17? If yes, good, we can exit. No, then you have to jump to the next location. Is it matching? If yes, good. If not, next. Matching, yes, no, next. So basically you have to search each element, right? And let's say the element is at the end, you are searching, you are basically tracking to all the different locations. So this is time consuming, right? What if you have a array of, let's say 1,000 values? To move between these values, it will take some time. What about inserting? Now this will be tricky is because, see, if you want to insert an element, what do you think? Will it take a lot of time? See, if you want to insert the element at the end, that's very simple. You can get the size of the array because we also have to have that option of getting a size of the array, right? So let's say you have 5 values. You will simply jump to the 6th location, which is index 5. And then you will say, okay, I want to add a value here. Let's say the value is 21. And you can add the value. It's very fast. But what if you want to add a value in between? So let's say you want to add that value at the 2nd location. So after the first, you want to add the new value. Now what you will do is, you don't have a space there, right? You can't simply create a new space. You can create space at the end. So what you do is you basically have to move all the elements, and it's not like you can simply move the elements. What you do is create a new block. So move the second last element now to the last block. Then again, you have to move every element one by one. Then you can add your value to the 2nd location. So if you are inserting at the end, that's fine. But if you're inserting in between, that will take a lot of time, and that depends upon the number of elements after the position which you're adding. What about deleting? See, deleting from the end is always welcome, is because you're not affecting your array in total. But what if you want to delete a particular element from between? Now, you can't simply delete from the between, right? You have to delete the end block. But how will you move? So again, when you want to delete this, just replace all the values, right? So that's tricky. So it will take a lot of time depending upon how many elements you have after that index value. Now, why we are talking about all this thing? Array was simple, right? We can perform the operations. The important thing here is time taken for each operation. And it's not about CPU time. If you're thinking, my computer is super fast, it will be happening very fast there. See, in the world, we have different computers, and different computers have different CPU power, different RAM power, different configuration. And that's why let's not calculate the speed of a code or the algorithm by the actual runtime. Important is the number of steps it takes. Example, let's say if you want to insert the element at the end, that's good. If you want to insert the element in between, that will take a lot of steps. It's because you want to move the elements, right? Now, in the upcoming videos, we're going to also talk about time complexity, which is a very important concept, something called big O notation. But yeah, we'll talk about that in detail later. I know you're excited to hear that, but important thing is, when you write a code, think about the number of steps your code takes, because that defines your time complexity. And if you say my algorithm is good, it should be time efficient. Okay, so for the same particular operation, you can write two different codes. Example on the screen, if you want to print, let's say 10 numbers from 1 to 10, and maybe you just want to print the even numbers, we have two options there. Which one is good? Of course, you will let me know in the comment sections, but the code which is not iterating between all the values is good, right? So that's how you define how your algorithm is good. Now, we can also expand the array example. Let's say if you have a sorted array. So let's say you have an array and this is sorted by default. So every time you insert the element, it gets sorted by default. You don't have to mention where you want to insert this. Example, let's say you have a bunch of values here, all are sorted, and now you want to insert the element which is 11. Now, if you want to insert 11 there, where it will get inserted? Of course, it will search for the location. Let's say we have a number 9. It will get inserted after 9. Now the question is, how do your code knows where is 9? So you have to basically search. You have to match. Is it greater than? Is it greater than? Is it greater than? And then you have to insert. So that will take a lot of time. But what if you're inserting in between? You have to shift all the elements. So that's about the array and a basic introduction of time complexity. We'll discuss that in detail later. In this video, we'll talk about time complexity. See, the thing is, in the previous video, we have talked about algorithms, right? Now, the thing is, if you want to build an application, basically we are trying to solve a problem, right? And every problem will have multiple solutions. So the steps which we write to solve that problem, that's what we call algorithm. Example, let's say if you want to cook something, you follow some steps, right? Now those steps are your algorithm. Example, if I want to record a video, we do multiple things. We prepare the content, we set up this camera, mic, and then we start recording, then we edit the video. So there are multiple things involved. In the same way, if you want to solve any problem, we have to follow some steps, which we call algorithms. And the thing is, for one particular problem, we don't have one solution. We have multiple solutions. And we have to pick the best one. Now question arises, how will you choose the best one? So when you say best one, what exactly it means? So let's say when I run this application, I want my application to use less memory. Or maybe when I run this application, I want it should take less time. Or maybe both. And that's why we have this term called algorithm analysis. So basically you have to analyze your algorithm so that you can make it more efficient. Right? Of course, as a developer, first focus is the product should work, and then you think about optimizing it. But when you say optimizing, you can optimize in two ways. One, think about the space complexity, and second is the time complexity. Space complexity simply means, can we use an algorithm which will take less memory? And time complexity means it should take less time. But there is one more problem here. And the problem is, how will you calculate the time, or how do you specify the exact time? Because every machine will have a different output, right? So if you are testing the algorithm in your machine, it might give you different time. And then the moment you test this in your office machine, it will give you a different time. So that's not the best thing to calculate the number of seconds it takes. But what you can do is, there is a way you can calculate with the help of steps. But before we go there, let's focus on two algorithms here, and then this will make much more sense. So the algorithm which we're talking about now is the searching an element in a sorted array. So in the previous video, we have talked about array, and then we have also talked about the sorted array. So in sorted array, by default, all the elements will be sorted, right? Now what I will do is, I want to search a particular element from this array. Now there are multiple ways of doing it. Let's talk about the two. So basically we have an option of linear search, binary search, or many more, but let's focus on this two. So what exactly linear search and binary search is? Let's talk about that. So what is linear search? So let's say you have an array with you. Okay, so this is your array, and in this you have multiple values. So let's say I'm going with few values here. Let's say 5 values, and then I'm going to write, let's say 5, 7, 9, 12, 17. So we got this 5 values here, right? And then I want to search a particular element. Now this is sorted array because you can see all the elements are sorted. We got 5, 7, 9, 12, 17, and I want to search a particular element. Let's say I want to search 12. Okay, I want to search this element. So maybe there is a target value which I want to search. In this case, the target value is 12. So I want to search 12, right? And then this is an array. So what we do in the linear search is you go one by one. So what you do is, in fact, we have talked about this in the previous video as well. So we'll make it a bit faster. So what you do is, whatever your target value is, you will compare that with the first element. If it is matching, great. Otherwise, you will move to the next element. Otherwise, you will move to the next element. Otherwise, you will move to the next element. And I mean, of course, at this point, we don't have to go to the next element. So here, we basically got the value. And once you got the value, you can return the value, right? Now there's a problem here. The problem is, what if the element is not there in the array? So of course you have to reach till the end, okay? What could be the best scenario here? So let's say you are searching for an element. Let's say element is 5, and now we know element 5 at the start itself. So when you have the element at the start, it will take only one step. But what if you have element at the end? So it will take the steps depend upon the length of the array. So let's say if you have 5 values, it will take 5 steps. When you have 10 values, it will take 10 steps. When you have 1 million values, okay, that's huge. Let's talk about 1,000. So let's say when you have 1,000 values, it will take 1,000 steps. That's tricky, right? Now the problem is not it is taking 1,000 steps. The problem is, as your size increases, it is also increasing the number of steps to search. Okay, that's one parameter you have to remember. So that's a theory, right? Now let's understand that with the help of a pseudocode here. So you can see I'm writing a pseudocode. Why pseudocode? Why not some programming language syntax here? Is because we wanted to make it generic so that you can, doesn't matter in which language you work, maybe C, C++, Java, JavaScript, Python, maybe COBOL, your choice. This could pseudocode remains same, right? Now this can be function, procedure, doesn't matter. So what I'm doing here is we have a procedure, right? It can be a function, and the name of the function here is the linear search, okay? Now we are accepting a list of items. Now this is your array. The name of the array is A, okay? And then you are also passing a target, what you're searching. So in this case, we were searching for 12, but doesn't matter. So you have an array with multiple values. It can be 1 value, 10 values, 1,000 values, doesn't matter. And then you're also passing a target, what you want to search. Now you will go inside this, and then for the first thing you will do is you will want to find the length of the array, because of course you should know, right, till when you have to search. So you got a length which is stored in the n, and then we are going to basically going from 0 to n minus 1, because when you start with 0, you have to end with 1 less, right? So if you have 10 values, you will go till 0 to 9. So you will go from the first value to the last value, and then you will search if the target which you are searching is equal to the current element where you are searching. So when you're searching for the first element, there's the first element here, target is matching. If yes, you're good, you can simply return the value. But what if it's not matching? It will go for the next iteration, next value. Is it matching? Yes, good, return. What if it's not matching? Next value. So basically you have to search each value till you're not finding it. So that's basically a pseudocode here. And what if there's no element? Example, you have 5 values and you're searching for a value which is not there. You can return -1 by specifying, hey, the value is not there. This is simple linear search. The code is small, but then the time complexity, which is the amount of time it takes, is huge. Okay. Now let's go for the second approach, which is your binary search. Now what happens in binary search is it's very simple. Basically, it's not that simple, but let's say. So what you do is you have an array, again a sorted array, and let's say we have multiple values here. I'm not sure how many lines I'm going to draw, so let's count it later. So let's say we got 5 here, again 6, 8, 9, 11, 13, 17. Okay, so maybe I love odd numbers, so it doesn't matter what values you have there. So we got 1, 2, 3, 4, 5, 6, 7. So we got 7 values, right? Now what you do is in binary search, now since this is sorted, if you're searching for a particular element, let's say I'm searching for 8 here, okay? And we know 8 is here, we know it, but computer has no idea where 8 is. So how it is going to search? Now in linear search, what we were doing is we were jumping basically from value to value, checking this, and then goes on. So now why this call is binary is because you divide your array into two parts. That's the binary is. Now how you do it? So basically what you do is you give a starting point and then you give a ending point. And of course, every element here will have an index value. So in total here we got 7 values, right? Which goes from 0 to 6. Now what you do is you first divide your array into two parts. And to do that, we have to find a mid value. Okay, so even before you divide, you find a mid value. So how do you find a mid value? So mid value is equal to the starting position plus ending position divided by 2. Okay, now this is 6 divided by 2, which is 3. Okay, so your mid now is 3. And this is your mid. Okay, now basically you check with the mid. Okay, so you always check with the mid. Is the value which you are searching for, which is here, is it matching with the mid value, which is 9? No, it's not matching. But is it less than or greater than? If the value which you're searching for is less than the value which you got as a mid value, then the values after the mid value is of no importance, right? So this values here has no importance. You can directly skip them. So you can divide your array into two parts. So you got the first section here, which is 5, 6, 8, 9. And then you got the second section here, which is 11, 13, 17. So what you can do is you can basically skip this part, or maybe I will just do that with a color. Now we can skip this part. We don't need this value. The value which you want to focus on is 5, 6, 8, 9. So what you do now is you make your mid as the end, okay? Because we have shifted to the left part of the array. Now, of course, when you shift to the right part of the array, in case, then you shift your starting value. Now here you got S and E again. And then what you do is you again check your ending, you will find your new mid value. So again, S plus E divided by 2. Now S is 0, 0 plus 3 is 3 by 2, which is 1. Of course, you can say 1.5, but let's say this is 1 equal to 1. We can apply a float function to get the nearest integer. Okay, so we got 1 here, right? So what you do is you check. So this is your mid. Again, you check. Is it matching with the value? No, it's not matching. So 8 is not matching with 6. Then what you do? Then you again divide your array into two parts. But then which one you have to skip now? Now we know that the mid is 6. So we have to jump to the next value. I mean, we have to look at the right side value. So 6 is less than 8, right? So we have to look at the right side. So now what we're going to do is, we have divided into two parts, right? So now we can skip this part and focus on the right side now. So your starting position has been moved here now. Now this is your S and you got E. So again, you will find a new mid, which is S plus E divided by 2, which is 1 plus 3 is 4. 4 divided by 2 is equal to 2. So your mid now is 8. Now is it matching? Yes. Okay. And that's how you got the value. Now, if you might be thinking we have done so many steps, right? Not exactly. Basically, at the start itself, we have removed half of the array, and which is very important, right? So let's say if you have an array size of 1000, at the start of the first operation, you have removed 500 values. For the next operation, when you do it, you remove 250 values. So the number of operations which you are doing with binary search is less, right? And that's how you know that this is better than the linear search. Of course, in linear search, if the value which you're searching for is the first value, it's very fast, right? It will take a lot of time for binary search. But in general, binary search works faster. But how do you do that? So with this theory, let's talk about the practical implementation here. So let's look at the code here very fast because we have already done the theory here. So what you do is you basically write a function, let's say binary search, and then you pass a list of values, right? And then you also pass a target, same thing we have done in the linear search. And here, then you go with the left and right. So basically we have mentioned the start and the end. Here in this, we are taking left and right. Left starts with 0, as we mentioned, the starting starts with 0. Ending ends at the last value. Okay, we have done that. And then you run a loop till you find the value, of course. Then what you do is you check the mid value. So this is the mid value. We have done that. Mid is the starting point, ending point divided by 2. And then you check, is the mid matching with the target? If yes, you're done. You can simply return the value. Otherwise, we have to do something more. Then you check if the value which you got, which is mid value, and the target, if the mid value is less than the target, in this case, you will focus on the right hand side. Okay. So basically you have to shift to the right hand side. So your starting point will shift. And we have discussed that here, right? Your starting point will shift. And then what if the mid value is greater than the target value? In that case, you will shift to the left position. Okay. So that's what we have doing here. And then every time you do that, you run the loop again, you find a new mid value. And that's what we have done multiple times, right? We found the mid value 3 times. In the same way you're going to do here. And then at the end, you will get a value. If it is not if it is not there, you will simply return -1 as we have done before. So basically by doing this, what we are doing is we have seen 2 algorithms, right? Now we have to find the time complexity. Now what exactly time complexity is? It's not about number of seconds it takes to run your code. It's all about this. So time complexity simply means the measure of how the running time of an algorithm increases with the size of input data. So basically, let's say when you are testing a particular algorithm, you're testing for let's say 10 values or 20 values. But what if the values goes up? What if you have 1,000 values? How will it affect your time? Will it increase the time in linear section? Let's say if it takes 5 seconds for 10 values, will it take 10 seconds for 20 values? Or will it take more? Or will it take less? Okay. Or let's say you have 1 million records. Will it take 1 million seconds? That's the question we have to answer. Okay. Now, how will you do that? And that's where we have something called big O notation. Now, what happens in big O notation is we use this particular concept to understand your time complexity of your algorithm. If someone says, hey, your algorithm is not fast enough, you have to first find the big O notation of it. So why big O is because it is represented with the help of O, the big O. In bracket, you mention the order of n or something. So basically, it is also called order of or big O notation. Anything will do. So how do you represent that? You represent that with something like this. So we have O of, and then the value which is 1 will keep changing. So there are multiple things here. You can say we have O, big O of log n. We got big O of n. We got big O of n log n. We say big O of n square, which is quadratic time. We got 2 raised to n. We got n factorial. Okay, so we got all this notation. But how do you find this? Okay, now this is tricky. So of course, in this particular video, you will not understand everything, but let's start with the basic. Now let's talk about the linear search. Now, if you go back to linear search, what we were doing there. Now in linear search, when you have 5 values, you take 5 steps. When you have 10 values, you take 10 steps. When you have 100 values, you take 100 steps, right? But let's say that is for searching, right? What about reading? If you want to read a particular element from the linear search or from the array, it's very easy, right? You specify the index value. Let's say the index value is 0, 1, 2, 3, 4. And then you specify, hey, I want the value at index 2. So let's say you say nums, which is the name of the array. And when you say 2, basically what you get is 9. It's very fast. So it doesn't matter what is the size of your array. It can be 1 million records. The time taken to get a particular element with the help of index value is constant, right? Because computer knows where that memory is. So in that case, I can say the big O, the time complexity for this is 1 because it is constant. Okay. Now see, it's not about one step. If you're thinking just because I've mentioned that it is only 1 step, it can be 3 steps as well. So let's say if you are reading a particular element and maybe behind the scene it takes 3 steps. It doesn't matter. It's constant, right? It can be 1 step, 3 steps, 10 steps. It should be constant. If it is constant, you can say O of 1. But what if you are searching an element? So if you have an array size of let's say 10, it takes 10 steps. Now you'll be saying, hey, what if your element is at the start itself? Of course, it will take 1 step. But we have to go for the worst case scenario here. The worst case is, what if the element is at the end? What if the element is not even there? It will take 10 steps. And that's why we can say the order, the big O notation here will be n. What is n here? The number of elements in the array. As it increases, the time also increases, the time complexity. I'm not talking about the actual seconds, okay? So that's your linear search. Now coming back to the binary search, what could be the big O notation for binary search? See, the thing is, as the number increases, it will not directly increase the number of steps. Reason for that is, let's say we have 7 values. How many steps it takes? Let's say 3 steps, because we have to find the mid value 3 times, right? What if the size increases to double? So let's say from 7, we got 14. So what do you think? How many steps will increase? What if I say only 1? Reason being, even if you have, let's say, 14 values here, let's say we have so many values, at the start itself, it will be half, right? You will get 7 values after 1 step. And then you basically increased 1 more step to find the mid. So that means when your value increases, it will also increase the number of steps taken, but not exactly n. Because in the linear search, if your number of values increases by 10, it will increase 10 steps. Here, as the number of value increases, it will not increase the steps in the same sequence. So what we can say is, we can say it is something between constant. It's not exactly constant, but it is between the O of 1 and O of n. So it is between these two. And what comes between these two is O of log n. Now what is log n basically? So log n basically means we have a base 2 here by default. Okay, so number of steps it takes. So what exactly this n here? So let's say we have 8 values here. So when you say log 2 of 8, it will give the value which is 3. Okay, now why it is 3 is because log of 8 is simply means it will take 2 multiply itself 3 times to get 8. Okay, so as the number increases, let's say now instead of 8 values, we got 16 values. It will give you 4 because it will take 2 to multiply itself 4 times to get 16, right? So it will give you 4. That means as your number of value increases from 8 to 16, it will only increase 1 step, right? And that's why the binary search is log n. So your linear search is O of n and your binary search is O of log n. So which will take less time, the log of n, okay? And you can see the graph here as well. So this is elements, the number of elements you have in the array, and this is the number of operation it takes. Okay, so number of steps. So if your algorithm is following the constant time, it means it's here. It doesn't matter how many values you increase, it will be constant time. Log n is similar to, it's almost same as constant, not exactly same as constant, but it will take less time. So you can see log n is mentioned here. It's there, the wave is there, you can't see it, it's there. So what if you go with big O of n? So as your value increases, your time also increases, right? But there can be some worse scenarios as well. There can be some other algorithms which you implement, which might take n log of n, which is worse than O of n. There might be some algorithm which will take O of n squared, which is worse than the O n log n. So basically, if you want to build an algorithm, try to make sure that you are here. If you are here, you're good, okay? If you are here, it's okay. If you are here, try to make it better. If you are here, that's the worst scenario. That means you're building an application which is not scalable. The moment you have 5 users on your server says, I'm good. The moment you have 1,000 users, it will struggle. Okay, so make sure that you, whichever algorithm you write, you follow this. Of course, in the upcoming videos, we'll work on some more algorithms. We'll see which one matches there, but you got the idea, right? So the time complexity simply means this definition, the measure of how the runtime of the algorithm increases with the size of the input data. And to represent that, we use big O notation. In this video, we'll talk about the practical implementation of linear search and binary search to understand the time complexity, which we can represent with the help of big O notation. Now, basically, we'll write 2 examples here. In fact, we will also do binary search in 2 ways, just to understand how thing works, and then how will you find the amount of time it takes, not in seconds, of course, but the number of steps, right? So we have discussed about big O notation, which is the big O of 1, big O of n, big O of log n, right? But we also have multiple options, but then at this point, let's focus only on 2 with the help of 2 algorithms. Linear search, which is big O of n, and binary search, which is big O of log n. Okay, so what I will do is I will write this code in Java, and of course, we'll not be doing very complex stuff in Java. If you know any other language, you can follow this. So I'm using an IDE, and again, you can use any IDE. I'm using IntelliJ IDEA. So in this, I have a project. I will simply create a file here, and we'll name this file as demo. So we got a file called demo.java. And this is where basically we'll also have our main method. So if you're coming from different languages, you know we also have main there. So we have a main. Now let's start with the actual work. Imagine this as just a template to run the code. We'll write our code here. Now what we want to achieve. Now basically we will be having a list of elements, and we want to search element out of it. Okay. Now the size can be anything. It can be 5, it can be 10, it can be 20, 100, doesn't matter. Initially, we'll go for less number of values, and then we'll also see how do you work with thousands of values and how do you find element. And then how much steps it takes to search a particular element there. So what I will do is, first of all, I will create a simple array here, and we'll say this array name as nums. So let's say we got an array, and then I will also specify the initial values to it. And since we are going for a sorted array, of course, when you talk about the linear search, we don't have to specify a sorted array. It can be applicable on any kind of array. But when it comes to the binary search, you need to pass a sorted element array or a list, you can say. So here, I will simply assign some values. Let's say we got 5 values here, and then I just want to keep it simple with those values. Of course, you can have any value, doesn't matter. I'm just trying to keep it simple. Or maybe if you want, I can say 7, 9, 11, 13. That's my love for odd numbers. Okay, and I want to search a value. So whatever value I want to search, we can also specify here. Now we can use any variable name, but we have already used target as a variable, right? When we were discussing the theory. So we'll say target equal to, and we'll mention the target. Let's say I want to search an element which is 11. Okay. So this is what I want to search from this particular list. We can do this with multiple algorithms. We can use linear search, binary search, or whatever you think about. But let's go for linear search initially, and then we'll look at the binary search. Now, how do we do that? So what we can do is we can say, I want to get the result. Okay. I want to find this 11 in this list and give me the index number. I don't want anything else, just the index number where it belongs to. Okay. So who will give me that? So what I can do is I can assign this star to someone else. Let's say linear search. Now this is another method which will give the value to us. So I don't want to populate everything in this particular main. Main will simply say, hey, I got these two things. I got the list, I got the target value. You tell me which index this value belongs to, or if you don't have this value in the list, also let me know. So linear search will say, okay, accepted the challenge. It will accept two things. First, nums and target. Why you have to pass nums? Of course, linear search will say, I will search, but tell me where to search. And target will say, this is a value you want to search. Now, the thing is, we don't have this method yet. So what I will do is I will just use my IDE to generate. Okay, so I will say more actions, create this method. And you can see we got this method. I don't want this to be private. I want this to be public. And that's it. What you're doing is you are calling another method. At this point, since we are returning a value, what we can say return -1. Okay, nothing fancy. I just want this to work, and that's why I'm returning -1. Okay, and what if you get the result? Of course, if this value is not there in the list, it will return -1. Otherwise, we can return the index value. So whatever value you get, you can simply print here, and you can say element found at index. And then you can specify the index value here. So let me just give a space. So you can specify the result here. So whatever index is there, okay? And let's run this code just to see. I just want to make sure that everything is working. Let me just run this code. And you can see we got the answer. And also I want to move this to right-hand side. Okay, so it looks good. So you can see the output says element found at index -1. That's weird. It's just that we are returning -1. That's what is printing -1. What we should be doing is we should be checking if the result is not equal to 1 or not equal to -1. So this statement, it should print only when the result is not -1. In case it is -1, that means the element was not there. So I can simply print element not found. Okay. And now if you run this code, it will print element not found because we are not even searching, right? But we'll search now. So how do you search? It's very simple. So what you can do is you can use a simple loop here. Okay, nothing fancy, again, a simple loop. And in this, you're going to iterate. So we have seen the linear search, right? So if you remember the theory, we have talked about this. So basically we'll search from the first element, right? So we are going to start from 5 and then we'll look for, is it matching? Is it matching? Is it matching? Of course, the values are different, but we'll basically search for each element. In the same way, in linear search, if you want to move, you have to use a loop. So it will start from 0 and will go till the nums of length. So basically, if the number of values you have 5, you have to reach 4. Okay, so that's why we have saying less than, and then I++. Now that's a for loop, right? So in this for loop, you don't have to do much. You simply have to check So whatever element you got, the current element which you're focusing on. So in the list, we have 5 values. If you're focusing on 5, we'll check if 5, which is the first element, is it matching with the target? If it is matching with the target, our job is done. We can simply return the index, the current index. So let's say if you're searching for 5 and then you got 5, return 0. Your job is done. That's what you're doing here. Okay, and that's it. Okay, it should work. That's what we're expecting. Linear search is so simple. If you run this code, it says the element found at index 3. That's right. So this is 0, 1, 2, 3. And our job is done. Okay. What if you're searching for, let's say, 5 in this case? It will print at index 0. And that's what we got. So this is working. But what if you're searching for something, let's say, 77, which is not there in the list? If you run this code, it will say element not found. So linear search is working, right? Now we can do the same thing with the help of binary search. Now let's see how binary search works. So what I will do is I will just write a code here, which is public. In fact, I will just copy paste the code, not a copy pasting, but reusing the code. I can simply copy this code and paste it here. Now, if you're coming from Java and if you're getting confused why I'm getting a static method, why not non-static methods, it's because I don't want to deal with objects here. Okay, just want to keep it simple. So we got a static method and a binary search. The thing is, only method name will change. The parameter will remain same. In binary search also, you pass a list and you pass a target. The algorithm will change. Of course, it will return -1. That is not something which is changing. But what we will do inside this. Now, if you go to the board here, what we have done is if you have a list of values, if you can see we have a list of values here. Now, initially you have to specify the starting point and then you have to specify the ending point as well, right? So starting and ending you have to specify. In this example, we'll say left and right, okay? Because that's how that makes much more sense, right? Left and right, starting point is left, ending point is right. And then you will find a mid. Every time you find a mid, if it is matching, that's great. Otherwise, you have to basically skip the number of elements, which is in the other section, okay? So how do we do that here? So what I can simply do here is, in fact, I will just, for my reference, I will also have those values here. So I will say 5, 7, 9, 11, and 13. Okay, and the value, let's say, which I'm searching for, this time let's have the value. So let's say I'm searching for 11. Okay, so what I will do is, when you're searching for 11, first of all, you have to specify the starting point. So I will say left, in fact, int left is equal to, now left is a starting point, right, which is 0. Then int right, which is the ending point, which could be 4. But then why to hard code it? What you can do is you can say nums.length -1, because nums.length will give you 5. You have to say -1, which will give you 4. So now we got the starting point, ending point, and then our journey begins, right? So what are we going to do here? So we'll use a while loop here. Now inside this while loop, what I'm going to do is I'm going to check if my left is less than equal to right. We'll check if left is less than right, because that's what we want, right? Left should be on the left hand side, which is the smaller values. And then here, what we'll do is we'll find the mid. Okay, that's the journey we are going to start. So mid is basically your starting point, right? Which is left plus right. And we want this to be in the bracket so that we can divide. So left plus right divided by 2. Okay, that's how you find the mid, right? Now, once you got your mid, you can basically check if the nums of mid, is it matching with target? If it is matching, that's great. We can simply return the index, which is mid. Of course, right, mid is representing an index here. If it is not matching, then we have to change the value of left or right, depending upon what you got in the mid. So what we'll do is we'll say if, else if. Now, how do you check? So we can check if nums of mid is less than the target. So let me take this up as well. Yeah, so if nums of mid is less than the target. So let's say when you talk about this elements and then we are searching for 11, right? The mid which we got is 9. If the 9 is less than the 11, we have to shift our left, right? So this left, which was representing 5, will shift here now. I mean, not even 9. We don't have to even consider 9, right? So what we can do is we can say left will shift to mid plus 1. Okay, so basically now we have two values, 11 and 13, which we are going to focus in the next iteration. But what if you are searching for something else, which is in this side? Let's say we were searching for 7. In this case, we have to shift our right. So right is mid minus 1. So basically, let's say if you're searching for 7 here, you got a mid as 9. What you will do is you will say, okay, so the value is less than the mid, so we have to skip this too. the focus will be only on 5 and 7. That's what we have done here if you're searching for 7. Okay, I think this looks cool. Our job is done. Let's verify if things are working out. The only thing that we do is, instead of searching for a linear search this time, we'll go for a binary search. Let's run. It works. You can see it says found index at 3. And what if you are searching for, let's say 17, which is not there? Run, it says not found. Let's search for 5 and it says it works. You can say index 0. So that means you can use linear search or binary search, both works. But what if you want to really see how many steps it is getting? So what I will do is, let me just say this is result 2, which is binary search. And let me also say result 1. Of course, I'm not going to use both the things. I just want to call both the methods. Okay, I'm just going to use result 1 because if linear search is able to find it, binary search will also able to find it. Okay, let's print result 1 here. So I just want to call both the methods. That's the reason I'm using result 2, but result 2, we are not using it anywhere else. Okay, so let's do this with both the algorithms and you can see both will print the same thing. Oh, we are not printing the second part. Okay, doesn't matter. Both will give the same result. But what I'm really concerned about is the number of steps. So what I'm going to do here is, let's calculate the number of steps it takes. So I will say for linear search, steps is equal to 0 initially. And every time the loop iterates, okay, I will simply say steps, number of steps taken. So steps plus plus. And then I'm going to print, just before return, I'm going to print steps taken by linear, colon, and I will print steps. The same thing I want to print here as well. What if there's no element found? So this will never be executed, right? Okay, we have to put this into a curly brackets. Cool. So we are printing the steps here. The same thing I think we should do for binary search as well. So here I will say int steps is equal to 0. And every time you iterate in this loop, you will say steps plus plus. And then basically here, you will print the same statement. So I will just copy this. So we'll print before returning the value. But here we'll say binary. And we'll also print this before returning, just to cover all the cases. Okay, and let's see what it does. Run this code, and you can see for 5 elements, linear search is searching in 1. Okay, reason being, we are searching for 5, right? I think we are searching for 5. Let's search for 11. Okay, in some cases, linear search works well. Run, and you can see the linear search takes 4 steps. The binary search takes 2 steps. That's crazy. Run again. Of course, you will get the same output. But what if the values are higher? Let's say I have more values here. Let me add 10. Let me add 1, 2, 3. So now we have more values, right? I don't know how many values we have, but let's say if I run this code, the linear search takes 8 steps. Binary search takes 3 steps. Okay. But what if you have 1,000 values? Now, how do you check 1,000 values? Now that will be tricky. So what I'm going to do is, let's add some random values here. Let me create an array of size 1,000. I don't want to specify my own values. Let's say 1,000. And the value which I'm searching for is, let's say 500. Okay, it's somewhere between, or maybe I will say 900. Let's see what happens. So I have a value which is 1 to 1,000. I'm searching for, I have 1,000 values in the array and I'm searching for 900. But by default, the value will be 0. Okay. Example, if you search this, it will say not found. But look at the number of steps. Linear search takes 1,000. Binary takes 10. And what if you have more values here? Run. Linear search takes 10,000. Binary takes 4. And look at the size. Example, let's say if the size is 8 and by default, all the values in the array is 0. So anyway, it is sorted by default. And you can see if I run this code, which says 8 for linear, 4 for binary. But the moment I double the values, look at the steps taken by binary is only 1 extra. Linear is double. If I double the value again, 32. So every time you double the value, binary search will take only 1 extra step. And that's why we say it's a big O notation for this is log n. Okay. So in this case, the binary search works better than the linear search. Now the same code you can write with the help of binary search as well. Example, instead of using a loop here, I can simply comment the entire section and we can replace this with a recursive function. The only thing is in recursive that the changes you will be doing is, in recursive, you're going to call the same function again by changing the values. Let's say you have this big array and then you're done your first search, you found the mid. Now, the moment you found this section, let's say this part or this part, whichever is matching, you will remove the other half. And again, you will run the same binary search on this list. And then again, you will break it down into two parts. You will remove one and you will run the binary search on the other one. So in binary search, basically, if you want to make it recursive, you have to pass two more things, which is int left and, okay, not int left. You have to specify the left and right. So you will say 0 and nums.length -1. So basically you have to specify the start and the end. And every time you call binary, you will simply accept those two things. You will say left and right, so that you don't have to specify them here. In fact, instead of removing it, maybe you want to refer this later. I'll just come in this section. Now, since this is a recursive, you don't need a loop here, right? What you can do is you can check if the same step, left is less than equal to right. If this is a scenario, what you will do is, of course, you have to find the mid. I will just copy this code. This is where you're finding mid. And after finding the mid, you can basically also check the same logic. This is a logic you're going to use. The changes is, we are going to change in the else part, I mean the if else part. Let me uncomment the entire section. The changes you're going to do, let's not print the steps. Now we know the steps, right? How many steps it takes, but I'm just trying to convert that into a recursive function. So you will return mid here. There's no problem with this. The changes happens in the else if. So in the else if, instead of doing this, we are going to basically call the binary search once again by passing the same nums, and then you will change the target value now. So you will pass target value. So you have to pass nums and target value. Then you have to pass the left value. Now what is left? So in this case, we have to change the left, right? Left will become mid +1 and right will remain same. Right will remain right. But here, again, we have to make the changes. Else part, instead of this, left will remain left and right becomes mid -1. So basically what you're doing is you are changing the values like this. If you have this list of values, you break it down into two parts, again, after checking. And then you're again calling the same binary search with the new values. Okay, that's what we're doing here. So let me remove the extra curly brackets just to make the code look good or short, basically. And that's it. This is your binary search. Let's see if this works. Let's rerun. And it says not found because, yeah, of course, it's not found because we don't have that value. But yeah, this is the code for the binary search with the help of recursive. Now there's one more thing. You can try with different examples. What you can do is you can take a array of 1,000 values and add random values. So in Java, we have this random class. You can add the values and see how much time it takes. In this video, we'll talk about the sorting techniques. Now, basically, we have talked about the big O notation, right? And now we know that if you want to judge the algorithm which you are writing, you have to make sure that you are using an algorithm which is efficient in terms of time and space as well. We are focusing more on the time complexity, where as your data increases, it should not increase your time exponentially. So we have seen different levels of time complexity, and we want to be into that lower zone, not on the upper zone, right? Now, when it comes to understanding different algorithms, we have to go for some inbuilt algorithms, right? Or some old algorithm which normally we use. So sorting, so we have talked about searching. Sorting is one of the way you can learn more about algorithms and how do you make it more efficient. Also, in the real world, we do use sorting a lot. So let's say when you say you want to search something on the internet, or maybe you want to buy something on the Amazon, you do that sort by price, sort by reviews, right? So you do that multiple times. So sorting is majorly used. So there are a lot of different sorting techniques available. So we'll try to understand them. Not everything or not every algorithm, but let's try to understand few of them. Now, if we talk about these algorithms, some algorithms are easy or simple to understand, but they are not time efficient. And then there are some algorithms which are good in terms of time, so they are time efficient, but they're not simple to understand, okay? So we have to do a trade-off here. Now, which is the best one? That depends. If you have less number of elements and if you're learning for the education purpose or to understand how sorting works, then we can talk about those algorithms like bubble sort, selection sort. And then there are some algorithms which are a bit difficult and they are very efficient when you have huge amount of data. Now, what algorithm I'm talking about? So when you talk about sorting, there are different options available. So we have bubble sort, selection sort, insertion sort, merge sort, quick sort, counting sort, radix, heap sort, bucket sort, and there are multiple sorting techniques. The famous one are bubble sort, quick sort, selection sort, insertion, and then merge sort, if I'm not repeated that multiple times. So let's start with the first one, which is bubble sort. Now, bubble sort is not efficient, but it is simple to understand, so that gives us a starting point. When we talk about bubble sort, why do we use it? So let's say if you want to sort different elements. So let's say we have this list in front of you. The numbers are 8, 6, 9, 2, 4, 5. Now, if you want to basically sort them, how will you do it? Now, of course, we don't have a magical way where you can find, hey, this is the first one, this is the second one. So what you do is you basically try to use some algorithm like bubble sort to sort it. In this, what you do is you basically create a bubble. Now, what exactly this bubble is? Take one element, put that into bubble and shift it to the end. Okay, now that sounds weird, right? So let's do step by step. Now, when you have this value, let's say you have 6 value in front of you, you can put them in an array like this, and then you have provided the index values. Now, if you want to do this sorting on this, of course, we want ascending sorting here. So basically we want 2 at the start, then 4, then 5, then 6, then 8, and then 9. That's the sequence we want. But how will you get it? So what you do is you compare 2 values at a time. So let's say if you put 6 people in front of you and you want to sort them according to their height. So what you do? Of course, you will compare 2 people at a time, right? That's how you sort. And then you will try to swap them. So how exactly it works? So let's say we have these 2 values here, 8 and 6. And then what you do is you want to make sure that the biggest element from this particular array in the first iteration goes to the end. Okay, so the way you do that is first you compare the first 2 values. Now, these are your first 2 values when you're comparing it. If the first value is greater than the second value, you basically need to swap. Okay, swapping is very important here. So you have to first compare the first 2 values. If the first value is greater than the second value, then you have to swap. And then you basically shift your pointer to the next 2 values. Okay, done. We are done with the 6. Now let's go for the next 2. The next 2 is 8 and 9. If the first value is greater than the second value, you have to swap. In this case, they are not. So the first value is less than the second value. So what you do is you simply say skip because there's no swapping needed. Then you go for the next 2 values. The first value is greater than the second value. So of course we have to swap. And then again you shift your values. Next 2 values, again you will compare. The first value is greater than second, swap. Then again you will compare the next 2 value. The first value is greater than second, swap. So basically after the first iteration, you got the biggest value at the end. But is it sorted? Unfortunately not. You need to do this operation one more time. Actually, not one more time, multiple times till you get this sorted. Now, this also depends upon the size of your elements or array. Now, in this case, the first 5 values are still unsorted. The last one is done, so we don't have to touch the last element. So in the first iteration, if you're going for 6 times, the second iteration, you can go for 5 times. The third iteration, you can go for 4 times. So let's see how that works. Now, after the first iteration, we got the 9 value at the end. Now what you do is, again, you repeat the same steps. Compare the first 2 values. Is it required to swap? In this case, no, we can skip it. Next 2 values, is the first value greater than second value? Yes, swap it. Then again, you go for the next 2 values. Is 8 greater than 4? Yes, swap it. Then again, next 2 values, 8 greater than 5? Yes, swap it. Now, in this case, what happened is, after the 2 iterations, you got the 2 biggest values, which is 8 and 9 at the end. Now we know that those 2 values are sorted, but what about the other values? Those are not sorted, so let's sort them. Again, you have to repeat the same steps. So you have to say 6, 2, which is 6 is greater than 2. Again, we have to swap it. 6 and 4, 6 is greater than 4, swap it. 6 and 5, again swap it. So now, after this iteration, you got 3 values, 6, 8, 9, which is sorted. But what about the other values? They're still unsorted. I mean, we know they are sorted now, but your algorithm has no idea if they're sorted. Okay, now this is tricky is because your algorithm goes from start to end. Okay, it will not check for do the other values are sorted or not. So it will keep doing that. So it will compare the first 2 values, swap not needed. Next 2 values, swap not needed. Done. We have also confirmed 5. Still there's a confusion for 2 and 4. Your algorithm has no idea those 2 are already sorted, but still it will try to sort them. It will compare the 2 values. They are compared, swapping not needed. So by doing that, 4 is confirmed, and since you only have one element now, that itself is sorted, and by doing this, you got the entire sorted array. So yes, even if it is sorted, it will still check. We are reducing one step, which is swapping, but still you are checking, and that's why bubble sort is not an efficient algorithm. And the problem is the time complexity for this is O of n squared, because you have to use two loops, one for the iterations and the inner loop. For each iteration you have to compare the values. So that's your n squared. Not a good way of sorting the elements. Now think about 6 elements. So that's good. 6 squared is not a big number. It is actually, but what about if you have a very big array or very big list, let's say 20 values, 30 values. Imagine the number of steps it will take. So not an efficient algorithm, but easy to understand. Now it's time to convert this into a code. Okay, now let's try to implement the concept of bubble sort in the code. So we are going to use Java as a language. So if you want to sort, of course, you have to store the values somewhere first. So what I will do is I will create an array of integers, and let me just name this as nums. And then I will assign some values. Of course, I can go for this new array and then assign the value one by one, or we can give them the static values. So here, let's say we go with values 6, 5, 2, 8, 9, 4. I don't remember the sequence in the previous video which we talked about the theory, but let's go with these values. And I want to sort them. Okay, so what I will do is, even before sorting, let me print all the values. The way you can print the values of an array in Java is, of course, you can use a normal loop, or we can use enhanced for loop. So let me just use enhanced for loop here. So I will say for int num in nums, and then we can print the values. Right, so I'm printing num here. So I will say this is before sorting, and then I will do the same thing. I will execute the same code, but after sorting here. So let's say this is after sorting. Okay, now if I run this code, of course you will get the same value 2 times. So and one more thing, I want to print this on the same line, because ln will print on a new line. I don't want it. And maybe after every printing, I want to give some space as well to differentiate the values. And let me do that here as well, so that it will print on the same line with spaces. Right click here and say run, and you can see we got before sorting, after sorting. I think this should be printed on a new line. So what I can do is, just before this, I will say sout and run. Okay, so this is before sorting and this is after sorting. At this point, it is not getting sorted. Of course, right? We have not written any logic here. Now, this is where in between you have to write the logic for sorting. Now, in bubble sort, what you do is you compare the values, 2 values at a time, and then you swap. So you compare these 2 values. If the first one is greater than the second one, just swap. And then likewise, you will do for all the elements. Now, for sure, if you want to move to the iterations, now we have to do 2 loops here. The nested loop, basically. The outer loop is responsible for the number of iterations or the number of passes, and the inner loop is actually responsible for swapping. So what I mean by that is, I need a first variable I will start from 0, and where are we going to end it? So of course I can end it at less than 6. So you can say 6, or you can say nums.length. Okay, so basically we can use the array length. The better way would be to store this value somewhere. So I can say size nums.length. So I'm just storing that value in a variable called size. It will be easier to work with. So I will simply say size. And then I will say I++. So it will go from start to end. So this is only for passing, right? We have to do this multiple times. You have seen that in the animations. But now let's do the inner loop, which will do the actual swapping. So here I will say int j is equal to 0, because we're going to start from 0. The real question is, where are we going to end it? At this point, I will say size, and let's see what happens if we do with size. Okay, so both the loop, the outer loop and the inner loop, are starting from 0 and ending at size, the size of the array. And now we have to basically compare 2 values. Now, how will you compare 2 values? And how do we even swap them? So we will check if the first value. Now, how do you know the first value? So nums of 6, or nums of 0, basically 6 is nums of 0. So nums of 0 compared with nums of 1, that's how you compare. Again, you can compare nums of 1 with nums of 2, then nums of 2 with nums of 3, then nums of 3 with nums of 4. That means the current number, when you say 0, 1, 2, it is represented by j. So I can say nums of j But this will be compared with the next value. And how do I know the next value? Which is your nums of j plus 1. As simple as that. So we are comparing two values. Now how we are comparing them? Which operator we are going to use here? So we are going to use greater than. If the first value is greater than the second value, then you have to swap. Simple technique, right? Now how do you swap? There are different ways of which you can swap the values. I'm going to use a traditional way. Let me use a temp variable. In fact, you can also declare a temp variable here. So I can say int, it's better to have all the variables on top. So I will say int temp equal to 0 initially. And then using the third variable, I can simply swap them. So I can say temp is equal to nums of j. And then nums of j is equal to nums of j plus 1. And then nums of j plus 1 is equal to temp. So basically what we are doing is with these three lines, we are just swapping them. Nothing complex, just swapping the two values, okay? And that's what we have done here. So every time you find this, the first value greater than the second value, just swap them. And you do this multiple times because we are keeping this in a loop. And that's it. The sorting is done. Since it will be happening multiple times, it will make sure that you keep the values at the end, the bigger value at the end after each iteration. So if you run this, okay, we got an error. It says out of bound. Now there is one problem here. Don't you think when we are going for j plus 1, what about the last value? So we need to make sure that we don't go to the last value. So it should end -1, right? Because when you're comparing the last two values, the value for j will be here and this will be j plus 1. So we have to make sure that your j ends before the last value. That was the error, and run. And you can see sorting done and you got the sorted values. This is how basically you sort them. Again, we have seen this explanation in theory, how things are working out. But here we just try to sort it with the help of this logic. Now there is one problem here. Every time you do this, in the animation if you remember, after every pass, we don't have to go for all the values because the last value is sorted. In the next pass, 2 values are sorted. In the next pass, 3 values are sorted. So we don't have to sort them again or even check them again. So here, j should be not going to size -1. In fact, it should go size -i-1. Is because after every iteration, so let's say we have the first iteration where I is 0, it will go till the second last value because we are saying -1. In the second iteration where the I value will be 1, it will go till the second last position or third last position because the last value is sorted. You don't have to check that. Again, it will not affect the output, but it will affect the speed because we are saving some time by not checking the same sorted value again and again. Okay, that's how you basically do it. In fact, if you want, what we can also do is we can print this in every iteration. So I can just copy this, and after every iteration of the outer loop, we can print the values and see what is happening there, right? So in fact, I will also print a new line here so that it will come on new line. Let's run this. So this is what basically is happening. Initially you have this value, and then this is where the sorting starts. If you can see, after the first iteration, the biggest value, 9, just went till the end. Then for the next iteration, the biggest value, which is 8, is at the end, or second biggest value. Third iteration, we got 3 values sorted. Fourth iteration, we got 4 values sorted. Fifth iteration, we got 4 values sorted, or 5 values sorted. And last iteration, we got all the value sorted. So that's how basically it does. Of course, here too, we got at the start itself. We don't have to sort them again, but that's how algorithm works, right? How will you even check if the array is sorted even before you compare all the values? So that's the thing about the bubble sort, where you compare the values, swap them, and you're done. In this video, we'll talk about selection sort. So basically, we'll talk about the theory in this, and then in the next video, we'll talk about the practical of it. The thing is, when you talk about sorting, we have different techniques available. In the previous video, we have talked about bubble sort, and it was working, right? But also the amount of time it takes, basically the time complexity of the bubble sort is n squared. Now that's not the main issue. Of course, that's a main issue. But then in this video, we are not going to solve that quadratic time complexity, but at least we can reduce the number of steps. Now in bubble sort, we are going from start to end multiple times. That's not the big issue. The big issue is swapping. Because every time in the inner loop, we were doing this swapping multiple times, and it consumes a lot of time and memory. So what if we can reduce that? And that's where selection sort comes into picture. Now what we do in selection sort is we don't actually swap every time when you compare two values, but what you do is from the entire array or the list, you find the minimum or the maximum value depending upon how you want to implement it. So let's say we are going for the minimum value. So what you do is from the entire array, you find the minimum value and then you make sure that the minimum value stays at the start. Now once that is done, now that is your sorted part. So from the entire list, you create two sections, the sorted section and the unsorted section. So once you find two, that goes into the sorted section, which is at the start. And then you scan more values. Now let's say when you scan, you find, hey, we have 3, which is the minimum value in the unsorted array. Then what you do is you pick up that 3 and replace it with the second location. Now what happens to the value of the second location? Now that will be swapped where the value of 3 was. So what you're doing here is you are swapping by selecting the minimum value. So when you say selecting, that's your selection sort. Now what it does is you're not basically swapping value inside the inner loop. You are doing that in the outer loop, which means the number of swapping in a code will reduce. Now to understand this more, let's look at an example. So let's say we have 6 values here, which is 6, 5, 2, 8, 3, 7, and we want to sort them. So how will you do it? First of all, going from all the values. Now, of course, as I mentioned before, you can go for the minimum value or you can go for the maximum value. So let's go for maximum value. Okay, so ultimately you will get the same output, but the way you do the code will be different. So let's say we are going for the maximum value. Now, from all these values, we have to find the maximum value. Now, of course, at the start, we don't have any idea which value is the maximum. So let's say you make 6 as the maximum value because at this point we don't know, right? So let's assume that 6 is the biggest value from all these values. And then you start comparing 6 with all the other values. So you will compare 6 with 5. If 6 is still bigger, no issue, go with the next value. If 6 is still bigger, no issue, go with the next value. Now at this point we are comparing 6 with 8 and we know now 8 is the biggest value. So now what you do is you change your variable or you change your biggest value from 6 to 8 and then you start comparing 8 with the other remaining value, which is 3 and 7. So you compare with 3, 8 is still the biggest. You compare it with 7, 8 is still the biggest. Now once you go through all the values, now you know the 8 is the biggest value. So what you do is you make sure that 8 goes at the end. Now if you're doing this for the minimum value, what you do is you take the value 2, which is a minimum value, and you put that at the start. But since we are going for a different approach where you're finding the biggest value, you will make sure that 8 goes at the end. Now when you move 8 to the end, what happens to 7? Now 7 will say, okay, I don't have a place. So 8 will say, don't worry, I will come to your place, you come to my place. That is swapping of the values. But if you remember, we are not doing it in every iteration of the inner loop. We are doing that in the outer loop. So once you complete one pass, that's where you do the swapping. So only once for the entire iteration. Okay, now by doing this, we have made sure that you have the biggest value at the end and you got a sorted at the end, which is the 8. And then the first 5 values are still unsorted. So what you do is you repeat the steps. Again, start with 6. Now we'll say, okay, 6 is the biggest value. Let's assume that. And then you start comparing 6 with 5. If it is the biggest value, 6 is still bigger, no need to change the value of biggest value. Then you compare it with 2, no need to change. But then when 7 comes into picture, 7 says, hey, you know, I'm bigger than you. So 6 says, okay, you're the biggest value. So now the current value will be 7. The biggest value is 7. Now again, we have to compare 7 with 3. Now 7 is still the biggest. So we have to make sure that after all this iteration, we move 7 at the place of 3. And that's what we are going to do. Now by doing the second iteration, so we have completed the second iteration in which you got 2 values, 7 and 8 at the end, and the first 4 values are same. So again, you do the same thing. Next iteration. So you have to do this till you complete all the sorting. So you again go with 6 and say, hey, you know, I'm the biggest now. Let's compare 6 with 5. So still the biggest. Compared with 2, still the biggest. Compared with 3, still the biggest. Now, once you complete that unsorted iteration, you will make sure that you move your 6 to the location of 3 because that's where the 6 should be. So it will swap with 3 and then the last 3 values, 6, 7, 8 are sorted. The first 3 values are not sorted. So again, if you observe what we are doing is we are making sure that you got two different sections of sorted values and unsorted values. Now goes for the first three values. So 3, let's assume 3 is the biggest, and then compare it with 5. Now we know that 5 is the biggest of all, or at least bigger than 3. And then you compare, you make the bigger value as 5 now, 3 is gone. Then you compare 5 with 2, still 5 is biggest. And now we know that 5 need to go at the location of 2, so you have to swap it. Now comes the first two values, again the same thing. You will keep doing this till you reach to the end of your array. And you move to 3. And since we only have one value, you don't need to sort it. That's already sorted. And by doing this, you basically got a sorted array. Now again, compared to the bubble sort, we are still going from start to end. You have an outer loop, you have an inner loop, but we are doing swapping only once in every big iteration or in every pass. So that's the advantage of using selection sort over the bubble sort. About the overall, the time complexity is still O of n square, but at least it is better than the bubble sort in terms of swapping. Now it's time to implement selection sort in Java. So in the previous video, we have talked about the bubble sort, right? And this is how it works. Now, one thing to remember, in the inner loop, can you see this loop? In this loop, we are basically doing this swapping. So it increases the time as well. So in selection, what you do is you basically swap this. Of course, you do that swapping, but outside the inner loop, somewhere here. So it reduces the number of swap you're doing. How will you do it? So what I will do is I will just remove the entire code from here because this is the bubble sort. I don't need this. And what we have here is we have the array, which has 6 elements. We got a size variable where we are storing the length of an array. And then we also have a temp variable for swapping. Then we are printing the array before sorting, and we are printing the array after sorting. Okay. So if you run this, you will get the values before sorting, after sorting, but at this point they are same. Is because the main logic of sorting is missing here. So let's write the logic for selection sort here. The thing is, in the theory, we have said that we'll go for the maximum value, the biggest value to swap, or we'll put the biggest value at the end. Let's say in the practical, let's try to implement with the smallest value, and we have seen both the approach then. So what we're going to do is we'll look at the entire array and then we'll find the smallest value, which is 2. Of course, you have to iterate between all the values. And then once you got the smallest value, you will swap this 6 with 2 because 2 should be the first value, and that's how we can start. And for doing that, we have to use two loops, the outer loop and inner loop. We'll start outer loop with 0, and then we'll say I less than size, right? Okay, so we'll say I plus plus. But also we can make it more efficient by saying that size minus 1. It's because if you remember, when we were doing the sorting, and once you got all the values sorted except the first value or the last value, you don't basically sort the one value, right? So you can reduce the number of iterations you go for. So we can say size minus 1, and we'll see if that works or not. And if it works, then we are happy. We'll also go for the inner loop. Now for the inner loop, we'll go for j equal to. Now where do we are going to start j? So basically, if you're putting the biggest value or the smallest value at the start, what it means is for every iteration, the inner loop, we can skip the first value, right? So for the second iteration, we can skip the first value. For the third iteration, we can skip the first two values because they are sorted, right? So we have two sections, right? Sorted array and unsorted array. So here we can start with j equal to I. Yeah, in fact, when your I value is 0, j should start from 0. So we can say j equal to I and j less than size and j plus plus. So basically we have to go till the end. Okay, so that's the for loop we have. Now what you do inside this? So we have to find the minimum value. To start with, we can take min value variable here. So I can say int min is equal to 0. In fact, we want the min index, not the min value, because we have to work with the index, right? And we'll say the index is by default minus 1. And here, to start with, we'll start with min index equal to I. And then what you do? You basically check if the array, which is nums of min index. Now we want this to be smallest value, right? So I assume that this is the smallest, but what if this is not the smallest compared to the value which we are considering? The value which is considering here is nums of j. So example, if this 6 is the smallest which we are thinking, in fact, we should be saying I plus 1. The reason being, when you are saying that 6 is the minimum value, we are assuming that, and then we are comparing with 5. Now you will get 5 when you say j starts with I plus 1, because in the first iteration the value of I will be 0 and this 5 is 1, right? So we'll compare these two values. Okay, if 6 is smaller than 5, then everything works. But what if 6 is greater than 5? In that case, we have to swap. Now, okay, we don't have to swap. We basically have to change the min index to j, because the new index we will get is j. So the new index here is 1, okay? So that's the min index. So what we are doing by doing this is, after the entire iteration, you will get the minimum value from this array. Okay, so that means after this iteration, you will know that 2 is the minimum value. Now, once you know the minimum value, what you do is you swap 2 with 6. It's that simple. How do you swap 2 and 6? How do you know we have to swap 6? Because I is referring to 6 and the min index is referring to 2. So we can simply swap them. So we can use a temp variable here and we can put nums of min index, and we can say nums of min index is equal to nums of I, and nums of I is equal to 10. So basically we just have to swap them. So what we are doing is, in the inner loop, we are just finding the minimum value, and then once you find it, you simply swap it with the min value which you're considering, which is the first value. And as the I value goes up, first you will compare with this, then you compare with the 5, then you make 2 as the minimum after the swapping. And what I will do is, I will also print this values after each iteration. So I can just copy this and paste it here, and we also print a new line to get it on the new line. So now if you run this, let's see what happens. So you can see if this is okay. I will, after printing this also, I will just say new line. Or maybe I will just skip this new line before the for loop printing. Okay, let's run. And you can see this is before swapping, and this is after swapping. So let's compare the value. Is it properly sorted? Yes, 2, 4, 5, 6, 8, 9. Those are the values we have. And then see the steps. In the first iteration before swapping, so this is the first iteration. What you do is, you know that 2 is the minimum value, so you swap 6 with 2, and that's done. Then in the second iteration, you find the minimum value. So the minimum value from this is 4, so you swap 4 with 5, and that is done here. Then you consider 6. Then you say, you find the minimum value from this, which is 5. You will swap 5 with 6. So in this, you will say 6 is the minimum, so you will swap it with 8. Comparing this to, this is 8 and 9, so you will swap 8 with 9. And in last value, you don't have to even sort it because it's already sorted. And that's what we are doing here. And that's why we say it's size -1. We don't even sort here. In fact, if you don't put this -1, what will happen is, if you run this code, you will get one more iteration and there's no change there. It doesn't matter how many values you have. You're not going to have any change in the last iteration. So you simply save it by saying -1 here. So yeah, that's how we use selection sort. Basically, you find the minimum value and swap it with the location where it should be. So we have talked about different sorting techniques. We have talked about bubble sort and selection sort. In this video, we'll talk about insertion sort. So what you do in this technique is, basically you take the elements and then you put the elements at the right position. That is your insertion. So you have to put at the right location. Now in this, you don't normally do swapping. Yes, we do swapping, but we don't use word swapping. What you use is something called shifting. Okay. So example, if you're playing cards. So if you have a random cards on your table, so basically in this example, we are not going to use cards. We are going to use this characters. I found these characters in my drawer. I think I got it for my kid's birthday, but it doesn't matter. So I got this, and we'll try to sort these values here. So let's say if you randomly get these values, and if you want to sort them, what you do is you pick up the value, and then you imagine these are cards, playing cards. So what you do is you take the first value, you take the second value, and then you keep it like this. I don't know how many of you play cards. I used to love them, not for money, but I used to love them. Then you take a next card, and then you put it before this. Then you take a card. Then you know that this card goes between A and O. You put it here. So this is called insertion. But how exactly you're going to do that? That we'll see with the example on this table and with this cards. So now let's sort these values. Now these are not values but characters. So let's try. So what we have here is, we'll start with the first location. As you can see on the screen, we have different values here, and I'll pull this down a bit so that we can have some place to keep this. So the first value is O. Now I'm assuming the O goes here, the first location, because it's always sorted. And then you take the next value, which is E, let's say. Now we know that E comes before O. So what we need to do is, this need to go at the start. So you have to move this to the next location so that you will have some space for E. Now the point to remember here is it's all about shifting, okay? So we don't use a word swapping here. You will understand that in some time. Why don't we say swapping? Let's go for the next one, which is S. Now we know that S is greater than, so we'll compare S with all the values. So we'll compare S with E. Okay, it goes after that, it goes after O. So S goes here. Okay, I'm not promoting any camera model here, but that's the sequence. Then you go for the next one, which is D. Now D goes at the start. So what you do is, you basically have to move all the elements, right? So if you compare with S here, D is less than S. So you compare, so you have to shift S. You have to make some space for D. Then you take O and you move O here so that you can make some space for D. Then you compare D with E and you have to make some space. Of course, you have to swap, you have to move this. You will make some space for D and D goes here, right? So now it is in sequence. Then what about the last value, which is A? Now A, we all know we have to, of course it goes at the start, but we have to compare from start or last. So this goes here, which is S. If it is less than that, we'll shift this to make space for A. But then we have to also check with O. This also have to shift. We check with E. This also have to shift. We compare with D. This also has to shift. And then A goes at the start. By doing this, what you're doing is you're basically inserting value at their location. So this is how you do the insertion sort. Now let's say this was the randomly we were picking values, right? But what if you have things already in the array? So what we'll do is we'll keep it here. We'll keep this here. We'll keep this here. This goes here. And let's say this goes here. In fact, I will also move this. Okay, I'm not trying to make any city name, but let's say we have this sequence. We have these 5 values. And now you want to sort them. So what you do is, you don't start from the first value. You start with the second value. And then, because we are assuming that the first value is already sorted, okay? So what you do in this technique is, basically you divide your list or array into 2 segments, the sorted and unsorted. At this point, all are unsorted. Oh, so this is unsorted array. But when you start, you have to assume that your S is already sorted. Then you start with E. Then you see, hey, do we have E at the right position? The way you do that is you compare E with S. And you say, hey, you know, E is not at the right position. So you will take E out. In programming, what you do is you save the value of E in the temporary location. Okay. So exactly, you're not moving E. You're just making a copy of it. Maybe there will be a copy of E here as well, but you have extra copy with you saved in a temporary variable. So let's say this is a temporary space. Then you move your S here so that you can make space for E, and that's sorted now. Now if you see this too, it looks sorted. Now what you do is you check E before do we have any value. So of course we don't have any value before E. Now that is sorted. Then you go for the next value. So we started here. In the next iteration, you basically start with O. Now O will compare with the previous value, which is S. Now is it the right position? No. So we have to copy O in the temporary variable and move your S so that you can make some space for O. And O, of course you can move O here. You have to also check if O really goes here. You have to compare O with the previous value, which is E. And we know that O is greater than E, so you can keep O here. So that's how you basically sorted the third element. Then you go for the next element, which is D. So what you do is you compare D with S here, and then you know that D is smaller than S or S is greater than D. So what you do is you have to move. So you take it into temporary variable, move S here. Of course, you don't move D directly there. You have to compare D with the other elements, which is O. Is it smaller than that? Yes. We have to move this here. We have to make space for D, right? Again, before that also we have one more element, which is E. So you move E here. It's all about shifting values. And then your D goes here. And if you compare, it looks sorted, right? Compared to the other values. So it looks sorted. But then we have to complete one more iteration. So you take A, you compare A with S. Now A here is compared with S. So again, we have to shift. So what you do is you take A is the temporary location, then you move your S, you will check A with O, again you have to move O, then you check A with E, again you have to move E. So remember, you have to only move when you know that A will not be at the right position. And then you compare A with D, again D has to move so that you can make some space for A. So this is how basically you do this sorting technique. Now question arises, how will you do in programming? So what you need is you need two loops, one for the number of passes you are doing, right, moving from different element, and you need an inner loop which will responsible to find the key and shift the values. And also you need a temporary variable so that you can store it somewhere. So you need a key which will go into a temporary variable on something. Now how do we do this? That's implement in the code. So let's try to implement insertion sort using Java. Now basically, even before we implement that, before we write the code, let's write the algorithm on the board and then we'll try to convert that into code. So what we'll do is, first of all, let's get some values, okay? So we also need an array. So let's say I will name this as array itself, ARR, and then it will have some values. So let me create an array here and we'll take few values. Let's say we got 5 values. Of course, you can go for more values here. And then let me just say these values are 3, 6, 2, 1, 5. Okay, so we got these 5 values. Now, I want some variables as well. So as I mentioned before, we don't swap here, right? We do shifting of the values. So of course, to achieve that, we need inner loop and the outer loop. So let's say we got the outer loop, which will go for loop. So let's say we have a for loop here. And then we have to take a variable which is I for the outer loop counter. And then inside this, we are going to have a while loop, which will have, let's say, some condition. Of course, you can also go for and for, but then when you talk about insertion, using while loop inside makes much more sense, is because we want to run this based on the condition, not on the number of iterations. Okay, so this is your outer loop. Let's finish it here. This is your inner loop. Let's finish it here, and let's write the code there. Now we need 2 variables, as I mentioned. Of course, in the while loop, we are not going to create a variable. We are going to use one variable, but let's also go for j. So we need a I variable. Let me just write I here. We need a j variable and we need a key as well so that you can store this value somewhere. So at one point you will compare and you will save it. Now from where we are going to start this. Now if you want to understand what we are going to do, it's very simple. So initially you will take your 6 as a key. So when you write this variable, we'll say key is initially 6, okay? Now how you're going to get 6? So let's say we take a variable I here and then we'll keep the j here, okay? So we're not going to start I from the first one, we're going to start I from the second one, and then j will be the first value. Now I will represent the outer loop and j will change in the inner loop as well, okay? So that's why we are going for I and j. We could have gone for different variable name, but we got used to I and j for the outer loop and the inner loop. Okay, so now what you're going to do. So the idea is very simple. Once you got a key, which is 6 in this case, now how you got 6? Maybe we can do something like this. We'll say ARR of I, whatever I represents, we'll save that in the variable k or key. And then we're going to start j by saying j is equal to I minus 1. So I is starting from 1, so j is I minus 1. That means the value for j initially will be 0 and I is 1. Now what you're going to do with this? It's very simple. You will simply compare the value of j, which is this, the first value. So you will compare j with the key. If this value is greater than the key, then you will do the shifting part. At this point, we don't need that, right? Because the value of j, where the j represents, is less than the key, then you don't have to do any shifting part. So this is already sorted, okay? But let's go for the next iteration. Now, when you send the next iteration, it's very simple. What you simply do is, so you shift your value of I here, and you shift your value of j here, because we know that the 3 and 6, if you compare these two, they are sorted. Let's go for the next one. Now in this, what you will do is you will check. Again, you will change certain things, right? If you can see, this will change because now ARR of I is not 6. ARR of I is basically 2. Okay, so key is 2 now. What about the value of I? Even I is changed. I is now 2. So index is 2. So let me also write index so that it will make much more sense, right? So that those are the index value. So I value is 2 now. What about j? So j is I minus 1. So j will start from 1. That's done. And now you will apply a condition. So what basically condition we are checking for? So of course, if you write the code here, so I is initially starting with 1, we are now starting with 0, and then we'll go till I less than n if the length of this array is n, and then we'll say I plus plus. Okay, and then we'll assign the value. Okay, let's not write the actual code, let's write some dummy code. So let's say we got a key variable. The value for key is basically ARR, which is the array of I, and that's what we are doing here. That's one thing. Next, we also need j variable. So we'll say j is equal to I minus 1. Okay, that's how we're going to start. Now, what you're going to compare in the while loop. So in the while loop, it's very simple. You will check for the ARR. So ARR of j, okay, let me just say, complete this here. So if this is greater than the key, because the shifting part will come only when whatever is represented by j is greater than the key. So if you can see, the key is 2 here. And in this case, yes, it is greater. So 6 is greater than 2. So what you do is, you basically perform some operation. Now what operation I'm going to perform? So basically, first of all, I will take this key somewhere. Of course, we are storing that key 2 in the key variable. And then you do the shifting. Shifting of what? So you will first compare this 2 with 6. And now we know that we have to shift 6. So you will shift 6 here. Then that's one done, right? Can you put 2 here? We can put 2 here, but the problem is we also know that we have to compare 2 with the previous value, which is 3 in this case. So you will not shift 2 there, but we'll shift 3 here. But then to shift 3 here, what we have to also do is we have to first shift our j here on the first location. That means we are also going to perform j minus minus, right? So what I'm saying is the first option you're going to perform is shifting the values, right? So how do you shift? You simply take the next value. So initially j was here, right? So this value 6 is going here. So that means what we can do is we can say ARR of j plus 1, which is in this case 2, is ARR of j. By doing this, what you're doing is you're shifting. So the j initially was here, which is 1. So index of j was 1, or the value of j was 1. Then you're saying j of 2, j becomes 2. Then what we are saying is we are saying j plus 1, which is 2. So the value of 6, which was here, will move here. That's what we are doing on this line. That's a shifting part. And then you will say j minus minus. So you can say j minus minus, or you can say j minus 1. Even both works. So this is the entire logic you have, right? But this loop will repeat, right? Now, when it will repeat, look at the condition here. The condition is whatever j, so we are shifting j backwards, right? J is now here. So we'll check if ARR of j is greater than key. In this case, yes, you can see the key is 2, ARR of j is 3, so it is greater, so we'll shift. So how do you shift? Basically, you do the same operation which is there inside the while loop. So if you compare this operation, this is what it is doing, the shifting part, right? And then we know that, of course, if you can see here, we have one more step. You will do j minus 1, which means your j basically moves 1 here, because when you reduce the value of j, it became 0, right? And then again, you're doing it, so it will become j becomes minus 1. So we have to stop it here. Once the j becomes less than 0, we have to stop. But don't you think we have to also add that condition in the while loop? So we'll do that. We'll say, and j should be greater than or equal to 0. Okay, this is one condition we have to add. If this is false, if j is not less than or equal to 0, then you will do the last step. The last step is very simple. You move your 2 here. And the way you can do that is by saying ARR of j plus 1, because j became minus 1. We don't want minus 1. We want 0 is equal to k, is equal to key. So basically, this is where the value goes first. Now, by doing this, we were able to sort the first 3 values. Now, what next? Of course, you will increment the value of I. So when you say increment, that means the value of the I variable goes here. And again, for the next iteration, j goes I minus 1, right? Because of this, basically, for the outer loop, the I value is incrementing, but the j value is just before I. And again, you do the same things. What are the same things? You first check if the key, okay, we have to update the key as well. Now, how do you update the key? Now, the key value is ARR of I, which is in this case should be 1. So the new key is 1, and I is what? I is 3 and j is 2. Okay, new key value is 1. You will compare. If the ARR of j, this is the condition we're checking now. If ARR of j, which is in this case is 6, is greater than the key, in this case, yes, you perform this operation. What is the operation? It's very simple. Let's keep this value somewhere. You start shifting 6 here, 6 goes there, and then your j comes back. J comes here, right? Because of this step here, right? And then you again check if ARR of j is greater than key, yes. 3 is greater than 1, again you will shift 3 here, then you shift j here, then again you shift 2 here, then you shift j here, and then now j becomes minus 1. Let's stop the loop and shift 1 here. You can just do the same thing for 5. Let's do that quickly. So what you will do is you will shift the value of I here, which means certain things are going to change. Now this I becomes 4, this j becomes 3. The key value now is 5, right? Again, you do the same things. You keep your j here because j is just I minus 1. Then you compare. If the ARR of j, which is 6 in this case, is greater than the key, yes, let's do the shifting. Now, how do we do that? Let's move that here, and then we have to shift 6 here. J goes here. Now, again, you check. Is the ARR of j is greater than key? No, it's not there. So you will just simply come out of the loop, and then you will keep 5 here. And if you can see, it's all sorted. So this is the logic. Let's implement this logic in the code now. So you have the logic in front of you. What you will do is you got the same values. In fact, we can go with the values which we have. So let's say, okay, I just rewritten the values. Let's go for these values and let's see if this works. Instead of array, we are going for nums. That perfectly works. I don't want a temp variable. So we can remove this portion here. This is basically the older code which we had for selection sort, if I'm not wrong. And this is the before sorting elements. This logic is going to change for sure. Okay, so let's write the logic. It's very simple. You create an array. So let's say this array is ARR is equal to, let's have some default values to it. Let's say 5, 6, 2, 3, 1. This time we are going for only 5 values. And this is an array. Okay, what next? Now, basically, as we have written in the board, let's take a for loop. Now, the for loop is going to start with I is equal to 1. And we can do that quickly now. It will finish at n, but we don't know what n is. So we can say array.length. And we can say I++. Right, that's 1 done. And now, okay, let me just remove some space in between. Okay. Now, what are the extra variables we need? Basically, we need 2 variables, right? We need key. The value for key will be ARR of I, which we have done earlier. And then we also need j, and we know j is j minus 1. You know, this is what happens when you know the algorithm on the board, right? I have a board with me. So, okay, those are the things we need. Okay, not j minus 1, it should be I minus 1. And then you do a while loop, because this is where you do the iteration. We have to make sure that j is greater than 0. That's one thing. And we need to also check if ARR of j is greater than key. In that case, you will execute the while loop. So you will do certain things here. Now, what you are going to do inside this while loop. So basically, you have to do the shifting, right? If it goes inside, you will say ARR if j plus 1 is equal to ARR of j, right? And also you have to reduce the value of j. So you will say j, we can even say j minus minus, syntactically that works. And for the outer loop, you will assign the value for key for that particular empty location. And the empty location is defined by j itself. So j plus 1 is equal to key. And I think we are done. So the code is so short. Let me check if that works. What I will do is I will just print the values here. So I will take a for loop. And I will say int num from array, and let's print the values. Let's say print num. I don't want the new line. I would just want a space here. And let's see if that works. Right click, run, and boom. You can see we got the output and the values are sorted. It doesn't matter what type of values you add here. Let's say 8, 4, and run. You can see this is sorted. Yeah, so that's your insertion sort. In this video, let's talk about another sorting algorithm which is called a quick sort. So the thing is, when you talk about sorting algorithms, the idea here is to explore different algorithms and we'll see how efficient it is. Now, when we talked about the other algorithms which we talked about till now, bubble sort, selection sort, they have a big O notation of n square, which we don't want, right? We want to make it faster or efficient. Now, in that case, we have to explore some other algorithms, and one of them is quick sort. Now, in the best case, the quick sort goes for n log n, which is much better compared to the n squared. But in the worst case, also it goes for n squared. So in the worst case, yes, it is almost there, but on average, it is n log n, or you can say the best case. So at least we are happy in the best case and in the average case. Now let's say what is quicksort. So actually it uses multiple things. So let's talk about that first. The first thing is divide and conquer. So basically till this point when we talked about bubble sort or selection sort, we were doing the algorithm on the entire collection. So let's say if you have a list of values which is 6 values. So what you do is you perform the operation of bubble sort and all the sorting techniques which we have done before applied on the entire list. But what quicksort says, let's do divide and conquer, which simply means divide your problem into multiple things and solve the problem or sub-problems individually. So what you're doing is you're dividing it, you're solving it, and at the end you will combine it. So that's your divide and conquer. So in this case, if you have 6 values, let's divide the values into multiple sub-problems and then sort it and then combine it. So that is your divide and conquer. Next, it uses something called a recursion. Of course, you can also use recursion in the other algorithms, but here it works with recursion. Now, basically, what is recursion? So when you call the same function by itself. So example, let's say the function name or the method name is show. And if you're calling show inside show, that's your recursion, right? And next, we have to understand the concept of pivot. Now, basically, pivot is something called a central point of a problem. Okay, so let's say you have this entire list here or the array. Now you have to find a pivot and then based on that you will perform the operation. Of course, it will make much more sense when we start, but remember, we have to work with the pivot. So those are the things we have to remember: divide, conquer, recursion, and pivot. There is one more thing, which is the tree. Now, basically, when you say you are dividing your entire list into subsections or sub-problems, what you're doing is you are creating a tree structure, okay? So once we start with the diagrams, it will make much more sense, but these are the things we have to remember. So let's see how your quicksort works, and then we'll try to convert that into algorithm, and then we'll see how to write a code for it. Now, the basic idea here is, let's say you have a list of values. So we are discussing about quicksort. So let's say we have a list of values. So let's go for 6 values here. And I will say this is 5, this is 3, 6, 1, 4, and 2. So let's say we have the 6 values. I'm not sure will it really make sense to use this example, but let's get started. Now with this 6 values, what you normally do is you do divide and conquer here. So the basic idea is break the entire list into sub-problems. Okay, something like this. Maybe we can create two different arrays. Here we'll be having 5, 3, 6. Here you can have 1, 4, 2, and then you can again divide this. Maybe you can have 1 and 4 here and divide this into 2. Here also we can have 5, and then we can have another array which is 3 and 6. So we got these 2 arrays from the big array, and then you create the shorter format of it. So at the end, what you're doing is you're creating the small chunks. Now this is what your tree structure is. So we have divide, we talked about divide, so we are dividing it. We'll sort the array and then we'll combine it. And then since we are performing the sorting on each section, each sub-problem, that is your recursion. But is it the real thing? No. So basically we talked about the idea, but how do you divide the array? Randomly I just divided the array, but that's not the main idea. But we have to divide, but not this way. So how we are going to divide this? That's the question. Let's remove this and let's go with the values here. The idea is you want to divide, for sure. You will divide this into 2 parts, but you need to find a point from where you will divide this. And that point is basically your pivot. Now, how do you find a pivot? Now, basically, the reason we get this partition or pivot to do the partitions of the array, right? Now, should we pick up 1? Now, that depends. So even before you divide, you have to do one more thing. So I'm saying pivot, but then that pivot should be a point which is at the right position. Let me repeat. The pivot is a point in this array which is at the right location. Now, if you see this, after this sorting, what the values you will get. So you will get values like, let's say, I will just write it in shorter format now. So you will get 1, 2, 3, 4, 5, 6. This is the output I want. Okay, just wait for the sequence of numbers here. But this is the output. So this is the output which we want from this input, which we have the bigger array here, or the big size which I mentioned. Okay, so if you talk about the value 1 here, so 1 should be at the first position, 2 should be at the second position, 3 on the third position, fourth position, fifth, and 6th, right? So they should be at that position. Now, since we have taken those values, and that's why it might be confusing, but you got the point, right? It doesn't matter what your values you have. It should be in the ascending order. So the first value, the smallest value should be first, and then a list goes on. Okay. Now we have to make sure that at least you find one point from here, or one value which is at the right position. Example, if I say, let me take 4. Now 4, is it at the right position? The answer is no. 4 should be here, right? So instead of 1, it should be 4. Then we can say 4 is at the right position. Now, if you want to understand this with an example, so let's say you're in a classroom and then you have multiple students there, okay? And then you want to sort them based on their height. There's one way, as a trainer, I can be there and I can say, okay, you go there, you go there. And that's what we have done in the bubble sort, right? I was controlling it. But what if student can sort themselves? So they can compare each other and they say, okay, I should be here or I should be here, and they will move. Now, one way is one person can sort them, but then we don't want it. So what we want is, what if the students themselves can get into the right position? That will solve the problem, right? Okay, but how we are going to do here, how they will reach to our right position. Now what you do is, initially we don't know the position, right? So you can take any value. Normally we can find the pivot. So for the first iteration, what we are trying to do is, we want to make sure at least one value is at the right position so that we can divide the array. Now which value should we take? Technically, if you take the average value, or if you take the middle value, example, if you go from 1 to 6, the mid value is 3 or 4, right? So if I can take 3 as my pivot, it will be much easier for me to divide the array. So what will happen is, if I take 3 as my pivot, then 3 should be coming here, right? So this is the right position for 3, right? But it's not. If you start with the array, this is not at the right position. But if you get to the right position, we can divide into 2 parts, right? Okay, so that's the main idea. How will you get that there? So normally what you do is, if you can find a good pivot, and that's very difficult to find, because how do you know the mid value? Since we know the values here, I can find the mid value. But as a program or as a software, they don't have any idea what are those values are. So what we do is, we randomly pick the pivot. Maybe you can pick up the pivot, let's say 1 in between somewhere, anywhere if you want. So you can pick up this 1, you can pick up this 6, or you can pick up the first value, or you can pick up the last value, or what you can do is, you can just add all these values and divide by 6, whatever value you will get. So try to find the average of it. That's what we can do. But again, that's a lengthy process. Normally, which I have seen, is they go for the last value, not the biggest value, last value, because we don't have any idea what the biggest value is. So we will go for the last value. Okay, so this becomes your pivot. That means we need multiple variables here. Now what variables we need? So I will just write variables here. So the first variable we need is a pivot variable. So we'll say pi. Okay, and then you need few more variables. You need a variable I for the positioning. Again, we'll discuss what this positioning is. Then we'll need a j, which will go through each element. And we have done that in the sorting, right? So when you jump from each value, that will be done by j. And then of course, we also need array here. So let's say this is ARR, this is your array. Okay, and let's have the index value. So we'll say this is 0, 1, 2, 3, 4, 5. Those are the index values we have. Apart from this, we also need a low and a high variable. Okay, so we'll say L and H. So let's say this is L and this is H. Now, normally we can say H is the last value, or we can say it's a length minus 1. So we can say that. So we have a low and we have a high. So low starts from the first, and H is the last value. Now, how do you perform the operation? It's very simple. First, you find the pivot. Now we know that we are going for pivot, which is 2 in this case. So what you will do is, let's take this 2 as the pivot. So I will say this is P. So this is referring this 2. So Pi variable at this point is referring to. So I will say this is 2 in this case. And then we need 2 variables. So let's take variable I. Now by default, the value for I will be the lowest value minus 1. So let's say the I value is here at this point. You know what I will do? Let me just remove this portion at this point, because let's keep the slate clean. So we need an I variable, and then we need a j variable. So j will be here to start with. So I will be here at the -1 position, j will be here at the 0th position. And then what you do is, you basically run a loop where of course the I will also increment, but the main loop here we want is for j. Okay, so we'll take a for loop for j. Okay, so let me write the code here. So what we want is, of course, the rough code. So I will say for j will be starting with low. Okay, that's what we are doing here. And then j should go till n, but then we are not using n variable, right? We are using variable high. So we'll say j less than high and j plus plus. Now what you are going to do inside this loop? So basically, you will first make sure that you get the pivot value, right? So you will, of course, you have a pivot value here, which is 2. And then you also got I is still -1. Now inside this loop, what you will do is you will check if the ARR, which is in this case, we have an array, if ARR of j, if it is less than the pivot, so pivot, we have a variable here. If it is less than pivot, you will perform some operation. Now, if you compare the values here, do you think the ARR of j, which is 5 in this case, is it less than the pivot? Because pivot value is 2. No, it is not less than pivot. So we'll not do anything. But we have to find a value which is less than 2, right? So if the value phi is less than 2, you will perform some operation. Since it is not true, we are not going to perform any operation here. So basically, you're going to shift your j here. Okay. Now, why we are doing it? Of course, we are running a loop, right? So j starts with low, and then we have to increment. So j goes there. It will compare itself with the pivot. Is it small? No. So again, you will shift your j. Then you compare 6 with 2. Then is it smaller? No. Then you shift your j here. Then you check. Is it smaller? Yes. What if it is smaller? Then what you will do? In this case, if it is smaller, you perform some operation. First thing you do is you increment the value of I. Basically, what you're doing is you are shifting your I here. Okay, that's done. Next, we have to make sure that you swap the value of I and j. Okay, so whatever value you have with I and j, you basically swap them. So what I'm saying is, take this value here, move this value 5 here, and move this 1 here. Okay, now how do we do that? Of course, we have used it before. So we can use a temp variable, or maybe at this point, I will simply say swap, and then we'll write the logic later. So I want to swap basically the value of ARR of I with ARR of j. Okay, so we need to do the swapping. That's it. These are the things we are doing inside the if condition. Now, once that is done, of course, you have to move your j again because we are in a loop. So j will go here. Now, again, you will compare. If the 4 is less than 2, no. And that's it. J will move here because if it is not less, then we are not doing any operation. Then your j goes to the last value because your j ends at high, right? So j reaches here. And of course, the pi and j is same. Then you don't have to, of course it is false. This condition will be false, which is ARR of j is not less than pivot. So in this case, it will not swap. But what happens after that? Even if you complete the entire loop, do you think 2 is at the right position? No, 2 should be here, right? So this 3 need to go there. So what you do is you perform one more operation after the loop. So after the loop, what you will do is you will basically swap the ARR of I plus 1 with the ARR of high. Okay, now this is the operation you have to perform. Now, what will be happening here? So what is the value of I? Value of I is 0, which is index. You're picking the next value, which is 3. So you have to swap this 3 with this 2 because that's what your ARR of high is. So you will move here and you will move this side. Now, by doing this, we made sure that the pivot value which you choose is at the right position. Can you confirm, is it the right position? Yes, it's at the right position. Now what you do is you divide. If you observe the array, if you look at the pi, which is pivot here, now if you see the left hand side of it, this is always lower than 2 and this value is always greater than the 2. So yes, 2 is the right position. Now what's the next step? The next step is very simple. You divide this array based on the pivot value. So what you do is you create another array here. And in this, you will be having only one value, which is coming from here, right? In fact, we can also draw an arrow there. So this is coming here. 2 will remain there itself. Maybe I can write 2 here. We don't have to work with 2 because it's already sorted. And then you take this particular section into another array. Not another array, but let's say logical partition we are doing here. So we'll get another array here. So we are doing divide and conquer. So here you're going to have 6, 5, 4, 3. If you observe, they're not sorted, but at least we got the partition, right? Now what you do is you again perform the same operation which we have done here in the first example. Now you help me. Should we start with this? Yes, we can start, but don't you think we only have one value? And whenever you have one value, it is already sorted. Let's work with this. So what you do is you again take the same thing. So you take the low, you take the high, and then you of course you again have this all these values here. So all these variables are still exist because you are going to apply quicksort again on this particular values. So let's get started. Let's take pivot. Which pivot we are choosing? Of course, we are choosing always the last value. So this is your pi pivot. Then you got I here, you got j here. Then what you do is you start running your algorithm, which is first you compare the value of j, which is 6 in this case. Is 6 smaller than 3? Look at the algorithm which we have done. Is 6 smaller than the pivot? The answer is no. So you will simply move your j here. Again, check, is it small? No. Shift, is it small? No. Is it, then again goes here, is it small? No. Then what you do is you have not done any swapping, but at the end we got one more logic, right? So once you complete this for loop, you will do something with this, which is swapping the I plus 1. So I is at -1. So you have to basically swap the 6 with the array of high, which is 3. So this goes here and this goes here. Now if you look at the pivot, this is sorted, right? So now what you do is you write 3 here, which is your pivot value, and then you divide your array into 2 parts. But since the pivot was the first value, what you will do is you will get the new array now from this, which is 5, 4, 6, and then you start performing operation here. Now what operation? The same operation which we have done. Again, you will apply quicksort. So this is L, this is H. So PI is referring 6 here. And then you start. So you got I here, you got J. Then you start comparing. Is the first value, the value of J, is it smaller than the pivot? Yes. Now when you say yes, what you will simply do is you will increment the value of I first. If you look at the code, that's what the logic we have. And then you swap the value of I and J. Now in this case, I and J are referring to the same value. So swapping doesn't make sense. Of course, they will get the same value. Then you increment the value of J. J goes here. Check, is 4 less than 6? Yes. In that case, you will move I here. And then you will swap the value of I and J. Again, it remains same. So nothing to do here. Then you shift your J here. Of course, the array of J is not less than pivot because they're the same value. Then this loop's end, the for loop ends. Then you perform this operation, which is ARR, which is +1. This will be replaced by high, and that remains same, right? So there's no swapping. I know it all depends upon the value, type of values you're getting. So at this point, there's no swapping happened. So this remain as it is, 6. But then you will get a new array here, which only has 5 and 4. And then you start applying the same operation. Let's get started. In fact, I will just write this bit up so that I will have some space. And this is coming from this particular section. Then what you do is you will take the same value, you say, and if you observe, we are doing recursion, right? The same steps we are repeating multiple times. So LH, we got PI here, we got the variable I referring to -1 position, or in fact, not -1 position. It is 1 less than the low. So in this case, the low is this position, right? Now, what is this position? This is, in fact, we should have maintained the index value, right? So this is 0, this is 1, this is 2, 3, 4, 5. Then we got 3 here, which is this one. This is 3, 4, 5. What we got here is 3, 4. So these are the index values for them. Okay, so we got I referring to the index value 2 and J is here. Then what you do is you simply compare the same steps which we have done. So the array of J, is it less than 4? No. So all this operation, this swapping is not needed. You will simply move your J here. Again, do we need to swap? Of course not, because the array of J is not less than pivot, so it will remain same. But then you will perform the last operation, which is this one. What it says swap this value with the high value. So this will be swapped. So 5 goes here, this goes here, and this goes here. Now, if you observe, we divided and we conquered. So if you merge this, in fact, we are not merging physically, we are merging logically, right? Because nowhere we were breaking the array. But if you see, if you try to merge logically, what you will get? So you will get this 1 first, which is 1 goes here, then 2 goes here, then by sequence 3 goes here, then by sequence this 4, 5 goes here, and then this 6 goes at the end. So if I'm to write this, this will go here. So let me write 1, then this goes here, that's 2, then 3 goes here, that's 3. Then if you can see in the binary tree, we always goes from the left to right. So if you see the left, because 6 is there on the right hand side, you will say 4 and 5 and at the end you will get 6. Now this is sorted. So after all this explanation, this is how basically you sort them. Now this logic which we have written here is actually a part of a partition method. So this is a partition method. So the entire thing goes there. But we also need to return the pivot value, right? So which is the pivot value? So we'll say return I plus 1 because that's what the pivot is. But this particular function will be called by whom? So we have a concept of quicksort here. So quicksort is going to call this partition. How? That we're going to say in the code itself. So you got the idea. Basically you divide, sort each values, and you will get the output. Now this will make much more sense once we start coding, and I hope it will get clear. So what I will do is I will just remove the entire part here. We got this array and we are going to perform the operation. Now of course you can write the entire logic here, but then remember quicksort goes for recursion. So when you say recursion, you have to create a function or a method which will get called. So what I will do is I will create a function here and let's call them. So we'll say a quicksort as a function name or the method name, which will take 3 parameters. Now what are the 3 parameters? The first one is the array itself on which you want to perform the operation. Next is the starting point and the ending point of each section. Example, at the start it will be the entire array, but remember when we have to break it down, so that is your each section. Okay, so we have to specify the low and then you have to specify the high. Now in this case, what is low? So low is 0 and the high is basically the array dot length minus 1, right? That's the value you have to send. Now basically we don't have this function, so we can just right click here and say, okay, I want the IDE to create this method for me. Maybe just using some inbuilt methods. Okay, let's create our own. So what I will do here is I will create a method called public. I don't want to get the object, so I will say static void quicksort, and it will take these 3 values. So first it will take a int array. In fact, one of the syntax of array, you can write it on this side because it will make much more sense. You got array and then you got int low, then you got int high. So these are the variables you need, and then you can start performing the operation. So basically from the main you're calling quicksort only once, but quicksort will be calling itself. Okay, but based on what? Now basically I want quicksort to call itself only till when your low is less than high. We don't want it, right? So that's what it makes sense, right? Low should be low, high should be high, and if it is true, then keep calling the quicksort. So I will keep calling the quicksort, but the question is, what values I have to pass? Now think about this. If you have one big array and then you're saying that we'll be breaking this into 2 parts, so don't you think you have to call quicksort 2 times for 2 different arrays? That's right, so you have to call 2 times. But the question is, what are the values? For sure, the first variable will be array because that's what we are sending, right? We have to sort the array. The question is, what will be the low, what will be the high? Because when you divide your array into 2 parts, what should be the starting point of the second array and the ending point of the second array? That's what you have to mention. But how will you know the starting point? It is easy actually. Here, the starting is always low for the first array and the ending is always high for the second array. Okay, even that is solved. The problem is with the ending of the first array and the starting of the second array. That's what we need to find. Now, how do you find this? For this, we have to run a partition. Okay, so this is the logic which we have to refer to. So what I will do is I will just reduce the IDE size so that I can see those values. I mean, this logic. So this is what we have to implement in the partition. So basically to get this value, the pivot value, what you will do is you will say int pi equal to, and you will create a method called partition in which you will pass 3 values, the same 3 values, array, low and high. So basically in the logic I have not mentioned it, but we want this value as well. Okay, so we need to create this method. So what I will do is I will just go back here, more actions, create a method. Okay, so we got the method. Let's perform operation on this method. We can make it private because we're not going to use partition outside this class. So private works. But what should be the logic here? And we have to return something. Remember, we have to return the PI value. Okay, so we can write the same logic which we have written here. And once you get this PI, you can basically pass the PI, and we don't want to include the PI. So we can say PI minus 1. And here we have to pass PI plus 1 because every partition when you create, you don't consider the PI, right? PI stays there. You create 2 parts and then those are your 2 partitions. But we have to find this PI, that's the main task. And for that, we have to write this logic which is mentioned here. So we need some variables. The first one is temporary pivot variable. And we have to assume pivot for the first time. So the pivot here is always high. So that's the algorithm we are using, but we can pick up the starting value or randomly pick any value that works. So let's say we got pivot high, and then we also need one more variable which is I. Remember, we have to use this I which will return. So I is basically your low -1. Remember, if the array starts with 0, the I will be at -1. Next, we need a loop, so we can get the entire loop from here, or maybe you can type. So we can say for int j is equal to 0. In fact, not 0, right? It should be always low, because when you create different partitions, not every partition will start with 0, but they will start with low. So j less than equal to high and j plus plus. I'm just referring to my algorithm which I mentioned here. And then the logic we have to write is if ARR of j, if it is less than pivot, then you start doing some operation. What operation? First you increment the value of I, and then you swap. But how will you swap? We don't have a swap function. Actually, we can create one. But instead of that, what we can also do is we can write the logic. So I can say int temp is equal to ARR of I. Then ARR of I will be replaced by ARR of j. And then ARR of j will be replaced by the temp. Okay, that's the values we have to swap. And that's it. This will run and you will do the partitioning part. But once you complete the for loop, again, we have to swap the value of I plus 1 with high. So you can actually use the same logic here, or same statements. So I'm not copy pasting, I'm just reusing the code. Sounds better, right? So here we can say this will be replaced by I plus 1, and I plus 1 will be replaced by high, and this high is going to replace by temp. Swapping done. And at the end, we need to return I plus 1 because that's what is referring to the pivot. Okay, looks like a right logic. We just converted that into here. So by doing the partition, we are saying replace 1. In fact, once you get this algorithm, also try out the same thing which I've done on the board. Okay, then it will make much more sense. Okay, I hope this will work. What do you think? Let's run and let's see. Run, and yes, looks like sorted. 1, 2, 3, 4, 5, 6, 8. Let's change some values. Let's say this is 81, this is 62, and this is 111. Let's try with these values and let's see if they're sorted. So 2, 3, 4, 5, 62, 81, 111. So it works. So this is your quick sort. Now, why we are saying this is n log of n is because we only have one loop here, which is for loop, plus we are doing the partitions of it, right? So they can run parallelly. Yeah, so this is n log n, but in the worst case, it can go for n squared, but better than the other sorting techniques. So yeah, that's it from quick sort. We have written the code in Java. In this video, we'll talk about merge sort. Now basically, let's talk about the theory first and then we'll focus on the implementation. Now when we talk about sorting techniques, we have worked with multiple sorting technique. And when we talked about the quick sort, which was going for a time complexity of n log n, now we have one more there which is called a merge sort, which also has a time complexity of n log n. Now, both quicksort and merge sort follows a technique called divide and conquer. So basically what you do is, you break down the problem into subproblems and apply the algorithm on those particular subproblems. And once you get the solution for each subproblem, then you combine the solutions or sub-solutions to get a final solution. That's what we are going to do here, which is divide and conquer. Okay, so how we are going to do this? Now, basically, it is actually easier to understand. So if you can be with me, it will make much more sense. So what we're going to do is we'll take an array initially. Okay, so let's say I'm taking a list of values here. So let's say we are going for 6 values here. And what are these 6 values? So let's say I have a value which is 8, 5, 9, 1, 6, 7, let's say. So we got these values here, and then I want to sort them. So what you do is, you will apply a merge sort. Now basically here, as I mentioned before, you will do 2 things. You will, in fact, 3 things. First, you will divide this problem into subproblems, and then you will conquer them, and then you will simply merge them. Now, since it is called a merge sort, the important step here is merging. So when I say important, I'm also saying it is complex part. The easier part is to break down this into small parts. Merging will be time consuming, so let's understand this. So when you have these values here, what you will do is, first of all, you will break down into 2 parts. Now the question is, how will you break it down? In different sorting algorithm, we have a different way of breaking the entire list. In fact, in quicksort, we use a pivot. But here, let's make it very simple. We use something called a median. Now, what is a median, or maybe a midpoint? So here what we can do is, as we know that if you talk about this particular array here, the mid is here, right? We can see and we can tell that. But how an algorithm will know that this is a mid? And that's why we will do some calculation. Now, what kind of calculation? It's very easy. So what we can do is, let's say this is your left and this is your right. So what we will do is we'll simply use index values. So the index values for this is 0, 1, 2, 3, 4, 5. So that depends upon the values you have. And then if you want to find a median, so basically L represents the first index value and R represents the last index value. So you have to find a median. And the formula for median is very simple. So what you will simply do is you will say median is equal to left plus right divided by 2. That's how you get the median, right? Now in this case, the median is, what is L? L is 0, R is 5, and this divided by 2 is equal to 5 by 2. Now since in different languages we get different outputs, so let's say this is 2 in this case, because in most of the languages we go for the float value. So we got 2 here. Now 2 is your median. So this is your median. So whatever is there on this side will go into a different array, and whatever is there in this side will go into a different array. So when I say array, I'm talking about the list. So what we can do is we can divide into 2 parts, and then we can create a different section. So we got a section here which has 3 values. We got a section here which get 3 values. And then the values will be 8, 5, 9 here, and 1, 6, 7 here. Okay, and again, the job is not done. Again, you have to divide into 2 parts. Now, how we're going to do that? It's very simple. The same steps which you have followed. Again, you will take L and R here, L and R here. Let's find the median of the first point here, or the first array. Now, how do you get the median? Again, you will say M is equal to L plus R divided by 2. So now we can do it quickly. So what is L in this case? So if you go with the index value is 0, 1, 2 in this case, and 3, 4, 5. Now if you talk about the first array, the L is 0, R is 2. So you will say 0 plus 2 is 2, and 2 divided by 2 is 1. So M for this is 1, so M is here. Now if you want to calculate for the next array or the next values, so again the same value. So what is L? L is 3, R is 5, so 3 plus 5 is 8, 8 divided by 2 is 4. So 4 is here, so median is here. Of course, when you look at the values, you will find the median just by looking at it. But let's talk about the algorithm, and we don't have a limited set of values. What if you have 500 values? You will not simply search for the median, right? So that's how we can get the median. Again, you will divide into 2 parts. So we can divide something like this. You will get 2 sections here for this and 2 sections for this. We can say the first section will have 2 values, which is 8 and 5. The second section will have a value which is 9. Here the first section, since we only have one value here, 9, we got 9. But let's say here we got 1 and 6, and here we got 7. So basically that's how you divide. Again, the job is not done. So you have to go till the end. So what we're going to do, again, you will divide the first one. So can we divide the second one? The 9, we don't need to divide this part, right? Because when you get one value, you cannot divide that. So let's divide the first part here. So if you divide this, you will get again 2 values, which is 8 and 5. And again, you will divide this, you will get 2 values, which is 1 and 6. So that's how you can divide, and at the end you will get the individual values. Now still we can persist the index value because we are not physically dividing them, we are just virtually dividing it, right? So index value for this is 0, 1, 2, 3, 4, 5. The index number remains same, and if you compare with the actual list we got, the index value and the values are same, right? So till this point we have not done any sorting part, we just did the divide part. And now it's time for the conquer. Now when you say conquer, it simply means that you need to sort this value. So whatever value you got at the end, sort them. But if you observe, they are already sorted. Because each element, if you compare, if you say 8, this list is sorted. When you have only one value, it is by default sorted. Okay, so sorting is done. So conquering is done basically. The next step is to merge them, and the actual fun starts here. Now when you say merge, what it means? So basically what you do is you start with the first 2 values and then you merge them. Now merging is important. So when you say we are merging 8 and 5, of course you will get a list and you can again say 8 and 5, but no, this is not how you will merge it. So the way you will merge it is this. So you will take these 2 values and merge them into another block. You will get 2 values. But when you're merging it, you will compare these 2 values. So which is less here? So if 5 is less, you will put 5 here and then you will put 8 here because that's the only remaining element. Then you think about merging. So you will merge this 2. Now when you're merging this 2, of course you will get 3 values, right? So you will take 3 values here and this is coming from here. So these two values and this one value. Now, how will you merge? Now, since we have two different lists or two different values here, or two different arrays, we can say, when you want to merge, that's where the actual algorithm starts. Because when you're merging two values, you can simply compare smaller or get greater. But now we have three values. In first, we have two. In second, we have only one. So what you do here is you basically compare these values before adding them. So what should be the first value? Now, we know that the previous array is sorted, right? And then, in fact, both the values are sorted, both the arrays are sorted. When you combine them, what you can do is you can compare the first two values, only the first two values, not 8, only 5 and 9. So which is smaller? 5. So you will put 5 here. Now, since 5 is done, you can simply say, okay, I'm done with 5. Now let me focus on 8 and 9. So which is smaller? 8. And then the only thing remaining here is 9. So we'll put 9 here. Now that's done. Now let's combine this 3, which is 1, 6, and 7. Now first you have to combine this 2. So you will get another box here, which is 1 and 6. So we will compare. So it is 1 and 6 because they are sorted. So now we will combine the next part. You will get 3 values here. Now when you get 3 values, what we are doing is we are basically combining this section and this section. Same steps. You will compare the first two values. So 1 compared with 7. So 1 will come here. This is done. Then compare 6 and 7. 6 will come here. This is done. Then 7 will come here. Okay. And then now the major work starts. We have to combine this two. Now when you're combining these two, you will get a bigger array of 6 elements. So 1, 2, 3, 4, 5, 6. So we got 6 blocks. Now what you will do is you got 2 arrays, and we know that those 2 arrays are actually sorted. When you combine them, again you will start with the first 2 values. So when I say first 2 values, let's compare 5 and 1. So what you will do is you will compare. Okay, 5 and 1, which will come here. So it is 1. So this is done. Then you compare 6 and 5 because 5 is still remaining, right? So 5 and 6, it is 5. Then 8 and 6, which is 6. So 5 done, 6 done. Then 8 and 7, so which is 7. So 7 done. Then 8 again. Now we don't have anything to compare from the next array. So you can simply take these 2 values as it is here. This is merge sort. Okay, so you get the sorted value, I hope. Yeah, you got the sorted value. So this is how basically the merge sort works. That's how you basically divide and you combine. But if you want to do this in programming, how will you do it? And we'll keep this as a reference. So we can divide, we can write this section here. So we can compare with this. Now, if you want to write an algorithm for this, first of all, you will get an array, of course. Now in this array, you will have some values. And we can take the same values which we have here, right? So let's say we have an array with some values here, the same values which we have. And then the next step is you basically need to create a function, let's say merge sort, and this is where you will do the sorting part. So when I say merge sort, the first thing you will do is you will say divide. Now when you say divide, you have to pass 3 things. First, you have to pass the array, then you have to pass the L value, R value, right? And then if you observe, we are dividing, again you're dividing, again you're dividing. So don't you think this is a concept of recursion when you do the same thing multiple times? So we have to do recursion here. So basically here, we have to pass 3 values, right? So you will pass an array, you will pass the left value and right value for each array. Now, as this will be called multiple times in recursion, every time you have to pass the array, the left and the right. Remember one thing, we are not dividing the array physically, we are dividing it logically. So even if you divide this array, ultimately the values will remain same. Okay, now when I say divide, what it means? The first thing you will do is you have to find the median or the mid value. So I can say mid, but then since this, okay, so let's find mid here. So we got mid is equal to, we know the formula R L plus R divided by 2. Now once we got the median, what we're going to do is, once you got the median, you will break down into 2 parts and you will apply the merge sort in each section. So what I'm saying is, when I'm calling this for the first time, I'm passing the entire array with the L value as 0 and R value as 5, which is the last index. But again, I'm going to call the merge sort by passing different values. So I'm going to pass ARR. Next, I need to pass the first array index value. So the first array here starts from 0 to 2, which is the median. So starting is L, ending is median or middle value or mid value we can say. Again, I will call merge sort for this second array. Again, I have to pass ARR, but this time you have to pass, if you look at the values, we have to pass 3 and 5. Now where do we have 3? We don't have 3 anywhere, so we can say mid plus 1. So mid is 2, so mid plus 1 is 3, and the ending is right. Okay, so that's how you call the merge sort. We have to remember one more thing. After doing merge sort, which will break it, we have to merge them as well. So when you say merge, you have to pass 4 things here. First the array, the left value, the mid value, and you have to also pass the right value. Again, we'll see the logic later, but this is the merge you have to pass. But if you call the function by itself, you can see merge sort is calling itself, but don't you think there should be a limit when it should end? So of course there should be a condition as well. When your left is less than right, then only you do this, otherwise stop. Okay, this is your merge sort. So by doing this, what you will get is you will get the values divided. But where's the concept of merge? We are calling merge, but we are not defined the merge function yet. Now this is where things gets complicated. Not exactly complicated, but it's a lengthy process. So what we need to do is, when you say merge, of course you have to pass all these values here. Now in this merge, what we are going to do. Now basically the first thing is you need to create 2 arrays. So I will not write the exact logic here, but let me just draw something. What we need is, we basically need 2 arrays here. When you say merge, at one time you need 2 arrays. Example, so when we are combining these two, we got 1 array. So at one point you need 2 arrays to combine so that you will get one big array. Same goes here. When you got 2 arrays here, we need to combine them to get a big array. So that means every time I call merge, I need 2 arrays. We'll call them, let's say, left array and right array. Okay, so we got 2 arrays here. The next thing we need to do is we need to copy the elements of the left array and the right array. This is empty at this point. So we need to copy these values from the actual array. Okay. Now, so we need to write a for loop which will copy data from the array. So basically it will copy data from the array and put them in this list. Okay. So maybe I will just write copy values. Again, we'll see the actual logic in the code itself. Okay. Next thing we have to do is, once we have done with the copying part, you will simply use these 2 arrays to combine to get a bigger array. Now, how will you do this? So of course there should be partition here, there should be some values. So what we will do is let's work with the last values here. So we got the last value as 5, 8, 9 and 1, 6, 7. So the logic of combining this is you will need multiple variables here. You need a variable I, you need a variable j. Now why we need these 2 variables? One to represent this particular array and one to represent this particular array to iterate. Then we also need a k, which will be used for the big array which you're going to create. So from these 3 values or 3 values, you're going to create an array of 6, right? So k will be handling this part. Now every time you copy one element, so let's say when you compare 5 and 1 and you know that you're going to copy 1 here, so basically the j value will shift here, right? Because this is done. The same thing goes here. So once you got 1, next time you will get 5 here. Then you have to increment this here. So I goes here. And of course, every time you copy element in the bigger array, you will increment the value of k. That's the logic. Okay. So this is how you are going to complete the merge sort. Now, how exactly you have to write the code, that we'll see in the practical video. So I hope merge sort makes sense, where you basically break down the entire array into small chunks and then you combine them to get the sorted values. So now let's implement this logic with the help of Java. Now, the thing is, first we need a array, right? So let's create an array here. So I will say int arr, and this will have certain values. So let's have some values here. We'll say 3, 5, 1, 4, 6, 2. So we got these values here. And let's apply the sorting techniques on this. So before sorting, I will print some values. I'll say for in array. And let's print these values. So I will say print n, but I will also make sure that I will put a space. I will not print on new line. And once it is done, I'll print a new line. And then after sorting also, so I will say this, I will just write it here. After sorting. So here let's do the same thing. And let's say after sorting, it should print some value. But at this point, if you run this code, let's run this. And you can see in the output, they both are unsorted. So because that's why we have to do some sorting here, right? So let's apply the sorting logic. So what I will do is I will simply call a merge sort method, which will basically accept 3 values, the arr, the L. Now L here is 0. And then you have to also pass the array.length -1. Basically you have to pass the R value as well. Remember, we have to pass 3 variables. Now, since we don't have this method, I will simply say more action, create this method. And you can see we got this method here. And let me just put this method not here, but on top. Now, this is where the actual logic is going to happen. So you can see we got two variables. This should be L and this should be R. So left and right. Okay. Now, as for the logic, if you can see in our logic, we have already mentioned this logic. So basically what we have to do is we have to first check if the L value is less than R, then only you do certain things. And what are the things you have to do? Basically, you have to find the middle value. So I will say int mid is equal to L plus R divided by 2. And then you have to call merge sort 2 times. Again, I'm just going with the logic which I've written in the code or in the board here. So you have to pass ARR, and then you have to pass the L, and then you have to pass mid. That's how you create two different arrays. So mid plus 1 and R. Okay, and then you will simply say merge. Of course, right after doing this sorting, after breaking it down, you have to also merge. But while doing merge, you have to pass 3 values. ARR, you have to pass the left, mid, and right. You have to pass these 3 values. So this is the only logic you have to write inside merge sort method. But then we have to also complete merging because dividing is very easy. This is how basically you are dividing the values. The difficult part is merging them. So let's implement merge here. So I will just go back here, more actions, create a method merge. Yes, so I got a method. At this point, there are private methods is because I'm going to call from the same class, but depending upon your requirement, you can just change them. And now the actual logic goes here, the merge. Okay, now as I mentioned, you need to create 2 arrays here, right? So if you can see the logic, we need 2 arrays. Let's name this as LRR, which is the left array. And this will be an array. But the question is, what will be size of it? Because when I create this array, I have to mention the size. I don't know what is the size here. Now, based on when it is getting called, it will be different size. But the question is how we are going to know the size. And that's where this L, M, all this thing comes, or L, R comes into picture. So let's use that and let's get the size. So if you want the size of the first array, the first section, basically you can simply say mid minus L. Because for the first array, it starts with L. If you can see here, it starts with L and ends with mid. So if you say mid minus L, you will get the length, right? But the problem is, since this is 0 indexing, we have to also add plus 1 because mid is not representing the size of the array. It represents the index value. So you have to say plus 1. Then you will get the second array length with the help of R minus mid. So we'll just put some space here so that it will be much more visible. Okay, so you can see we got these 2 values and this is the size you have to mention here. The first array will be of size n1, the second array will be of size n2. That's done. The next step is actually to copy the values. If you can see, we are mentioning the copy values here, right, in the notes. Now, how do you copy value? We can use a for loop and let's use 2 different variables. I will say x and y this time. X is equal to 0 and depending on the size of the array. So for the first array, the size is n1 and x plus plus. Not used to using x and y inside a for loop, but let's try. So how do you copy? So ARR, this values, which is x. Now how will you get the values? So from ARR, from the main array, we have to start from the left. So you have to say left plus x. That's how you get the values. So whatever value of the L is. Example, if you look at here, for the first array, the index is 0, 1, 2. But let's say if you are merging the second array, this one, the index value is 3, 4, 5, right? So whatever value of L is, which is the left, which is 3 in this case, it is 3 plus x. That's how you will copy. And done. So this is for the first one. Let's do the same thing, but a different values. So I will just copy this for the second array. Okay, we can also use x here, no problem. We can say n2, and this will go into the right array. But the question is, what will be the value here? Now, any guess? So when you say on the right hand side, it is your mid plus 1, because we are not considering the mid value for the next array. Example, if you go up, the mid here was 2, but we started with 3. So you have to say 2 plus 1, mid plus 1, so that you will get 3. Okay, so we copied was the next step. And now the actual work starts of merging. And already mentioned we need 2 variables. One is I equal to 0. We also need j for the second array. So first array will be counted with I and second array will be handled by j. But we also need one more counter which will represent the main array, right? And this value will start with L. because we have to start from the left hand side. Now once we get these three values, let's start merging them. So we have to do multiple times, right? When you say merge, you have to take value from here. Example, when we were doing this, we would compare the first two values, compare the next two values. That's how we were doing, right? So when to end this? If your I value is less than n1 and not this and j value is less than n2, we'll continue till this point. If they are not true, then we'll have to stop, because that means we have actually reached the end. But now question arises, how will you merge? And that's where you have to start comparing values. Now when you say compare, what it means? Compare 5 and 1. So basically the first element of this array and the first element of this array, let's compare them. How will you do that? So we'll simply check if the L array of I, because that's what is representing the L array, which is the I variable. If it is less than, and we can also say equal to, what if they're equal? Then we have to compare this with the R array of J. If the left one is smaller, in this case the R one is smaller, not the left one, but let's say if the left one is smaller, in that case you will put that into the main array. So array K is equal to L array, not length, L array of I. Now since we have used, so let's say this was a smaller value, and once we have used this, we have to cancel this, right? I mean, this is done. So we can shift our pointer to the next element. How do you shift your, not the pointer, but the reference? You will simply say I plus plus here in this case. But what if it is not same, or what if it is not true? In that case, you will go to else part. You will do the same thing, but not with the left array. This time you will do with the right array and then the j variable, and you will say j plus plus. And every time you run this loop, because see, after one iteration of this loop, basically you will get the first value of the array, right? Main array. You will simply say k plus plus, because you have to also increment this. So once I is done, because k is here, once I is done, you have to move k here. Okay, and that's why we're doing k plus plus. And that's it. This is your merge sort. Let's see if that works. Let's refresh this or this rerun, and we got an error. Something went wrong. You can see everything was going well, but this 4 is not at the right place. We got 1 there. Because sometimes what may happen is, when you're copying two arrays, what if the values are left in one of the array? Example, if you look at our example, when we were copying this, remember when we were completing the entire task, these two elements were remaining from the first array, which goes at the end. So that thing is not covered yet. So what you do is, for the remaining elements of the particular array, you will again run a while loop here. So you will say, if I is still not equal or still not less than n1, you will simply copy the remaining elements, whatever is left. Because after this loop, at least one array will be ended, okay? So we have to work for the second, the remaining element of one of the array, maybe left hand side or right hand side. First, we'll try to understand left hand side. Let's see what happens on the left hand side. Simply copy all the values. So you will say ARR of k is equal to, we have to copy from the left array, and let's use I here. Now every time you do this, you will increment both the elements, I and k both. So this is for the left hand side left out values. The same thing should be done for the right hand side. So this time I will say j is less than n2. In that case you will copy, but not from the left hand side. You will do it from the right hand side. The variable is j, and the increment you will do for j plus plus. Okay, and let's run this. And you can see now it is sorted. And now it doesn't matter what values you have. Let's take the values which we have written on the board, which was 8. What was the value? 8, 5, 9, 1, 6, 7. And if you run this, you can see we got sorted values. Let's add some more values here just to remove the confusion with different values. Let's say 1, 1, 1. This is 57. And now let's see 6, 7, 8, 9, 57, 75, 1, 1, 1. So this is your merge sort. So the steps, basically you have to first do the breakdown of, you have to break the array down into small chunks, and then you have to also merge them. The only thing you have to remember is, when we were drawing this, we were going in two sections, right? Something like this. We were saying, okay, we will create two different sections, and then first section will break into two parts, and second section will break into two parts. No, that's not how it is working. If you observe, what it will do is, it will break down the entire section into two parts, yes, but then first only you will get the first part. Then you're not going to the second part, okay? You're not looking at here. This is not there yet. You're still into the first part. Then this will divide into a section. You will get this 8, 5. Then you're dividing into two sections, which you will get 8, 5. And then you will merge them. Then you will start breaking down the second part, which is 9. Okay, 9 was still not there. Then once this is also merged, once you get this, it will start working on the next part. Then it will work on this. It will work on this, merge, and merge. Break down, then you get 7, then you merge this two, and then once you have merged, then it will go for the next two. So it's not exactly breaking down the entire section equally. It's basically going from left to right. So yeah, that's how things are working out, and this is your merge sort with the help of Java code, and I hope this makes sense. Let me know in the comment section. In this video, we'll talk about linked list. In the last video, we have talked about arrays and what are the drawbacks in array. Now, one of the drawbacks which we have seen is once you define the size of an array, you cannot expand it, or you cannot even shrink it. But in case of linked list, we can do that. Now in linked list, what we can do is we can create a collection of elements, and every element will be linked with each other. Okay, so let's make it simple now. So what I will do is, let's take an example here. I will take 4 values. Let's say I want to take values like 12. The next value is, let's say, 6, and then we have 8, and then we have 3. So I want to store this 4 values. So I want to say 12, 6, 8, and 3. I want to store it as a collection, not individual, because if you want to work with individual values, you could have created 4 variables and you can assign those values. But if you want to keep it as one collection, in normal way, we can create an array, but the only problem is you cannot expand it. So in linked list, what we do is we use a concept of a data and a reference. Now what it means. Now, first of all, to store these values, I will not go for any continuous memory. What I will do is I will create these 4 boxes. So the first box will have a value 12. The second box, maybe it's anywhere. So you have a sequential memory, right? You can have your data anywhere. But just to make it simple, just to represent in a dynamic format, I'm doing it in CLY. So we have one more value here, which is 6. And then let me just draw one more here, which is 8. And the last one, which is 3. So we have these 4 values. We have 12, 6, 8, and 3. Now what I want to do is I want to say this is a collection, but then it is possible that they are not in a continuous location. There might be some elements in between. So let's say we have 12 here. After that, we have some element here, maybe A, B. Then you'll be having some more than maybe 5 to 6 elements in between, maybe 15, 20 elements in between. So they're not continuous, right? So when I say I have these elements, they are not in sequence. Example, if I want to say, hey, I want to fetch the third value, how can you mention third value? Because you don't have any sequence. If you want to make them in sequence, what you have to do is, first of all, you have to make the first element as a head. So you have to make this as a head. So once you have made this head, that means this is the first element. So that is simple. But how about the second element? How do you link the first one and the second one? Now to make it work, we will call each element here as nodes. So the elements which we are using here are nodes. So this is a node, this is also a node, the 8 is also a node, and 3 is also a node. And of course, all these are elements. So node value is 12, node value is 6, node value is 8, and node value is 3. You can call them as value, you can call them as info. Now, how do you link this 12 and 6? The way you link is by creating one more memory here, or one more box. Now, this node will have 2 things. The first one is the info. So this 12 here is the info, and the next one will be the address of the next node. Now, every node will have an address, of course, right? So let's say the address for this node is 512. That's the address for this node. The address for this node is, let's say, 326. The address for this node is, let's say, 101. And the address for this node is, let's say, 202. So we have all this address here. Now in this box, this will have the address of the next node. So in our example, 6 is our next node, right? If you want to have 8 as a next node, you can write the address of 8 here. But in this case, 6 is our next node. As you can see the sequence here. I want to maintain the sequence. You can say 3, 2, 6. So this is the address of the next node. That means we have a line between this. So we have a line between the first node and the second node. So this node 1, this node 2, node 3, and node 4. Now, as you guessed it right, in 6, you will be having the address of 8, which is 101. So this is 101 here. And this one will have 202. So we have a reference. So this is a link. And even this is a link. And that's quite simple, right? But the problem is, what about the last element? Now, of course, we don't have any element after that. Even there, we'll be having an address. But then address of what? So it will be null. Now, since we don't have anything after that, it is null. So we have the first node here, which is 12. This is the first node, second node, third node, and fourth node. And fourth node will be null because we don't have anything after that. This is how you create a linked list. So we have a list of values and they all are linked. And that's why they say linked, because they all are linked, and a list because they are it's a list. So once we have all these values assigned, this is a list. Now, if you remember, in the start of the session, we said this is expandable. So when I say it is expandable, how do I start the first one? I mean, how do I add the element anywhere? So maybe I will start by adding the element at the end. Maybe I want to add the element here after 3. So let's say in the list, we have one more value here, let's say 7. And how do we add 7 at the end here? So what you can do is, it's a very simple step, just create a node here, whatever node you want. And the value for this node will be 7. So this is the value, right? What about the address? Now this is the last one, you can simply put here null. So you can say this is null because this is the last one. But then we have mentioned 3 as null, right? But then now 3 is not the last element. The last element is 7. So after 3 also we have 7. And this 7 will also have an address. Let's say the address for this one is 126. This is the address. If you want to link this, you have to mention after 3 we have 7. So what you will do is you have to change this value. So now you cannot have null here. Now you have to make it 126. After 3 we have 7, right? So you have to mention the address here. And then we can give an arrow. So this is the 7 is the last element here. After 3 we have 7. That's how you can simply add the value. It's that simple. Can we add the value at the start? Yeah, it's quite possible. The only thing you have to do is again create a node. So we got a next node here, and let's say the value before 12 as well, I want to assign a value like 5. I want to have a value 5 here. So what you can do is you can make the value 5 here. And how do I refer? So now there's one more change. You cannot refer the 12 as the head element now. So 12 is no more the head element. Now the head element is 5. And of course this will have an address. So let's say 5 is at address 306. That's the address. Now what you will do is in 5, after 5, the element is 12, right? So we have to mention the address of 12 here, which is 512. So 51. So after 5 we have 12. So that means we have an arrow. So 5 is the first element now because that is head. And then after that we have 12. After that we have 6. After that we have 8. So that's how we can add the value at the start. Now can we add at the value in somewhere in middle? And the answer is yes, it's quite possible. What you can do is you can create one more box here. Let me make a box, and that box will have a value. So what I want to add, so between 6 and 8 I want to add, let's say 9. So I want to add 9 between 6 and 8. So you can create a 9, you can have a 9 value here, and then it will have its own address, let's say 506. I hope that address is not covered here. So we have 506 here. I know if you can observe, I'm giving random values or random addresses because all these values will be stored somewhere else you don't even know, right? They're not in sequence. I mean, you will know by the address, but then they're not in sequence. So if you don't have these links, you cannot fetch them in sequence. Okay, so now in 9, so we have to mention 9 comes before 8. So 9 will have an address of 8, which is 101. So now 9 is linking to 8. That means we have to remove, we have to of course remove this link, but then if you remove this link, what should I put here? So 6, so inside 6 will be not, so the address will not be of 8 now, it will be of 9. So we have to say 506, and we have to give an arrow. So of course we are not using this arrow anymore. So after 6 we have 9, after 9 we have 8. So that's how you can add values in between. So it's not comfortable because we are not consuming data in a continuous location. So we can create as many nodes as possible, provided you have enough memory in your system. It will create a number of nodes, and all these nodes will be connected with a linked list. Now this type of linked list which we have created here is called as a singly linked list because it is single linked list. That means we also have a doubly linked list or double linked list. Yes, we also have a double linked list. We'll see that in the one of the videos in future. But now this is a single linked list. So this is better than arrays, right? So before we have talked about arrays, and now we are talking about linked list. So now you tell me which is better. Is it array or linked list? Now, of course, both have their advantage and drawback, but what is the advantage? So the advantage of using linked list is it is expandable. You can increase the size of the list, you can reduce the size of the list, right? So you can say the advantage here is expandable. But the problem in linked list is it is slow. So when I say drawbacks, it is slow when you compare with array, because in array it works with index numbers. Now since everything is stored in a sequence, it works with index numbers and you can fetch the value randomly. So the benefit of array is you can fetch the value randomly, right? So that's the positivity of it. So let's say this is arrow positive value, and so linked list drawback is it's slow. We have to also mention the drawback of array, right? In fact, we have talked about in the previous video. It's not expandable. So yes, linked list is slow because if you want to fetch a particular value, let's say if you want to fetch 8, you cannot directly go to 8. You have to go from 5. So first you have to go to 5, then you can go, first you have to go to 5, then you have to go to 12. So you have to follow that sequence, and then you can reach to 8. In fact, we also have a concept of big O notation. Again, we have not discussed that yet. So we'll say big O notation would be big O n. So if you want to search for the value, you have to say big O n. Again, we'll talk about it later. Remember that linked list for search, it uses big O n. So it is time consuming compared to array in terms of searching. But if you want to fetch, if you want to insert value in between, linked list is the best one. Now this can be implemented using any language which you like. You can implement this with C, you can implement that with C++, you can implement it with Java, or maybe Python. In this video, we'll see the implementation of linked list. In the earlier videos, we have talked about why do we need linked list and what is linked list. So let's try to implement that with the help of Java language. Again, you can implement that concept with any language which you love. In this video, we'll focus on Java. We have two sections on this screen. We have on the left hand side, we have Eclipse IDE. Again, you can use any IDE which you prefer. You can use IntelliJ, you can use NetBeans. I will be using Eclipse here. On the right hand side, I have a paint, so that if I want to show you any diagrammatical representation of that, whatever we are doing, you can see on the right hand side. So what exactly we need? So just to make a quick recap, what we have learned till now is when you talk about linked list, we have representation like this. We have nodes. Now these are our nodes, right? So let's create a first node here. So this is our first node, and let's say I want to store values like 5, 12, 6, 9. I don't know why I love these numbers. And let's say we have 8. So I want to store these 5 values. That's it. Nothing fancy, just 5 values in a linked list. So in linked list, what we do is we create individual nodes. So all these things are called as nodes, right? So this is a node, and then we'll create another node. So this node will have a value which is 5. And then we'll be having another node here, which is, let's say, value 12, and this node will have some address. And we'll be having one more node here, let's say 6. So this is 6. We have one more node here, which is 9. Again, I'm doing it purposefully, creating the objects anywhere. And then let's say we have 8 here. So we have all these nodes here. So this node, which is of 5, will be linked with 12. We have to find a way to link these two nodes, and then we have to find a way to link these two nodes, and this node. And this node. This is what we are going to do. So once we can link this node, in future, if you want to add some new elements, you can do that very easily. Every node will have two things: a value. So this is your value, and this is your address. Now this is an address of the next node. Now in C programming, we can use pointers, but in Java, what we do is we create a reference of the next object. Java is all about objects, right? So of course, this node is also object. So this is the first object. So you can say this is the first object, this is the second object. So the first object will have a reference of the second object. The second object will have a reference of the third object. Now again, we don't number them, but then every object will have a reference of some other object. The last object here will have nothing. It will have null, right? So we don't have any other object after that. So we'll be having null. Maybe after some time, we'll add one more node. The reference of that node will be assigned here. So let's try to implement this. So what are the things we need here? So let's see what are things we need in Java perspective. So of course we need to create objects, right? So before getting the object, we need to use a class. So the first class we need is a node class, because a node class will have two things. A node class will have a data, and a node class will have the next node. So data will be of type int. Again, you can have any data you want. You can have a string data. You can have any object, maybe alien object, maybe accounts object, maybe a laptop object, your wish. And then the next node will be of type node itself, because this will refer to the next node. A node class. So this is a class which has two things. We have a data and a node. Then what are the class we need? We need a linked list class, right? Because linked list class will have certain features, because when you talk about linked list, it has certain methods. Example, we are going to look at insert. So we look at insert. Now insert will add data at the end. So let's say if I specify data as 5, it will add that at the end of the list. What if you want to add in between? So you will say insert, and you will say insert at. I want to specify the position. Let's say I want to specify position 3, or the index the value 3, and the value is, let's say, 12. So I want to add 12 at the location 3. Maybe I want to add element at the end. So I will say insert, or maybe at the start. We're already done with the end, right? So we'll say insert start. So I want to insert at start. So you can say I want to insert the start, which is 18. So it will add at the start. So this will add at the end, this will add at in between, and this will at the start. You maybe want to delete the data as well. So you can also use a delete method, and in delete you have to specify the index. Let's specify the index as 2. So it will delete the element at index value 2. These are the options I want to perform in my class. And then to run this, of course, we need a class which has a main method. So we'll have a main method in which you will be doing all these operations. So you will be having main, and then a main will have all the execution. It will have a linked list object, and then using that linked list object, we can perform all these operations. And then, we also want a show method, right? So show method will display all the elements. So if you want to display all the elements, you can do that. So this is what you'll be doing here. So in total, we need 3 classes here. So this is the first class we want to work with, this second class we want to work with, and the third class. So let's create these 3 classes in our Java code. So let's do that. So I will say right click and let me create a Java class here. I will say this class name as node, because the first thing which we are going to do is node. Now this node will have 2 things as we have discussed. The first thing it will have is the index value. I guess the font is not visible. Let me just do that. So now I would say this node will have the first thing, which is the int data. And as I mentioned, you can use any data you want. You can go for int, float, double, alien type, data, any complex type if you want. And the next thing is the node itself. So the node object which is next. So this node is a reference. So this next is a reference for the next node. Quite simple, right? So we have public class node and we have just 2 things. Nothing fancy here. We got just 2 things. You can make it more efficient. You can make it this private variables, and you can use getter setters. But then just to keep it simple, I'm doing this code. The next thing we need is a class which is called as linked list. But what if, okay, let's create a main class first. I will say the main class, and the main class name will be runner. Again, you can have any name, doesn't matter. We have runner class which has a main method. Now what if, or maybe I don't want to create my own list, I want to use the inbuilt feature. So in fact, in collection API, you do have a linked list as a class. So you can say linked list, I will say list equal to new linked list. In fact, you can use the internal one as well. You can simply use this class and you can say list dot. We have an add method. So using add, you can specify which object you want to add. Maybe I want to add 5. So this is same as the thing which we are going to do. We are going to use insert. Yeah. And then we'll be having list dot add. You can specify the index value where you want to add. Let's say I want to add the index value at 4, and you can add the element as, let's say, 12. So the same thing which we are doing here, maybe index value 3, which we're talking about. And then you can also delete elements. So you can say list dot delete. Okay, we have remove. So we have remove, we can specify the index value. The method which I'm going to use is delete. And then do we have a show method? We don't have a show method here, but we have size. Okay, we are missing size there. We'll be doing that later. And okay, we don't have the show method here, but then we have iterator using which you can fetch all the values. In fact, you can print the entire list as it is. That will work. This is how you work with list. But then I don't want to use the internal implementation. I want to go for my own implementation. So of course we need a class. So I would say the class name is linked list itself. Again, don't get confused with the name which we are using and which is provided by Java. I'm going for the same name, but since they're in different package, we can have our own class names. Now this class need to have certain methods, right? Even before creating a method here, what I'm going to do is every list will have one thing, and that one thing is, okay, so how do you know that this is a first node? Now, if you remember, we use a concept of a head node. So the first node will be referred as head node. And where do we define it? So in the list itself, I can say I have a node which I will call as head node. So this will refer to the first node. Okay, that's it. So we got that node there. Let's implement the functions. First of all, this code is difficult to understand it in the first go. What I would say is watch the entire video and then try it by yourself. So maybe you'll be watching this video 2 to 3 times. So make sure that you also practice this. That's where you will get this concept. Okay, so let's start with the first method. So the first method we want to go for is insert. So let's do that. So I would say public void insert. That's the first method I want to go for. And this will accept an integer value. I would say integer data itself. So this is what I'm expecting from the user. Now this data I want to assign to a node. So whenever you call insert, what we have to do is we have to first create a node. So what I will do is I will just clear this up. So let's use this area here on this side. So what we are going to do is every time you say insert, you will be creating a new node. So let's get a node here, and this node will have a value which is whatever value you are passing. So what we are going to do here is let's create a new node, and then the way you create a new node is by saying node, and let's name that node as node itself, and we'll say new node. This is how you create object, right? So we got a node there. The moment you say node equal to new node, this is what you will be getting in your memory. The next thing we have to mention is two values of it. So we'll say node.data, the data which is coming from the user. So whatever user is passing, let's say if a user pass 5, the node will get the value 5. Just to make it more realistic, what I will do is I will also create the object of list, the linked list here in the main. So I would say linked list, I would name this as list itself equal to new linked list. And in this linked list, I have only one method, right, which is insert. This insert will take a value. Let's say I'm passing 5. So this method will call 5. It will pass 5, and that 5 will be assigned to a node, which means this node here, it will be having a value which is 5. That's simple, right? And by default, the value of this one will be null. So we got our first node. But then it is possible that this is our first node, because what we are expecting is when you say insert, it will add the data at the end. So if you already have a list with you, it will simply add data at the end. But what if you don't have a data itself? I mean, you don't have a list itself. This is your first node. In that scenario, you have to check, because if this is your first node, then the head would be null, right? Because by default, the value for this head is null. So if it is your first object, this is the first object we are inserting, so head is null. So we'll verify if the head is equal to null. In this case, I would say the node itself is a head. So we'll say head equal to node. So the first node itself is a head. But what if that is not a scenario? What if this is not your first node? We already have some nodes there. In that case, you will go for the else part. So the first case we are checking is what if your head is null? So then when you say head is null, it means you don't have any nodes in the list. So whatever node you are adding is a first node. In that case, we got the node. By default, the next value is null. In fact, you can, if you want to make it more readable, you can assign that to null. Even if you don't do that, that's fine, because by default, the value for the object is null. But then this looks more readable, right? So you can do that. So if it is a first object, that's become your head. But what if this is not the first object? In that case, you will create a node and you will make it as head. Okay, now why I'm doing this? It's because let's imagine you already have a list. So let's say if you have multiple nodes here, we got 6, and in fact, let's go back to the original diagram. Now you can see if I'm adding a node in between or somewhere here. So let's say I'm adding a new node, which is let's say, okay, the value which I'm passing here is not, let's say, not 5. It is let's say 18. I'm passing 18 now. So we got a new node. And of course, this is not the first node which we are adding. So head is pointing to 5. So in this case, what it will do is it will assign the value here, which is 18, right? We got 18 value here, but then this is getting added at the end, right? But that means after 8. What we have to do is we have to first check which is the last element. How do I know which is the last element? And that's where you have to start with the first location. So from the first location, you will travel from first location to the last location. Now that is tricky, right? How do we travel? Is it that easy? No, it's not that easy, but just try to understand. So from the first one, we'll go to head first, and using head, we'll jump to the next node. So from the second node, you will jump to the third node. From the third node, you can jump to the fourth node, and then fifth node. And then, but how do we stop? Where do we stop? So we have to stop the moment you get null as the next value. Okay, now this looks simple. So to traverse, you have to use a node, right? A temporary node which will hold the data, and that is, let's say, n here. So we'll say while n dot next. Since we have to traverse between different nodes, so we'll use a while loop. So we will travel till you got a null value. The moment you get a null value, the while loop will stop. So how do we traverse? So what we are doing is we are saying n dot next equal to null. So we have a temporary node here. Let's imagine I'm doing that node. I'm creating that node here. This is a temporary node, and I will call this node as n. Now this node will first refer to the head node. So it will refer to the head node, and then head node will check. Do we have a null value here? No, we don't have a null value. We have the address of the second node. In this case, a reference of second node. So it is not null. Okay, so then we have to jump from here to here. Now how do we jump? So to jump, what we will do is we will change. Earlier this was referring to this node, right? Now we have to refer to this node. Now how will you get this node? It's very easy. You will say n is equal to n dot next. So now you are jumping between nodes. So if it is not null, let's jump to second node. If this is not null, let's jump to third node. And using while loop, you can do that. Now this will stop the moment you get null at the end. Now once you got the null, what you will do is once you got this null here, you have to change this value. You have to change from null here. So this is not null anymore. So this will refer to the new node which you have created. Now how will you do that? So to do that, we have to say n dot next is equal to the new node which you have created. That means the value of this node, because the current n value is referring to this node, right? Again, this is the tricky part in Java. You have to work with objects. So imagine when the loop gets over. So at this location, when the loop gets over, you are here at this node. Yeah, you are here at this node. Now what you do is you have to just change this null to the next node, whichever you have. So this is the new node, right? So this is a node in our case. So the value of node will be assigned to the current node dot next, which is this value. So this will be replaced by the node reference. So you don't have a null anymore. And this is null by default. Now if you can see the code here, we have a null value here, right? Okay, this looks cool. Now this is how you insert value. Can we verify? Now even if you can verify, we don't have a way to print all the values, right? So I will insert the data and I will also try to print it. Now how do we print it? We can use a show method to print all the values. So I will say public void show to print all the values. And how do I print the values? So we will use some methods we will use some statements to print here. Now how do we print the values? So same steps. You have to traverse from between all these nodes. Now how will you travel between all these nodes? Is you have to say node n. Again, you can say node equal to head. So initially you have to start with head, and then we'll be using a while loop. We have to travel, right? So when you want to travel, you will use a while loop. So you will say n dot node dot next is not equal to null. This is how you travel. And then, so while traveling, you will print the data of the node. So you will say system.out.println, and you will print the data of the node. So you will say node.data. That's it. This is what you are going to do. And every time you print it, you just have to shift to the next node. And the way you can shift to the next node is by saying node equal to node.next. This is how you shift. Now see this loop, the same loop. So same while loop, the only thing which you're doing here is we are printing it. That's it. Okay, I hope this will work, but let's try. So what I will do is I will insert not one value, I will insert 3 to 4 values. So I will say list dot insert, and I will insert 45 as well. And I will say list dot insert, I would say 12. Okay, let's add 3 values, and at the end I will say list dot show. I hope this will work now. So let's run this code. Right click and say run as Java application, and we got the output, but with one mistake. You are getting 18 and 45. That's perfect. We are not getting 12. So what's wrong? Is it not getting added, or is it not getting printed? I think it's not getting printed. It's because you are traversing till null, right? The moment you get null, you are stopping it. In this case, we only have 3 nodes. So in this case, we only have 3 nodes. Let me just draw that here. So we got the first node as 18, the second node as 45, and the third node as 12. So you got these 3 nodes, right? So this node is referring to this node. That means this is not null value. So this is not null. Even this is not null. But this, okay, this is referring to this object, right? So this is null. So this here is null. So it will stop as soon as you get null. Oh, okay, that's weird. That means we are not printing this one. But we are reaching to this point, right? So when you say it will print data, it will not print data which has an object which is null. In that case, let's do it manually. So I would say system.out.println, and here I will say node.data. So for the last element, you have to print it outside the loop, because it will not getting printed in the loop itself. Now let's run the loop, run the code, and you can see we got those 3 beautiful values. So just to make a quick recap, what we have done, we have created 2 methods here. One is insert and one is show. In insert, what we are doing is we are creating a node, because that's what we do. Every time you say insert, it will create a new node, and that node will have a value which is, so whatever data you are passing will be assigned to that node. Now, if you want me to go for a quick run through of this, we can use a debugger. So what we will do is we'll use a debugger here, and let's apply a breakpoint. This is where I want to apply a break. And then I will run this in debug mode. I will say run as, okay, where's the debug mode? It's here. And let's jump to the locations. So we'll say F5, and F5 will take to the next thing. So what we are doing is, the moment you got a linked list, so I will just draw it here. So the moment you got a linked list, it will create the first element. So when you say insert, so insert, what it is doing is, it is saying, it will create a new node for you. So here it will create a new node. Okay, we got the node there. And then we are saying, okay, it will go to node class, it will take those two values, and then it will assign the data. So data is 18. Can you see that? It's 18, and we got 18. Yeah, and the ID for this is 22. So let me just write 22 somewhere. So we got 22. So the value is 18 and the value ID is 22. And then it is saying null. So the next one is null here. And then it is saying, if it is null, is the head element null? Yes, by default is null. So head is null here. Right, head is by default null. In this case, this becomes your head. So head will point to this location now, and then it will not go to else part, because if got executed, it will jump back to the second value, which is 45. So in this case, it will try to insert 45. So the same step, it will create a node for you. If I jump into this, you can see it is creating a new node, and with those two beautiful values, which is data and next, it is assigned data, which is 45. So we got 45 here, and then the next value is, so this is null. Now, when you say null, it will jump to the next location. Is it head null? No, head is not null, right? Because head is pointing to the first node here. So if will not get executed, it will execute the else part, and that's working. Now it will drive us between the elements, right? So first it will jump to head and check if, so it will traverse. The first element itself is null. So it will directly jump to the location here, and it will say the n, this dot next. So this value will be replaced by the reference of the next element, which is 20. Okay, what is the ID for this? The ID for this node is 23. So this will refer 23 now, and then it will jump back to the insert the third block, and we got the object here with the value 12. The same steps will happen. Now it will again go back. It will create the object, assign the data 12, and then this will be null. So the text will be null here. And then it will jump to next. It will jump to head. Is it so head is null? No, head is pointing to the 18th location, so it will not execute the if block. It will execute the else block. In else block, it will traverse from the head block to the end block. So is the first block is null? You can say no, it's not null. So it will execute. It will say jump to the next location. So now n is referring here. Now is it null? Yes, it is null. You can see that it is null. So the moment you get null, it will execute. It will say the n dot next. Next is this one. So this will be replaced by the ID 24. So the ID for this object is 24. This will be 24 here, and then you got a link. It's that simple. The end of the code. And then when the moment you say show, what we are doing in show is we are jumping from one location to another location. So it will start with the head location, and it will check, is it null? No, it's not null. So let's print the value. So it will print the value of it, which is 18. So we got 18 there. You can see the output console window here. We got 18. And then when you say next, you can see it is printing the next node now. So it is referring to the node 23. Is it? Yeah. So now 23, and then it will print the value data of that, which is 45. And now so the moment I go back, you can see the node ID is 24 now. It is referring to 24, and it will print the data, which is 12. So this is the beauty of linked list. Now you can add values anywhere. Again, this is a lengthy video, so what I will do is the remaining part we'll see in the next video, where we'll talk about the other methods which we have discussed. We'll talk about insert, at start, delete, and show. So the next one will be faster because we have seen the difficult part. So I hope you understood something about linked list. Again, you may want to rewatch this video again. So let me know in the comment section if it was helpful. So now let's see, how do we add element at the start? So we have seen how to insert the element at the end. Now we'll see how to add the element at the start. So what we're going to do here is let's create another method, and we'll name this method as public void insert, and then we'll say insert at start. Okay, so we just have to pass a value there. So I would say the value would be int data. That's the value we are going to pass. Now let's try to add the value. Now how do we add the value? So if you think about this same thing which we have drawn before, let me just take you there. Now if you remember this image, now I want to add an element at the start. So I would say a new element, and this element will go at the start. So let's say the element is maybe 25. So I want to add 25, and this will go at the start now. Now when you say start, it simply means that you just need to change your head location from the current object to a new object. So this is the new head location, and the value or the address for this one would be the earlier first element, which is 18. So the ID is 22. So I want this 22 to be here so that it will refer to this element now. So now the new element is at the start. So the head will become the new element, and it will have the address of the previous first element. So let's see how do we implement that. So same steps, we have to get a node. So I can, I can simply copy paste the code now. What I can do is I can say, okay, the same thing will remain, this thing will remain same. So I will copy and paste it here. Again, we cannot say copy paste, I can say code reuse. So I would say paste here. And once I got the value, the only thing we have to do now is the node. So we have to say head node is equal to node, the current node. Okay, so when you say you have to say head equal to node, so the current node will become the head. But even before doing that, I just need to verify, I just need to mention that the next node for this, so the current node, next node should be the first node, and it is then in the head, right? So head is the first node initially. So I would say before assign the node to head, you will say node dot next. I want to say head. So whatever value was having with the head will be the next for this one. So let's say this node is maybe, let's name it as N6. So this node will have an address of this node. Initially this node was head, so we can simply say node.next is equal to head. It's that simple. Let's verify if it is working. Just to verify that, what I'm going to do is, let's go back to runner. After adding 12, let's say insert at start. I will say insert at start, and the element I want to insert is 25. So now 25 becomes the first element. Let's run this code, and you can see we got 25 at the start. So this is simple. Now you can add the element at start itself. At start, what we are doing is we are creating a node and just saying that the node next element would be the previous head node, and now head will be changed to the node. So head will be pointing to the first node, the node which you have created just now. That is how you insert at start. The next method we are going to do is insert at any location. So I would say insert at, and then we have to specify two things. The first thing you have to mention is the index value, and then you specify the actual data. Now when you specify index value, maybe I want to insert a data here. So I would say list dot insert, and I would say insert at position 2. Now index number normally starts with 0, and we'll say data is, let's say 55. So I want to add 55 at location 2. So when I say location 2, it is 0 location. So this is my 0th object now, and this is the first, this is the second one, and this is third one. So when I say I want to insert this 55 at, okay, I want to add 55 object at index 2, which means here. So we got a new object, and this will be 55, and this will have some address. So this object, the first object will refer to the new object, and the new object will refer to this one. So now this becomes 3, and this becomes 4. In fact, we don't have to number that, but then this is how you push. You have to push this one to the next location. So what you will do is you will just mention this node will change to this address, and the new node which you have created will refer to the next object. Okay, now how do we do that? And why are we getting error there? So I will go back to my linked list. I guess I've not saved it. Now how do we mention that? So to achieve that, what we will do is we'll say node equal to new node. Again, the same steps. In fact, we could have copied it. So we'll say paste. Yeah, so this thing is for sure there with every insert. Now in this case, we have to traverse, right? Because we have specified the index value, we have to traverse from that location to the index value. And to travel, we have to again start with the node, the head node. So I will say n equal to head. So remember, whenever you want to traverse, you have to always say node n equal to head. Now how do we traverse? Now since we know the index value, so whenever you know the value, it's always better to start with a loop. So with that trace, what we have to go to this point. So if your index value is 2, you have to reach till 1. So if index value is 2, you have to reach till 1, because in 1 you have to make the changes, right? So if I say index value 2, you have to make the changes here. I guess this thing is not properly visible. Let me just rewrite again. as I'm very bad with handwriting. So let me just do that once again. So I got the first object here. So we got the first object which is 18, and which is referring to the next object which is 45, which is referring to the next object. Let's say this is 12. And before that we got 25, right? Because 25 is the first element now. So 25 referring to 18, 18 referring to 45, 45 referring to this one. Now when I say you want to count, when I say index value 2, it means this is 0. I have to start with 0. This is 1, and this is 2, and this is 3. Now when you say 2, that means you have to create a new node here, somewhere here. And let's say the value is 55. So you have to reach till this node first. In this node, you have to change the location from here from this arrow to this arrow, and from here you have to refer this one. So first you have to reach till this point. Now since the index value is 2, you have to reach till 1. How do we reach till 1? Is by saying, let me just go back there. So we'll use a for loop, and in here I would say int I equal to 0, and I would say I less than equal to index minus 1, and I would say I plus plus. In fact, not minus 1, we'll say index. Now every time you traverse, you have to say n equal to n dot next. That's how you traverse, right? Okay, now there's one change. When you say next, that means we have to say minus 1, because we have to reach here this node by referring next. So because next itself is going for the next node, so you have to say minus 1. You have to come 1 back. Once you reach till this point, you just need to change the address, right? You have to change the address of this node with the new node. But even before doing that, I will change the address of this node to this node. So this node, the new node which I have created, that is node. So this, in this current situation, this is node, and this is n. I want to have the value of node next to this value. Now to achieve that, what we will do here is we'll say node dot next is equal to n dot next. So n is this one. So whatever value is there here will go into this node, right? Because this value is nothing but the pointer or the reference to the next node. Okay, we have done that. Now we have to update this value. So this node, so the 18th node now will have the address of this node. And to do that, we simply say n dot next is equal to node. And by doing this, our job is done. Let's verify. So I would say insert at 2. Let me just run this code, and you can see we got 55 at 2. So 25, 18, and 55. It's that simple. Awesome, right? So this is how you add the element in between. But there's only one twist. What if I add at 0th location? Because for 0 location it is a bit different, right? So if I run this code now, you can see it is adding at the first location, so it is not working. So for 0, we have to put a special condition here. So we will check if the index value is equal to 0. What we will do is we'll simply call, because see, when you say 0, it means you want to add at start, right? So you simply call that method start by passing this data. So in case if the index value is 0, that means your intention is to start from the first location. So you have to say insert at start. So this is how you add the element at any location which you want. So I hope you got the idea how to add at start and how to add at any location. So till this point, we have seen how to insert data into list, how to insert data at the start of the list, and then how to insert at specific index. So if you can see, we have a value which is 18, 45, 12, and 25, and then we are also adding 55 at the start. So if I run this code, we should be having 5 elements, right? But then I made a mistake. So if I run this code, you can see I made one mistake. I'm getting this 55 2 times. So what went wrong? If you can see the code here, we are saying whenever you insert at the start, and if the index value is 0, then you need to execute this code. That means we should not be executing the other code as well, right? I mean, this thing is need to be skipped, and we are not doing that. And that's why you can see we are inserting 55 2 times. So this code here should go into the else part, which we missed in the last video. I will just put a else block here, and after putting that else block, I will just go back to my runner, and if I run this code now, you can see we got 55 only 1. So yes, that was one mistake in the last video. So I just made some correction here. So there should be an else here. It's working now. You can see we got 55. So just to draw here, whatever we have done till now, so let's start with the first one. So what we are doing is with this line of code, we'll create your first box here, and let me just write a box which is 18, and let's give an address which is 501. That's my first address. Let's have one more. So when you say 45, we got a second box. So when you add this list, you will get 45 here. The value is 45. Now let's say this is 502. So of course, this 18 here will have an address of 502. So it will link to this box. And then when we are saying add 12, so we got one more box here which is 12. And let's say this has some address with, let's say, 503. So for 45 here, we'll have 503 now. So we got this link here. We got one more, which is 25, but 25 will go at start. So we got a new box here, which is 25. Initially, we were having a head, which was referring to 18 at the start of location. But now that head is not referring here. The head is referring to this new box 25, because we are saying start at the start. So this will have its own address, like 495. This is the address. It can go anywhere. It's not just when you say it will add a start, it will have this value. It can have any value, maybe 595, maybe 695 or 795. It doesn't matter. Now here it will have 501. So this will refer to the next element. So the sequence is 25, 18, 45 and 12. And of course 12 will have null. And then we are saying insert at 0th location. So we are adding one more element, which is 55. So we got 55, which is going at, and let's say 55 has its own address. We'll say this is 702. 55 will have 495 because the head value. And then this will refer here. Now head will not be referring to the 25. Head will refer to this new location. So that's how you insert value in between or at the end. So we have seen all those stuff. The next thing which is remaining now is delete, right? So how do I perform delete operation? So let's say I want to delete this 18 here. So I want to delete this 18 with index number 0, 1, 2. So I want to delete this index value 2. Now how will you do that? So when you want to delete this index value 2, so what we normally do is so the only thing we have to do is just change this address. That's it. The only thing we have to change is change this address. So here, instead of having 501, we need to change this to 502. Our job will be done, right? So when you say this is 502, it will refer to the next node and will not be using this node anymore. So this is gone. Okay, now how do we execute that? So let's go back to our linked list and let's add one more method, which is delete. So before show here, I would say delete, public void delete, and this will take an index value. So I would say index, int index. Now technically the name should be delete at, right? So it should be delete at, because we are specifying the index value. Okay, now we have a special scenario here. What if you want to delete the first index? So if you want to delete this one, which is the first index here, now in that case, you just need to change one thing. You need to change your head location with this one. That's the only thing you do, right? And how do we achieve that? So we say if my index value is equal to 0, in that case, I will change my head location. So the head location will change to the next node. And what is next node? It is referred with the head node dot next. So I would say head dot next. So head will become head dot next, and that's it. This is what you do when you want to delete the first element. It's that simple. But what if it's not a first element? So we'll go for else part again. And here we have to traverse. Remember, whenever you want to traverse, you have to do something. If you want to traverse, remember this, we were using a for loop or a while loop. We'll go for loop because we're using index value, right? So remember this code here, the same thing. From here to here, everything remains same. We have to traverse to that location. So let's go there. I will say copy, and we can just reuse the code here. So we are traversing, right? So from the head node, we are traversing to that location. Now once you reach to that location, so now when you pass a value 2 here, so the index value when is 2, so this loop will run only once, right? Because the index value is 2, so 2 minus 1 is 1, and we are going till I less than 1, which is 0 itself. So this loop will iterate only once. That means the current n value which we're representing after the loop would be this n. So this 1 will be your n. So n is 1. Now I want this value, which is 502, because so that if I know this 502, you can assign that value in this box. And the way you do that is by using this node in some temporary variable. So I will say that there is n1. So when I say n1 now, I'm representing this object, and when I say n, I'm representing this object or this node. So I would say, first of all, I want to assign n1 is equal to n dot next. That's how you will get this reference. So if you want to use this object here, you have to, if you want to make it n1, you have to say n dot next, because n dot next is n1, right? Oh, but we don't have n1 anymore. So we'll say node n1 is equal to null, so that we can refer that. So we have to declare that object first. Now once I got n and n1, the only thing which you have to do now is the n object. So when I say n dot next, so the n dot next need to be replaced by n1 dot next. And it's very simple now. You can simply say n dot next is equal to n1 dot next. Okay, and then once you got the value, you can simply say system.out.println, and you can print the value if you want. So just want to verify if everything is working properly, you can delete the element which you want to delete. So I will say I want to delete n1 because that's what we're doing. We want to delete n1, right? So we'll say n1 and let's print the value of n1, which is n1 dot data. So we'll know at least which one is getting deleted. Now how to verify this? Let's go back to our runner and let's delete a value after some time. So we'll say list.delete. I want to delete the element at index number 2, which is 18 in this case. Let's run this code. And you can see after running, we don't have 18 anymore in the list. Yeah, this is getting printed in the delete method itself. If I don't print something here, even it will not print 18 there. So yes, we can delete the value just by using delete method. So we have delete at, it will be used to delete the value at the particular index. So that is awesome. This is how you delete the element. The only thing we did here is we just changed the reference, right? So this element address is changed by the new one, which is 502, not 501 in this case. And that's it. This is how you break the links. Okay, there's one problem. This object is still there. It is deleted from the list, but it's still there. If you want to nullify it, you can do that. You can simply say n1 equal to null so that it will be eligible for garbage collection, right? So if I run this code now, you can see we have removed 18 and it is not there in the memory as well. It is eligible for garbage collection. So that's how you can delete this data. And in this video, we'll talk about stack. Now what stack means? Now stack is basically an ADT in data structures, and as you know, ADT stands for abstract data type. So when you talk about abstract data type, we only focus on the features it provides but not the implementation. Now in stack, it provides you multiple features. When I say features, we have a list of features like we can add element, and normally when you want to add element, we use a term called as push. You can delete the element using pop, so you can do that with the help of pop, or you cannot say delete, but you can take out the element from the stack, and then you can also look for the element. So you can find an element, the first element, and then you can do that with the help of peek. Again, we'll understand this in detail later. So we can apply a push operation, we can say pop and we can say peek. Stack, it supports a feature called as leaf4, which is last in first out, which simply means whatever element you have inserted last, you can access that first. So leaf4 stands for last in first out. So whatever element you have added last, you can access that first. To explain this, we will be having a stack here. So the last element you have inserted is the first you can take out. And in stack, you have only one entry point. So you have only one entry and exit point. That means this is the only entry and this is the only exit. So this one will remain closed. You can apply a lock here. So this one will remain closed. The only place where you can enter the values is from one point. From here, and you can take it out. So whatever element you have inserted last, you can access that first. But do we use this in real world? And the answer is yes. Example, let's say if you are working on a task. So let's say if you're working on a project, it's a very big project. Maybe that project is, let's say A, and that project will take 6 days. So it will take 6 days to complete this project. And suddenly the old project or the old version, which is already deployed on the server, it is giving you an error. Now let's say you got a bug. Now at that point, what do you think? Will you complete the entire A project and then you will think about the bug, or you will try to fix the bug first? And of course, right, a bug is something which a user is facing nowadays. So of course you have to fix the bug first, and then you have to think about the earlier task. So in this scenario, you will try to fix this bug. That means you are keeping your job A aside and you're focusing on B now. So you started working on B and you thought, okay, in next 3 to 4 hours, I will complete this B. I will fix this bug. So you're keeping this task A aside and you're working on B now. And suddenly that this is your lunch time now. So you're going for a lunch. So let's say this is 1 p.m. and then you want to have your lunch. You're going for the lunch now. So let's say that is task C. So task C is your lunch time. And now you are having your lunch. So while you're having your lunch, of course, you will not be working on B at the same time. Because when you're having a lunch, you should do only one thing at a time. You should have your lunch. So when you're working on, you're doing your lunch, you will not be working on B. That means you have kept B aside. Now, once you complete your lunch, what do you think? Which is the first task you will resume? A or B? It's B, right? Because this is the last task you have left. So when you say B, this is what you left last. So last in, first out. So this is what you will resume. And once you complete B, then you will resume with your A. So that is last in, first out. So the last task which you are working is the first thing you will resume. Now, do we use this in some other concept? Yes. Example, if you have a stack of books. So whenever you have a stack of books, what you do is the first book, so you will keep the first book here, then second book, then third book, and then fourth book. So once you keep all this book one above other, the first book you can access is the last book you have kept here, right? So this is how so let's say if you have kept one more book here, then this is the last book you can access first, or this is the book you can access first. What about virtual world? So in virtual world as well, when you talk about recent applications, so in Windows we say Alt Tab. So when you say Alt Tab, it will show all the applications which you are working with. So when I say Alt Tab here, you can see this is the first application. This is the last access application. So you can see that first, which is Paint. Then I got this recording software, which I have opened second last. And then I was working on a notepad. That's the third. So that's the third in the list. And before that, I have opened my computer, and before that, I went to Google or Chrome. So this is the stack, right? So the last access element is coming it first here. So yes, we use stack a lot of time in real world and in virtual world as well. So let's try to understand how do we work with elements. So let's say I want to store these 4 elements here. We got 5, we got 8, we got 3, and we got 2. So I want to insert these values in a stack. So what we do is we create a stack here, and again, if you want to insert the value, we will use push. So using push, you can insert the value. Using pop, you can get the value, the last value. And using find, if you don't want to delete the value from the stack, you just want to see the value, you can use peek. Question is, how do we implement this? In fact, we will be seeing the implementation later, but then there are multiple ways of implementing this. We have the array way, so you can implement that with the help of array. In fact, in array as well, we can go for fixed length array. Then we can go for dynamic length array, or then we can also go for linked list. So we have different implementation. So we can go with the array implementation using fixed or dynamic length. We can go for linked list, but doesn't matter what you go for. Let's say if you talk about array. So let's say if I create an array of 4 elements here, right? So we got an array of 4 elements, and this is index value 0, index value 1, index value 2, index value 3. Now how will you insert the value? So this is the only entry point and this is the only exit point, right? So if you want to enter the values, you will be using a method called as push, or a function called as push. In this push, you will pass the value. So whatever value you want to pass, let's say if I say I will represent 5 or 8 or 3 or 2, whatever you pass. So once you pass a value here, that value will be assigned to 0. So let's say we got 5 here. Then when you say 8, 8 will be assigned here. Now once you inserted this 2 value, or maybe let's say add 3 as well. So we got 3 here. Now which is the last element you can access? So if you have entered 3, this is the last element you can access. But how do you know which is the last element? So you can simply use a variable called as top. Now top will have the an index value of the recent element. So index value 2, we have element 3. This is the top element. And when you insert 2 now, the 2 will go here. Simple, right? Now how about if I say pop? So when you say push, everything going in this tag where you say 5, 8, 3, 2. So the value will go down. And then when you say pop, it will remove the first element, because when you say you have inserted 2, this is where you are representing your top, right? This is the topmost element. So this is the element which will remove first. So when you say pop, it will remove this 2. And let's say after that, if you're inserting 12, so let's say after that, after saying pop, you're inserting 12. So 12 will come here because that's the last element you can access. So again, that will go back to 2. Yeah, when you delete this element 2 before, it will go back to 3, okay? The top variable will go back to the index number 2, which is 3 in this case. So this is how you push and you pop. So the last element which is added is the first thing you have an access. So when you say pop, it will delete the element, it will give you the element and to delete the element from the stack. But what if you don't want to delete the element? You can simply use find, and to use find, we normally use a function name as peek. So when you say peek, at this point, it will give you 12. Pretty cool, right? Now let's say once you have inserted all these values in the stack, and the stack is full, right? Because the size of the stack was 4. We can make it dynamic, we can use linked list, but let's say if I'm using a fixed length array. So if you're using a fixed length array here, and if you have crossed the limit of your stack, which is 4 in this case, if I try to add one more element, so at the end here, if I try to add an element which is 1, now the moment you say 1, if you try to add 1, it will give you an error, and that error is overflow error, because you are trying to overflow the stack. That's one case. So if you try to push the value and if your size is full, it will give you overflow error. What if you try to delete the element? If you try to pop and your stack is empty, let's say if you don't have any element here. So if a stack is empty and if you try to fetch value at this point, it will give you another error. So if your stack is empty and you're trying to pop, it will give you error, which is underflow error. So underflow is when you don't have the value and try to pop the elements from it. So that's how you have overflow and underflow concept. Those are errors basically. And there's one more thing here. With this push, pop, and peek, we can use some other methods as well, or functions as well. Example, we can get the size of the stack using size method. You can also check if the stack is empty with the help of isEmpty function. So again, you can implement whatever methods you want, but these are the basic ones for stack. And in this video, we'll talk about the stack implementation using Java. Now, when you say a stack, basically stack is a class inside Java. So if I simply say control space, it belongs to a package java.util. So you can use all the features of a stack here. But then why to use an inbuilt class when you can create your own? So I don't want to use the stack class which is inbuilt. I want to create my own class. So what I will do, I will right click here on the package. I would say new, and I want to create my own class, and that class name is called a stack. So I have my own class here, and here I will create object of stack. I would say stack nums equal to new stack. Now in this stack object or the nums object, I want to perform certain operations. So when I say nums.push, I want to push the element. I can specify any value here. If I say 15, so the first element should be 15. And then again, I can push multiple elements, and then maybe I want to pop element, which is taking out the element from the stack, or maybe I want to fetch element. So when I say stack, basically it has certain features, right? As we discussed in the theory session, we can use push, we can use pop, and we can use pip. So we'll be working on these methods. So let's start with the first one, which is push. So if you can see in our stack, we don't have any method yet. So let's create certain methods. So the first method is push. Now to implement push, what I will do is I will say public void push. Now since we are adding the value, we are not expecting any value. So let's say push data. So we have to send the data and it will add data there. So now you can see if I go back, now you can push the element and there's no error. But then what you will do with the push? To make it work, first of all, we need to create an array, right? So we have to create an array, and we have to also specify the size of the array. So let's say if I say we have an array here, and initially we'll take an array of 5 elements, so that if you can work on 5 elements, you can work with any number of elements. So let's say if I have the first one, then the second one, then the third one, and fourth and fifth. So we have these 5 elements here. Index number will be 0, 1, 2, 3, and 4. Now if you want to add the first element, as we are doing it here, we are passing 15, right? So that 15 will go to the go to element 0. So somewhere here we'll be having that value, which is 15. But then we don't have array yet. So even before you push the element, you need to create that array. So let's do that. I would say int, and we'll say stack equal to, or stack, it's an array basically. So we'll say stack equal to new int, and the size of int is 5. You can make it dynamic. You can take the input from the user, what array size you want, but time being, let's specify by ourselves. So we have created the array, and now we can push the element. But question arises where? So we'll say, okay, when you say push, you will assign the value to the address location 0. Okay, so that makes sense. We can simply say 0 here, right? So we can say stack of 0, and you can assign the value whatever data is coming. It's so easy. That value, which is 15, will be assigned to the index value 0. It is that simple. But here's a twist. The twist is, what if I want to add one more element? So if I say nums, so if I push another element here, we'll say I want to pass maybe 8. Now we are passing 2 elements, right? We got 15 and we got 8. Now what will happen is, the moment you pass 8 here, the value 8 will be assigned to 0 again with the 0th location. That's not what we want, because if you run this code, the value 15 will be replaced by 8. We don't want that. I want to assign value to 1. That means we need to count it. We need to use a variable which will count the number. And maybe I will use a variable here which is called as top, and the initial value of top would be, let's say, 0. We can simply specify top here. Right, so instead of using 0, we can say top. Okay, now when the first element getting inserted, so when you insert 15, that 15 will be inserted here at the top location 0, right? So we got 15 here. Now if I send 8, oh, 8 is also, the value of top is still 0. That means after doing this thing, you have to simply say plus plus. So every time you push an element, you just need to increment the value of top. So that when you pass 8 now, 8 will be assigned to index value 1, because when you pass 8, the value of top at that point is 8. So yeah, so that is how you push the element in the stack. Okay, now next point would be, how will you fetch the element? Maybe I want to pop the element. Or even before, let's push all the element, and let's say I want to print it. I want to print the stack. So after pushing 2 or 3 values, let me just push one more. We have a stack of size 5. In that, let's say we have only 3 values. Let's say this is 15, 8, and 10. I want to print the entire stack, so I will say nums.show. So it should show the entire stack. But the problem is we don't have show method in the stack. So let's go there and say, hey, I want a show method here, which will print the entire stack. Now question arises, how do you print the entire stack? It's very simple actually. You can take a loop, enhanced for loop here, and you can say int n colon stack. That's an array, and you can print each value. And you can print that value with a space. So I will say n, and then I will print a space, so that, you know, when you print all the value, they should be separated with a space. Sounds cool. Let's go back, and what do you think? Will it work? Let's try. So I will right click here and we'll say run as Java application. And it worked. Can you see that we got 15, 8, and 10, and we got 0, 0. So yes, it is working. So stack is working when you say push. But how about pop? I want to remove the elements now. Is it simple? Let's try. So when I say pop, I will simply say public. Now pop will also fetch the value. So it will remove the value from the stack, and it will also fetch the value. So I would say int pop, and this will not take any parameter. Now how will you fetch the value? Now temporarily we can say int data is equal to, okay, first of all, let's declare that. How do you fetch a data? It's simple, right? We can say data equal to, the data is coming from stack. Now, the property of stack is, if you have 3 elements, as we defined here, we have 3 elements, right? We have 15, 8, and 10. Now, whenever you use pop, what do you think? Which element you will be getting? And by default, the value of 4 and 3 is 0, because that's how array works in Java. The point here is, when I say pop, which value I will get? So it is done with the help of top. So we have a top variable here, and whatever value we have for top, you will be fetching that value, because you will always get last in first out. So the last element which I have added is 10. So the top referring to 10 now, this location. So it will give you 10. And the way you do that is by simply saying, you will say stack, and you will say top. Now you will get that data. Quite simple, right? Okay, now we have to do one more thing. Now once you say you are removing this 10, we will be making it 0. So I will make this element as 0. And how do we do that? It's very simple. Let's go back here and say stack of top is equal to 0. So we are making it 0, so that again you can make it 0, you can make it negative value for whatever you want, and then at the end we can say return data. I hope it will work now. So let's run this code, and you can see we got, we are not saying pop. So we'll say nums dot pop. Now it will delete the last data, run, and you can, not working. What's wrong? What went wrong here? Okay, so we are saying top. Oh, okay, so we have to do one more thing. See, as you can see here, when I say push, the top value, so when I say push first time, the top value become 1, second time top value becomes 2, third time top value becomes 3. That means it is referring to this value. We need to do minus minus. We have to decrement the top before using it. So we'll say top minus minus. Is it? Let's try. So I will, I'm not even printing pop value. So whatever pop value I'm getting, I should be printing it, right? So I would say system.out.println. I hope this will work. But on this code, it worked. Now it worked. You can see that we are removing the value of 10 from the stack, and you got 0 here. Cool, right? So that's how you use push and pop. Now what else we can do? We can also implement peek here. And how do we do that? So peek is very simple. Peek is almost same as pop. The only thing is in peek, you don't delete the element. So I will paste it here, and I will say this is peek. Okay, you will not do minus minus, because if you do minus minus, it will decrement the value. But while you're fetching, you will be fetching the -1 of it. So we'll say -1, and you will not delete the element. That's what you will be doing. That's it. That's peek for you. After adding value 8, I will peek. I would say nums dot peek. If I run this code now, you can see we got 8. So the last value which I have inserted is 8 here. And then I'm pushing 10, then I'm popping 10. And you can see that's why in the stack we don't have 10. Simple. This is how you use push, peek, and pop. What else we can do here? Now we can implement certain other methods as well. Example, you can get a size of the stack. You can get you can make this dynamic instead of saying 5, whatever size defined by the user, or very dynamic, which is every time you add the element, even if the initial size is 5, you can change it. So you can increase the size on the go. We have talked about 3 methods. We have talked about push, pop, and peek. In fact, we have also used one more function, which is show, which will print all the elements of the stack. Now with this, we need 2 more methods. The first one is size. Now size will give you the size of the stack, and we also need a method called as isEmpty. Now isEmpty will be useful to check if the stack is empty. Now why do we need that? That we'll see in some time, but then let's implement these 2 methods first. Now to implement this, let's go back here, and I would say, in fact, after this peek, let's first implement the method which is size. So I will get the size of the stack. So I will say public int, the method name would be size, and here let's return top, because top will give the size, right? Okay, we have a top variable there. So when I return top, what do you think? Will it work? Let's try. So I would say go back and run, inside run. So let me just not pop any element here. So you can see we are pushing 3 elements, and then at the end I want to print the size of the stack. I would say nums.size. Now it should print the size for you. Let's run this code, and okay, it is printing 3 here, but you should also print the message. I would say size is, and I will say size is this one. Let's run this code, and you can see it says size 3. That's right, we have 3 elements. Let me just add one more, and I would say the value is, let's say 7. And if I run this code, it should say size is 4. Oh, that's working. You can see that it is working. And after that, if I remove any element, let me just say pop. I would say nums.pop. Of course, it will print 7, the pop value. But what's the size? Size becomes 3. So it works, right? When you push the element, it will increase the size. When you pop the element, it will decrease the size. That makes sense. I want to implement one more, which is isEmpty. So I would say public. Now isEmpty is a method which returns a boolean value. So whenever a method starts with is, it always returns a boolean value. I would say isEmpty. So let's return if the top is or less than equal to 0, then we have to say it is empty, right? So if it is not 0, which is more than 0, it's not empty, right? So let's go back to runner, and we have to check if it is empty. So I will check it here after everything. So I would say empty status. I want to check if it is empty. We'll say true or false. And the moment you do that, so we have to say nums is empty, right? And of course it is not empty, so it should print false. And you can see we got false. If I do the same thing before pushing any value, and if I run this code now, you can see it says true. And maybe if I push one element here, and after that if I pop, and again if I print is empty, it will say true, right? Because it is empty. So that's how we can implement these 2 methods. But what's the use of this implementing these 2 methods? Do we have any advantage? And the answer is yes. So what I will do is let me just do some experiment, and let me remove all the extra stuff from here. I don't want to peek. I just want to push multiple elements, and I don't want to do any of this stuff. Let's keep it simple. Say I'm only pushing elements, and then while I'm pushing, I will push 4 elements. And if I run this code, so yes, we got 4 elements. What if I try to push 5 elements? Will it work? Let's try. I would say 17, and if I run this code, and yes, it does work. What if I try to push one more, and let's say the value is maybe 77? In this case, if I run this code, you can see we got an exception, which is array index out of bounds exception. It's full, right? Because the stack is full. That means whenever your stack is full, you should not be adding the value. You should print the message to the user, hey, the stack is full. How will you do that? How will you check if the stack is full? And the way you do that, so every time you say push, so before pushing, you need to check, is it full? How do you check if it is full? The stack value is 5, right? The maximum size is 5. So I would say if this is equal to 4, that means your stack is full, right? So if it is 4, I would say stack is full. So I would say system.out.println stack is full. And this part will be executed in else part. Okay, let's go back here. And after every push, I will try to print show, so that we'll know what is happening. So I would say nums.show. And let's run this code now. And you can see at this point, it is saying stack is full. Oh, my bad. Okay, I guess I'm missing one more thing here. After printing this stuff, I just want to print a new line, so that every output I will get a new line. Okay, so you can see it is saying stack is full here itself, because I just made a mistake. It should not be 4, it should be more than 4. Why more than 4 is because Every time you say push, you can see we are incrementing the value here. So it is not 4, it is 5. Let's go back there and let's run this code, and you can see that after this point it says stack is full. So it will not allow to push the element after this point, so that you can save yourself from the exceptions, right? So that's how you can check if it is full. Now what I will do is I will try to pop. So I'm pushing all these elements, and after pushing this, if I try to pop the elements, and I would say system.out.println, I would say nums.pop, it will pop all the elements, and not all, it will pop only one at one point. So I will run this code. You can see at the end you got only one element, which is 17. That's great. In fact, I will not add all this element. I just want to add 3 elements so that we can save our job. So I'm adding only 3 elements now, and if I say pop, of course you will get the last element, which is 10, right? This is the last element which you have entered. I would say pop 2 more times, and you can see it will try to pop all the elements. So if I say print the size, I would say nums.size, it will print 0 because we don't have any element, right? So you can see we got 0. What if your stack is empty now, and if you try to pop? Now if you try to pop, it will give you exception, right? Because you don't have that value before that. So you don't have any value in -1. So that means you need to stop it before popping the element. How do you check? So we'll say if, so we have to do this only when, if your stack is empty, then you will not do all these things. You will simply print a message which is stack is empty. Otherwise we'll say else, and you got the point, right? So if I say tab, and if I run this code now, okay, I hope it will work. There's a problem here. Data, we have to initialize something. I would say data is by default 0. That's a local variable, right? So before returning it, we have to assign some value. And let's run this code now, and it worked. You can see that it says stack is empty. So it will not give you exception. So we have to take care of all this element as well, right? So that's it. I hope you understood what we have done. So we have implemented 2 things. One is size, and second is empty method. So using these 2 methods, we can check if the stack is full or the stack is empty before performing any operation. We have seen how do we implement stack using a fixed size array. So if you can see this example here, we have a stack class in which I'm creating a stack array, or basically an int array of size 5. And then we were able to push element, we were able to pop element, then we were able to peek, and then we were checking the size of the array, and then is empty, and then we were able to print all the values. And then using this we can perform the operation. The only problem here is we have a stack, and that's perfect. We have a stack here, and this stack does have a value which is 15, 8 and 10, but the problem is the size of this array is only 5, which means the maximum element you can go here is 5 elements. What if you want to go beyond that? What if you want to have a stack which is expandable? And that's where we have a concept of dynamic size array. But then how will you implement dynamic size array? So what we want here is the moment you say you have 5 elements. Let's say if you entered 2 more elements here, let's say 3 and 6. And after that, if you try to add 1 more element, which is 7, and now, of course we don't have the array size of size 6. So I want to create a new array. So it should create an array of maybe a new array in which you will be having all these values. Now when you say a new array, so what should be the size of that array? So I'm expecting the size of that array would be, so let's say the current array is of size 5, the next array should be of size 10. Technically we'll go with the power of 2. Initially we'll have an array of size 2. If you want to add more elements, we'll make it 4. If you add more elements, we'll go for 8. If you add more elements, we'll go for 16. This is what I'm planning for. But then how will you increase the size every time? So it's very simple. The current array is, so let's say if you have a current array, and let's name that array as stack. So that's your array. We will create a new array with a name. So let's say if I create a new array with a name as new stack. Now this new stack will be having a size of 4. But the problem is we got the new array. What about the values in it? So whatever value you have in this stack will be copied in the new array. That's what we want to implement. That's it. If you can do that, our job will be done. So every time you increase, you go beyond the limit, you have to simply expand your array. And okay, there's one more thing. What if you have an array size, let's say 16? Yeah. So as you add more elements, you'll be having an array size of 16. And let's say you have 16 values, and then you are saying pop, pop, pop for maybe 15 or 10, 12 times. In this case, let's say if you have only 3 elements now. So in total we have 3 elements and the size of this array is 16. That means you are wasting some memory, right? Or we want to have a feature where you can shrink the size. So we want an array. When you say array is dynamic, you want it to be expandable and you want it to be shrinkable. So we want to implement these 2 features. And if it is possible for us to implement these 2 features, that is what your dynamic size stack would be. So let's get started. So what I'm going to do here is, first of all, I want to copy the exact code because we will reuse the code here. And I will simply copy this code. I will say Control A, copy, and let's create a new class. And I will call this class as dynamic stack, or we'll say dstack. That will look like a dynamic stack. We are making a dynamic stack here, so let's say dstack, and we click on finish. And in this stack class, I want to have all those features. I will just simply paste it here. And if I go back up, there might be some issues. I have repeated the package, and the class name is dstack. Okay, now the first thing we need is, we cannot simply create an array of size 5. I want to create a variable with a variable name as capacity, and then let's say the capacity of this is 2. Initially we'll have a capacity of 2, and then we'll go beyond that. Normally we can go for a capacity of 4 or 8. That will make more sense, because normally when you say you have a stack, of course you'll be having more elements. But just to make it interesting, just to show you how it expand and shrink, we'll start with 2. And then here, when you create this array, I want to say this is 2. Again, we can write capacity here, right? So you're creating an array of that size. Initially, the array which you have is of size 2. Okay, that makes sense. Now, of course, we will be having a method which is size. We have the element which is empty. So everything will remain same. Now, what will change is the way you push. So when I say I want to push the element, and I don't want to print a message which is stack of full, we don't have any option there. Now, even if your stack is full, you want to expand this size. That means this code will happen for sure. You will be able to add the element. The only thing is, maybe if your stack is full, so you need to expand the size. And then how will you expand the size? So I will simply call a function or a method here called as expand. But when I want to call a method which is expand, so only when your stack is full. But how do we know if the stack is full? Okay, that's a good question, right? So if the size of the stack, which is say size is, okay, if I say size is equal to the capacity, then that means your stack is full. In that scenario, you will expand. That's it. Nothing much. In that scenario, you will expand. And anyway, you have to do this task. But question arises, what you will do in expand? What exactly happens in expand? Okay, let's think about it. What will happen in expand? So in expand, what we will do is we have to create a new array. That's the main idea, right? So let's say I want to get a method called as expand, which will be this method here. Again, you can make it public or private, doesn't matter. In this case, I'm keeping it private because I don't want to access this expand function from anywhere else. I just want to use the expand only from the current class. So I will use expand, and then the first step would be I want to get the current length. And the way you do that is by saying int length is equal to size. So when you say size method, it will give you the current length. Okay, that's simple. Now we have to create a new stack. And as we define in the diagram here, we will simply create a new stack, right? This is the new stack we have. So the way you do that is by saying, I would say I want to get a new stack. I would say int new stack, and then I will give a bracket equal to new. Okay, now the size of this stack would be doubled, right? So if the current size is 2, the next size would be 4, right? So I would say int, and then I will simply say capacity, whatever value of the capacity we have, I will simply say capacity into 2, our job will be done. So we got new stack, and then we are saying into 2. That makes sense. The next thing we have is, okay, so we got the new array. Now we have to copy the element from the current array to the new array. Now how do we do that? So we can run a loop here. We can use normal for loop. The best way would be to use inbuilt classes. Again, it's your choice, okay? You can use normal for loop. But since I'm lazy, I'll be using some inbuilt classes. So I would say system. I would say there's a method called as array copy. So thankfully we got this method, array copy. This array copy takes 5 parameters. The first parameter is from where you want to copy. So I want to copy from the stack array, which starts with the next value 0. Again, I want to copy the entire array, right? So I will start with 0, and then it will get copied to the new stack, and it would be 0. And then how many elements you want to copy? I want to copy all the elements. So I would say simply say length. Once you have copied everything, so in new stack you have all the new values. But then unfortunately, ultimately we are working with stack array itself, right? So even if you expand the new stack, everywhere we are using the stack reference. So of course we have to replace the stack reference with the new stack reference, so that everywhere else I'll be using the stack reference, which is representing new stack here. Okay, so once we have done with the stack, and now if you can observe, we have also increased the capacity. So I would say capacity is equal to the current capacity into 2. So I would simply say into equal to 2. So whatever capacity you have here, we are just trying to double it. That's it. It's so simple. And now let's go back to runner. Now instead of having the object of stack, let's say object of dstack, so that we will not get the exception. And I will not say pop this time. I will only focus on push. And every time I push the element, I would say show, just to get the output. I'd say copy, paste, paste. So you can see I'm entering 5 elements. The size of the array which we have here is only 2, right? But still we are trying to print 5. Let's run this code. Let's see if it is working. And it works. Can you see that? It works. So initially we were having 2 elements, no problem. We added new element. But then the moment you added 10, can you see that the capacity is not 3, it is 4. In this scenario, we have added 4 elements, and now the moment you add one more element, which is 10 again, we got the element of size 8. So that's how it is expanding. Cool, right? In fact, you can print the value using size, and you will get the exact size, whatever, or the capacity if you want to print. So that's how we are expanding it. So simple. That's why you say it's a dynamic array. The next point would be, how do we pop the elements? Because I also want to pop elements, right? So I would say pop is working. But then every time you say pop, I want to decrement, I want to shrink. Okay, first of all, I will not say is empty. Do you want to check is empty? Yeah, that sounds good. Is empty is a good checking. But every time I remove the element, I want to shrink. So I would say shrink. Now shrink may not work every time, but then whenever your size goes, okay, when do you want to shrink? That's a good question. So let's say if you have an array of 8, or maybe you have an array of 16, the size of this array is 16, but the elements you have, let's say 8. At this point, I don't want to shrink. But the moment elements goes or less than 4, so let's say if the number of elements is 1, 2, 3, or 4, in this scenario, I want to shrink it and I want to make it half of 16, which is 8. So even if I have 4 elements, I want to keep it 8. Let's see if I go beyond that. If I go below that, if I say I have 1 element, then I have to make it 2. Right? Of course, before going for 1, it will become 4, and then it will become 2. So the idea here is, if the number of elements goes below 3 by 4, we will make it half. So the size of your array becomes half. That's what we're going to do here in shrink. So let's implement shrink method. So I would say click and create a method called as shrink. Now inside this shrink method, I want to perform those operations. And how do we do that? Now, first of all, we want to know the length, because that's very important. So I would say length equal to size. And then once we got the size here, or once we got the length, now how do you shrink it? First of all, how do you know that your array is the number of elements in the array is less than 3 by 4? Now, there are multiple ways of doing these formulas. We can use left shift arrows. You can do some mathematical calculations. You know, since I'm lazy, I'll be using the simplest one, which I love. So I would say length is less than, I would say capacity, because so the operation which I'm doing now will give you half. So I would say divide by 2, it will give you half. And again, if I say divide by 2, it will give you the 1/4. In this scenario, what I want to do is I want to reduce the capacity by half. So I would say capacity is equal to capacity divided by 2. But then it's not just reducing the capacity, it's also about creating a new array. That's important, right? So what I will do is I will create a new array, which is, I would say, new stack again. And the question is, what should be the size of this array? And you guessed it right, it will be the new capacity, right? If your earlier array was of size 8, the new array would be of size 4. So this is where you're doing it. You're dividing by 2. Again, if you're thinking we will be getting a point value, don't worry. This is a part of 2. Capacity will always give you a part of 2 because we're expanding in that way. So it will not create an issue for you. Now, once you got the new array, the same thing, we can actually copy paste, you know. Okay, I cannot say copy paste. I should be saying code reuse. That will make more sense. Go back here and paste. And you can see we are creating a new array, we are copying the elements, and then we are saying stack equal to new stack. I hope it will work. Let's go back to runner. And then at this point, the size of your stack is 8. After that, I'm saying pop. So I would say, I don't want any value. I would simply say nums.pop. It should remove the element. And then I would say nums.show so that I will see the elements. And look at the size. It has removed the element. Let me just remove one more. In fact, two more. Just let's go beyond 3 or beyond 2. It will go, let's go to 2. And the moment you have a size 2, can you see that the array is getting shrinked? And if I go one more time, see the size, see the array size, it is getting shrinked. So that's how you make it dynamic. And in this video, we'll talk about queue. Now we have talked about linked list, we have talked about stack, and now it's time for queue. Now queue is almost same as stack. The difference would be in stack we use a concept of LIFO, which is last in first out, and in queue we use a concept of FIFO, which is first in first out. Which means whichever element arrived first will be the first one to go out. So it is first in, first out. Now in real world, whenever you want to take a movie ticket, you join a queue, right? So whoever arrived first will get the first ticket. In a queue, what we do is we have, let's say we can implement this with a different concept. We will be implementing this with an array. So you can do that with the help of array, or you can do that with the help of linked list. In this example, we'll look at how do we implement that with the help of array. In fact, in array itself, we can go with the flat array or we can go with the circular array, but we'll see the difference. Now, let's have the array of size 4 where you can have 4 elements. In this array, you'll be having two end. The end from where you will insert the value and the end from where you will take out the value. So this is your insert. So this is where you will insert the element and this is where you will take out the element. And that's why whichever element reaches first in the queue will be the first one to go out. Now let's say if I insert a value 5. So the 5 will be coming from here. It will go in this area. So the 5 will be saved here. The moment you insert a new value, let's say 2, it will go here. Let's say if I insert 7, it will go here. And let's say if I insert 3, it will go here. So this is how you add the elements. Now, if you want to delete the element, so this is the first element which go out. So 5 is the first element which go out. And then all this element, which is 2, 7, and 3, they will shift on left hand side. So 2 will come here, 7 will go on the place of 2, and 3 will go on the place of 7. And then you can add one more element at the end. That's what we are expecting from queue. So in queue, basically we have two end. One is from where you will insert the value and from where you can take out the value. So you can call this area or this thing called as front, and this is the rear end from where you're inserting the value. Now in queue, we can perform certain operations. So you can insert the values and you can remove the values the way we did with stack. In stack, we use a concept of pop or push. So push would be inserting values. In the same way in queue, we use a different term. So that term is enqueue. So enqueue is like inserting, or in stack, you can say push. If you want to remove the element, we use a word called as dequeue. So we have a concept of enqueue. So you can represent insertion with the help of enqueue, and you can remove the element with the help of dequeue. Now, of course, enqueue will take an element from you, so you have to pass a data, and then in dequeue, don't pass the value, but it will return your value. So let's say if you say dequeue and your front is 5, so it will give you 5. But let's say after that, also you are saying dequeue, it will give you 2. Now with these two methods, we can implement some more methods as well. Example, we can implement a method of size, which will give you the size of the queue. We can implement is empty if to check if it is empty. These are two methods we can also implement in this. We can also implement peek the way we did in stack. You can get the value which is going to be removed. It will not remove the value, but it will show you which is the value which is going to remove. Now, how do we implement this? So first step would be we need to create an array. So we have to create an array of, I will go for an array of size 5. I love this number 5. So I will go for the array of size 5, and then I will try to add the element. Now, how many variables we need here? So basically, when you talk about this implementation, maybe we need a front variable which will have the index number of the front, because every time, so initially when you don't have the value in the queue. So example, if I create another queue here, and if I say the queue is of size 5, so we're going to size of 5. So whenever you don't have any element, of course the front and rear both will not be referring here, but then the moment you add a value, front and rear both will refer to this value. So this is your front and this is your rear. But the moment you add more values, let's say if you have entered 5 and then 2, the rear will be pointing at this point. In fact, the rear we have to shift to this point when you insert 2 so that you can add 3. So rear will shift here. So every time you add a value, you will say rear plus plus. And every time you delete the value, you have to say front plus plus. So when you say delete, you have to say front plus plus, and whenever you insert, you will say rear plus. We'll see the implementation and then you will understand what I'm talking about. So I will go back here in the queue. And so you can see I have two classes. One we have is runner class, another we have is a queue class. I will go to queue and let's try to implement those methods. The first method we have to implement is enqueue. Oh, before that we need to create some certain variables. The first thing would be I want to create a queue itself. So I would say queue, and the size of this queue would be, let's say 5 initially, or this is not what you do it. So you say new int and you specify the size 5. You can make it dynamic, your choice, but initially I will go with the static one or fixed one so that it will be easier for you to understand. And then we need 3 variables. We'll say size, one of the variable. Then I need a variable which is front, which will refer to the front element. And then I will need a rear element, or rear variable, which will refer to the rear element. Once you got these 4 variables, and of course the value for this size would be 0, front will be 0, rear will be 0. And then I will create the method. So the method name is public void enqueue. This is my method which will take a int data, and then I will try to insert a value here. Now, how do we add the data into a enqueue? So for that, I will go back to this point and let me just make this an empty queue. Okay, so you can see that we got an empty queue here. So the name of this queue is queue itself. And now I want to insert a value. So let's say if I'm inserting a value which is 5. So in this queue, at the index value 0, I want to insert 5. Now, if you want to insert the value, we use a variable which is rear. And by default, rear has the value which is 0. In fact, front will be also referring to the first element at this point. So we'll say front is also 0, index number 0, index number 1, index number 2, 3, and 4. Now, front and rear both will refer to the same element here at the end. Now, the moment you add 5, so at the rear point, you have to insert 5. Now, how do we achieve that? So in the code itself, you will say queue of rear is equal to whatever data you are passing. So the data I'm passing is data itself. Now, once you have added the value, you need to do one thing. After adding the value 5, you just need to shift your rear to the next location, which is here. And how do we do that? How do we shift our rear? It's very easy. You simply say rear plus plus. So you will say rear is equal to rear plus 1, or you can say plus plus, that's fine. And then once you have added the value or incremented the value, now I also want to increase the size of it, right? So now the size is size plus plus, because we are not, in fact, we can write size equal to size plus 1 just to maintain the same sequence. So if you have rear equal to rear plus 1 and size equal to size plus 1, so every time you add the value, the size will increment. It's that simple. Time and let's work with enqueue, and then later we'll work with dequeue. I want to see the element as well. So let me say I want to create a show method which will print the elements. So we also need one more method here, which is show. So I would say show method as well. And show is responsible to print all the elements. And in this show, if I want to print elements, it will print all the elements from the queue. But how do we do that? So what I will do is I will say for loop. I will start with 0 initially. And then I would say, okay, till what point we have to go? I have to go till size, right? And then plus plus, because the size of the array may be, so you have inserted 3 values, so the size would be 3. So you have to go till I less than 3. And every time you go there, you just need to print the elements. And the way you can print the element is by saying the value q of I, and then you will also print a space after that. And here I want to print the elements. I would say system.out.println. I would say elements colon, so that it will give you a good format of printing. I don't want to println in there. That's it. It will work now. So we got enqueue, we got show. Now how do we verify? So let's go to runner, and in this runner, let me create an object of queue. I will say q is equal to new queue. I got the object which is queue, and in this queue I will add the element. I would say enqueue, I want to enqueue the first element, which is, let's say 5, as we have done here. Now after inserting 5, I will just simply say q.show. I want to see how many elements are there. And if you run this code, you can see we got 5. We got only 1 element. That's perfect. Let me just add one more element here, and that will be 2 in this case. I would say 2 here. And when you say 2, if I run this code, you can see we got 5 and 2. So every time you insert the value, it will get added in the queue. But question arises, how will you remove the element? And what happens when you go beyond the size? Let's say if I inserted 7 values, what will happen? And of course, if you insert 7 values or 6 values, it will give you a very famous error or the exception, which is array index outer bound exception. Till this point, we have only inserted the values. Now, how do we remove the values and how do we avoid the exceptions? So let's try to delete the values. And how do we do that? It's very simple. Just go back here and we just need to implement one simple method, which is dequeue. So I would say public, it will return the values. I would say dequeue, and it will not take any parameter. Now, how do we remove the elements? It is simple, right? So just go there. So when I say I have inserted 2 values, so we got 5 and 2. And let me just insert some more values. I will just try just to explain this in a better way. I would say I want to insert some more values. So in this list, in this queue, we got 7 and 3, right? So we got these values. I want to say dequeue now. So the moment you say dequeue, what should happen is it will remove 5 from the queue. So it will remove this 5. Now, when you say removing the value, maybe you will not remove the value. The only thing we have to do is we just need to move our front from this point to this point. So we just need to move our front, right? That's enough. So I would say, hey, front, just go to 2 here. Okay, that should work. I mean, we just have to increment our front. So what we'll do is when you say dequeue, first of all, I want to return a value. So I would say int data is equal to which value? The first value. And how do we get the first value is by asking, hey front, give me your value. So front will be index number 0, so it will give you the first element, which is 5. That's simple. And then every time you fetch the value we have to return the data as well, so we return the value here. But it's not just about returning value. We have to move the front to the next location. So how do we shift? We say front equal to front plus 1. It's that simple. And once you do that, we also need to reduce the size of it. So we'll say size minus minus. We can say size equal to size minus 1 just to keep the same syntax. Yeah. So we'll say size equal to size minus 1. So here we are saying size plus 1. Here we are saying size minus 1. That's it. It's so simple. Let's go back here. Now you can see we have inserted 5 values, and before calling show, in fact, if I call show at this point, you can see it will print all those 4 values. But if I say dequeue, so if before saying show, if I say dequeue, and if you run this code, you can see we got 5, 2, and 7. Oh, we got a problem here. We are not able to remove the last element. We have removed the front as well. So this is some problem with the front. The problem is you are starting from 0 and you are ending at size, right? That's perfect. But then you cannot simply say I here. You have to say front plus I, because we are shifting the front as well, right? So you don't want to start from 0. You have to start from front. And now if I run this code, you can see this is what we're expecting, right? We got 2, 7, and 3. We are removing the element which is 5. It's so simple. Now if I try to do this one more time, if I say dequeue, and you are guessing it right, we will getting only 7 and 3. So if you run this code, you can see we got 7 and 3. So this is how you enqueue and this is how you dequeue. Now after dequeuing it, what we are thinking is we only have 2 elements, right? So in an array we have only 2 elements, but that's not the case. Let me prove it. Let me just add 2 more elements at the end. Now, of course, it should work, right? Because in total, when you say dequeue, in total you have 2 elements, and I can insert 2 more elements there. I can say I want to insert 9, I want to insert 1. So this should get added, right? But the moment I run this code, we got an error, which is array index outer bound exception. Why? Because even if you are dequeuing it, you are not removing the elements. You are just shifting the pointers. In total, you have 4 values there. In fact, after these 4 values, you are adding 2 more elements. Just to prove my point, once again, I will go back to this show, and at the end, when I say show at the end, after printing the values, I want to print the array as it is. And the way you do that is we can use enhanced for loop, or we can use normal for loop as well. I can say q, and then I will print the element of n with a space there. Now if I run this code, you can see we got the exception. Let me just not do that here. I'll say comment, and let's run this. And you can see we are getting Okay, I just forgot one more thing. We just need to put a new line in between so that we'll get a difference. And if I run this code now, you can see it is working at this point because you are entering only 4 values and the size of the array is 5. So you're inserting 4 values, you're trying to remove those 2 values. So in total, you have 2 values which we are getting. But in array, we still have 4 elements. And that's why if you try to enqueue 2 more elements there, which means you are crossing the index value, which is 5. So index value last would be 4, right? But the moment you try to add more elements, it will give you error. And as you can see, we got error at this point. You cannot go beyond that point. In fact, the exact error would be at here because 9 will be inserted because we have space for that, not this value. The problem is arising because of this rear value. Because if you cross the 5th value, which is this one, index value at this point is 4. And after that, the value for rear becomes 5 and we don't have any element after that. And of course, the size of array itself is 5. You cannot go beyond that. At this point, what I want is, I want it to go back on this first one, which is, you can imagine this array in not as a linear array, but as a circular array. Now, this is just a representation. So you can imagine we have a circular array, which we have 4 elements. We have the first one, in fact, 5 elements, this third one. So 4 and 5. Let's say we have these 5 elements. So the starting value would be here. So this is, let's say, imagine your front and this is your rear itself. Every time you add value, let's say when you add value 5, it's here, rear value will become 2 here, and then 7 here, and then 3 here. Now, if you try to match this with the runner, what we just have to do is, imagine this is index value 0, and index value 1, index value 2, index value 3, and index value 4. Imagine this is how you work with it. And then after 4, I want to go back to 0. How do we do that? That's a question. So the moment you add these 4 values, we have added those 4 values. And then when you say dequeue, it simply means you just need to shift your pointer, right? So your front will be shifted to 0 and 1. So it will be shifted 2 times. And your front will represent the 7 value here. So this is your front now. This is no more your front. Now what about the rear value? So rear will shift here. So this is where your rear is. Now, if you add a value here, which is 9, it is getting added. What about this 1? The moment you try to add 1, it will try to go on index number 5. We should not be going for index number 5. We need to go to index number 0. That is where you call it as a circular array. So after 4, the index number will go to 0. That's it. If you can achieve that, your job is done. Oh, now that's a question. After 4, how can you make sure that your value becomes 0? Okay, so let's try. Now, when I say 0, so can I apply this operation? Because when I say, so when you say 5 mod 5 will give you 0, right? Because 0 is a remainder. So 5 mod 5 is 0. Now, when your real value is equal to 1, 1 mod 5 is equal to 1. When your R value is 2, R mod 5 is equal to 2. Then 3 mod 5 is equal to 3. And 4 mod 5 is equal to 4. And then here is a twist. Now, if you say, if you say 5 mod 5 is equal to 0, that's the beauty. We wanted 0, right? And we got 0. After that, when you say 6 mod 5 is equal to 1, that means we are going to the same loop. So the only thing we have to do is, every time you perform this operation, you just need to do a mod of 5. So if the size is 5, you will say mod of 5. Same goes with front. Because the front also should be in the loop, right? So you will say front and you will say mod 5. That's it. This is what you do. Now, if I run this code, it should work, and you can see it is working. Oh, it's not working. We still got an exception. But why? Are we doing in a perfect way? Yes, we are, but it is giving you error while printing. I guess that's the issue. If I go back to runner, yes, the problem is because of printing. So if I go back here, in printing as well, I need to perform that operation. Because you don't want to say front plus I, you want to say front plus I mod 5, because I don't know the current value of front, because it is going in circle. So I will run this code, you can see it is working. You can see we got the value, which is 7391. This is the exact loop. Can you see that? We got 739, and the next 2 elements are coming here, which is 1. 9 and 1. This is 2 is the previous element. It's so simple. That's how you can work with the circular loop. But we still have one issue. What if you try to add more elements? In fact, I will say copy and paste. Let's see what happens. I'm trying to add 2 more elements, which is 19 and let's say 15. So we wanted the value here, which is 7, 3. Okay, these two values, because we are removing these two values, right? 5 and 2 because of DQ. So these two elements and these 4 elements. In total, we have 6 elements. Let's see if it is working. And oh, it's working. You can see there's no problem, and it is getting increased. Oh, that's weird. Can you see that the array size is 5 and we are getting 6 values? It's because of the loop. So till this point, we have seen how to add the element and how to remove the element from a queue. We are here to add some methods like size of the queue. Then we want to know is the queue is full, or we want to know is the queue empty. Let's start with the toSize method or the size method. So I would say public. So return the size. So I would say size, or maybe get size will make more sense. Okay, now what it will return is simply it will return the value which is size. That's it. So we'll say return size. And now if I go back to runner, and after doing all these things, you can see I'm adding 4 elements and I'm removing 2, and then again I'm adding 4 elements. So in total we have 6 elements there, and unfortunately the size of our array is only 5. Let me just remove this as of now. So you can see we have 4 elements here. We are removing 2, and then we are again adding 2. So in total we have 4 elements there. Now if I want to know the size, of course I want to print the values, but I also want to print the size. So I will say system.println, and here I would say the size, and then I will print q.getSize. So it will print the size as well. And let's verify it is working. And the moment I run this code, you can see we got the size as 4. And that perfectly makes sense because we have 4 elements there. Now let's use is full or is empty method. So I would say public. Now how do you know if your queue is empty? So I would say public boolean is empty. So the way you know that it is empty is by returning if the size is 0. So we'll say return size is equal to 0. If it is 0, then of course it is empty, right? So that's what we are doing here. Now, how do you know if it is empty? So let's go back here, and I will not add any element. I will not delete any element there. Or maybe I will add 2. I will remove 2. Let me just comment. So you can see we are adding 2 and we are removing 2. And after that, if I say system.out.println, I would say q.isEmpty. So of course it will print true. So if I run this code, you can see we got true. But if you add a value and if you don't remove it, let's say if I uncomment this part and if I run this code, you can see we have one element there, so it will print false. So we have implemented is empty as well. And now let's go for is full. So it's very easy. Let's go back there and say public boolean is full. And here we just need to return if the size is equal to 5, because the queue size is 5. So we'll simply specify size equal to 5. In case if you're making dynamic, then you can also use a variable there. Let's go back here and you can check if it is full. So we have done with the empty. Let's go with full. And in full, what I will do is I will add some more values. I will uncomment this part and I will uncomment this part because I want to add 5 values and I don't want any removal. So you can see I'm adding 5 values there. The moment I run this code, it will say it is full, true. But if I add only 4 values, you can see it will print false. It is not full. So we have implemented is empty, is full, and get size. Now, how it will be useful? Now, instead of using size here, we can also use methods. Normally, this is what you do in Java. You always use methods to get the value. So you will say get size equal to 0, or you will say get size equal to 5. So normally we check with size. That's one thing. The next thing would be whenever you want to add the value. So before adding the value, we have to verify if it is not full. So we'll say if we have to do this only when it is not full. So if it is full, how do you know if it is not full? So we'll say not is full, then only you have to execute this statement. Otherwise you will print else message. You will say else and you will print the queue is full. And here also, okay, we have to just format the code to look it good. And in DQ as well, we want to remove only when it is not empty, because if it is empty, then what you will remove, right? So you will say if is empty, and this code will be executed only when it is not empty. Otherwise, you have to print a message. So I will say, first of all, this format that. And in else part, I will print queue is empty. Simple, right? So here we are checking it is full or is it empty here. Let's go back to runner and I will try to add more elements now. So you can see I'm adding 6 elements there. And the moment I run this code, you can see it will print the queue is full for this element here. And the size is 5 and you got all these elements. So that means 1 is not getting added. Now what if I delete the element? Let's say if I don't have any element in the queue and I'm trying to delete the element. So of course, If you don't have any element, of course, how can you remove that? So if I run this code, you can see it prints Q is empty. So in both the scenarios, Q is empty. So yeah, that's how you implement these methods. So let me recap. We have get size is empty and is full, and this will be used to check before adding the element and before removing the element. And in this video, we'll talk about a tree data structure. Now we have talked about linked list, stack, and queue. Now tree is another ADT. Now if we talk about tree, it is basically a structure where it's similar to linked list, you can say. So in linked list, what we have is, let's say if you have a node and you have B node. So what happens is A node will have a reference of B node, right? And then B node will have a reference of C node. So we have this in linear format. In tree, what we have is we have the almost similar structure, but then with a difference. In tree, we normally create a structure like a tree, but you can imagine a mirror image of a tree. Normally in tree, we have roots, we have branches, we have leaves. In the same way, if we talk about a tree here, imagine this is a root node, this is a root of the tree, and this A, instead of having one reference, may have multiple references. In this case, I'm getting three references. So A will be knowing about A will be knowing about C, and then D. So after A, we have these three nodes. Maybe this C itself will have some other nodes. Let's say we have X, and here we have Y, and maybe this D has one more node here, which is maybe K. So we have all these nodes here. Now this is the topmost node, right? So okay, every box here is called as nodes. So these are nodes here, and the line between these nodes are called as edge. So I would say this is edge. So we have this as node B, X, Y, C, all are nodes, and then this is edge. And the topmost is called as a root node because this is where your tree is getting started. This is your root node. Now, if you talk about this A, so A has a node which is B, A has a node which is C, and A has a node which is D, right? The same goes with C. C has X and Y. But what about this K? What about this Y and X? We don't have any other further nodes here. And in fact, B as well, we don't have other nodes. So these nodes are called as a leaf node because we don't have anything at the end after that. So the topmost is called as root node. This is where you will start your traversal. If you want to store data as well, you will start from the root node and then you will go down and down and down. So this is your node, and then the end nodes are called as leaf nodes. So these are normal nodes in between, but then A has a special name which is root node. Now this is about tree. This is so you can represent this with different languages using Java, C, C++, Python. Now with this, we have a very special type of tree which is called as a binary tree. Now what does binary tree means? Now binary means two, right? So if a node, so let's say if you have a node which is A, and if this node has two more nodes like C or D, so maximum if you have two nodes, this is called as a binary nodes. So we have two nodes, so binary nodes, and that's why the tree is called as binary tree, where every node will have max to max two nodes. So either we can have a zero node, or we can have one node, or we can have two nodes, not more than that. So this is how you represent your binary tree. Now, in fact, in binary tree as well, we have certain types. Let me just write it here. So we have certain types in binary tree. So first one is strict binary tree. So we have the first one, which is strict binary tree. Now, what is strict binary tree means? A tree where every node will have two subnodes or no children. So and again, we have one more term here. So the C and D are called as childrens. So if I have A here, and if A has two, which is C and D, then this is called as a strict binary tree. In fact, you can also have inside C, we can have two more nodes. Let's say we have X and we have Y. This is also a strict binary tree. Now you might be thinking about D. So yes, so when you say strict, it means either two or no children. So here you can see we don't have any children to D. Now how about if I say we have, let's say X has one more child, let's say K. Now in that scenario, this is not a strict binary tree because we have only one element or one children node for X. So this is not a strict, so let me just remove that. So this is the first type. The second type we have is full binary tree. Now what is full binary tree means? Where you have a tree where every node either has two, they will be having two subnodes. For example, we have C and D again, and D has two. Let's say we have X and Y, and D should also have two more nodes so that they will come on the same. So let's say we have P and Q here. right? So we have D also has two more nodes, which is P and Q. So A has C and D, and C has X and Y, and D has P and Q. So all the leaf nodes should be on the same level. So you can see they are on the same level. So this is what you call as a full binary tree, where all the children are on the same level. The third one is called as a complete binary tree. When do you say a binary tree is complete? It's very simple. Where you have a tree where all the nodes are on a level. So let's say if I define that C and D again, and here if I say X and Y, and then so this is also called as complete binary tree because you have all the leaf nodes on the level. So let's say this level is, let's say I will call this level as L. So either it should be on L level or L minus 1. Now, which means if you have one more here or two more here, let's say we have K and we have C. Now this is not a complete binary tree because the leaf node are not on L and L minus 1, because if I say this is L, then this is L minus 1, but this will not work. So there should be two more nodes here, then it will be called as complete binary tree, right? So this is not a complete binary tree. So if I undo, so this is a complete binary tree. Now let me draw a simple tree here. So if I say we have A, and then we have B, we have C, and then we have inside B we have D, we have E, and inside E we have F, and we have G. And then I will draw a line here. So these are all my nodes. And inside this F also we have two more nodes here. Let me just draw it. Let's say this is X and this is Y. So now looking at this tree, we have certain terms here. So again, this is a root node, right? So this is your root node, and this C, G, Y, X and Y and D, those are your leaf nodes. Now we have to remember two more terms, which is height and depth. Now what it means? So depth means, let's say if you talk about this E, so what is the depth of E? It is A, B and E. So that's the depth of this E. And what about the height of E? So height would be, it's the children's of E. So we have F and we have X, right? Maybe this X has two more subparts here. Let's say we have K and we have L. So now for E, it would be F, X and K. So this is the height of E. So when I say the depth of E would be 2, so we have 2 because it is A and B, right? So A and B, those are the two nodes we have. What about the height of E? It would be F, X and K. So it will be 3. So right, so height is 3. Now what about the depth of a root node? It's always 0, right? Because this is the first element, so we don't have any depth. What about the height of a root node? Is it, again, so you have to say A, B, E. So we have to go for the longest one. So it is A, B, E, F, X and K. So it's 1, 2, 3, 4, 5. So height of this tree is 5. Oh, that's a new term now. So we know the height of the root node, right? So height of the root node is same as height of the tree, or you can say height of the tree is same as height of the root node. So that's how we have these two terms are important when you go for the coding part. So yeah, that's it. That's what your tree thing is. So we have talked about what is tree. We have talked about binary tree. Now we'll be doing the implementation of this using different languages. So I hope you enjoyed this video. Let me know in the comment section. In the theory video of tree, we have talked about different types of tree. And when you implement this, we are going to implement that with the help of binary search tree. Now, what's the difference between binary tree and the binary search tree? Binary search tree is a binary tree. The difference is the way you add values. Now, in binary search tree, what you do is you always make sure that the smaller element is on the left-hand side and the bigger elements are on the right-hand side. That means if we talk about a root node, the elements on the left-hand side of a root node will be smaller than the root node, and the elements on the right-hand side of the root node will be bigger than the root node. It's that simple. That means when you try to create this tree, how will you do it? So let's say we have these values here. Now, when you work with 8, 8 becomes your root node. Okay, that's so simple. You always get your first element, make it a root node. Next, you have 7. Now, 7 is less than 8. So it will go on the left-hand side. So that is 7 here. Then you got 12. Now 12 is bigger than 8, so it will goes on the right-hand side. Now, of course, for the root node, both the nodes have been covered. What about the next element 15? Where 15 will go? Of course, you cannot create one more node here. That's not possible for the binary tree. So what you do is you travel. Now where to travel? Left or right? Now 15 is bigger than 8, so it will go on the right-hand side. but we already have 12 there. Now 12 have an option of putting 15 left or right. Now, since 15 is bigger than 12, it will go on the right hand side. So 15 goes here. Next element is 2. Now 2 is smaller than 8. Again, we're starting from root node. So starting from 8, it is smaller. Then it goes to 7. It is smaller. It goes on the left hand side of 7, which is 2 here because it is less than 7. Next we have is 5. So we go to 8. It is smaller than 8. We go to 7. It is smaller than 7. We go to 2. It is greater than 2. So it goes on the right hand side of 2. So 5 goes here. So this is how the binary search tree works. Now, once we got the basic understanding, let's start the implementation. If I want to code that, first of all, we need a class called node, right? In fact, I will not be writing this here. Let me just remove it. What I want is, from my main method, basically I want to create a binary tree. There are some inbuilt classes, but we're not going to use it. So let's say binary tree, and we'll call this as a tree equal to new binary tree. So we want to build a binary tree. Okay, you can see we have some inbuilt methods. We don't want to use them. So let's use a binary tree. We don't have this class yet. So what I will do is, I will just go back here, and you can see it is importing this package. We don't want any inbuilt things. So if I go back here, and if I say, hey, give me suggestions. More actions, I want to create this class, binary tree in the same package, and you can see we got it. I will just move this on this side. I don't want to see the project structure. So you can see on the left-hand side, we have a main. On the right-hand side, we have a binary tree. So basically in this binary tree, I want to do all those stuff. Now when I say I want to do stuff, basically we have to say tree dot. I want to insert value in this tree. So I can say insert, and I can pass a value, let's say 10. I don't know what values I'm passing here. Or maybe I can for the same value which we have in our node. So we have 8, 7, 12, 15, 2, and 5. Let's add that. Okay, but then unfortunately, we don't have this insert. Okay, so what we need to do is we need to create this method called insert inside this binary tree. And you can see we got insert method. Okay, but when you say insert, that means we have to make sure that you're inserting a node. Of course, you're passing data here, but it should be added to a node, right? And we don't have a node implementation yet. So I can create a node implementation by saying class node. Now, what every node will have. Now, if you go back to linked list, a node will have two things, the data and the next value. Now, in terms of this node here, which is a tree node, it will have three things, data, the left node, and the right node. So I can say int data, then we have to say node, because when you say right node, left node, they are itself nodes, right? Let's first write left and then right. So yeah, so we got data, we got left node, and we got right node. I think the only problem is in some of the class, I think in linked list, we already have a node here. That's the problem. So what I will do is, let me just move binary tree and this main to some other package. I will just move the binary tree to other package. Let's say package com.telesco.tree. So sometimes you have to solve the problems in a go. You need to import the package from here now. Importing done. Okay, so problem resolved. The problem was I was having two classes with the same name in the same package. I just moved it to different package. Okay, so now you don't have to do that if you're just writing the binary code. You can just skip this line. Anyway, so we got a node, and then we are referring to left node and right node. So that's node done. But also what I want to do is, maybe when I create a node, I want to have a constructor here, which will take the data from me, and I will assign that data. So I can say this dot data to data, and that's it. So we are basically done with the node concept. But how will you implement this tree? So every time you want to insert the data in a tree, how will you do it? So if you say this is a tree, of course let's say we don't have a tree here, and let's go with the same value. I don't know what values we have. I can just use this copy. Okay, so we got this value. So if I want to draw a tree, so let's say someone is giving you the value 8 initially. So what you do is you create a root node. Now we know that we don't have a node in the tree. So basically the tree is empty. In that case, you will make this as a root node. Okay, so how do we do that? So when you say insert, basically we have to create a root node. That means every tree need to know about only one thing, which is a root node, right? As I mentioned before, for a tree, the most important thing is root, and then tree don't have to worry about other nodes. The root node will take care of the next two nodes. So what I can do is I can say node root, and then every time I create insert, and then imagine that this is the first time. So what you will do is you will create your root node here. So you can simply say root is equal to new node. That's how you create a node. Just create the object and pass the data. And that's it. You got your root node. In fact, instead of using this variable as I, it should be data. It will make much more sense. So now if you can see our code, this is the thing we have done. So we created a root node called 8, and that's your root node, which looks good. But then what about if I insert one more data here? So if I say tree insert I want to insert the next record. What's the next record? It is 7. So when I insert 7, where the 7 should go? Now, don't you think the 7 should go on this side is because we are implementing binary search tree. 7 is less than 8, so it should be on the left-hand side. So when I say 7, it should create a new node, and we are doing it. You can see every time you say insert, it creates a new node. But don't you think this time is not a root node? It's a left node of the root node. How will you do that? And how do we even know that this is not a root node? So in that case, we need to do is, we need to check if the root is null. Then you create a new node. Then you create a root node. Otherwise, you don't create root node every time. So root node will be created only once if the root is null. What else if it is not null? Then we can check for something else. Now see, if we talk about 8, yes, this satisfies us because root is null till this point before executing 8. But when you insert 7, we already have a root node, right? Then we have to go for if else. Now the question is, now we know that this is not a root node. We have to either go for left or right. So what you do is, you basically check for data. If the data is less than root.data, then you go on the left-hand side. So when you say you go for left-hand side, what you simply do is, you say root.left.data is equal to data. That's what you do. But then we have one little problem here. Because see, this will work for this data. Okay, so we will get new thing. But we're not even creating a new node. Okay, so the problem is we need to modify this to something else. Why something else? Let's say we have adding one more, which is 12 goes here, and then you add 15. Now, by our logic, if the value is greater than root node, just add it to the right hand side. But 12 is already there, right? Then we have to move to 12 and it becomes a right hand side of 12. That means we have to jump from root to the next element and then the next element. Oh, that's a recursive process now. So that means we have to add a recursion here. That's one thing. Second problem is, every time you insert data, we need to get a hold on root. Writing the logic here is not efficient way. What we should be doing is create another method which is called, let's say, insert rec, and we'll say this will take two things, because when you want to do recursion, we have to get a hold on root element or root node. So that means we cannot do that in this insert, because the moment you say recursion, every time you call the method, we need to get the hold on the node where you're calling this. So this will not work, but that doesn't mean we have to remove this. I will tell you in some time why. So basically we have to say node root comma data. And here, okay, this should return a node because we are going for recursion, so it should return something. And now here, instead of doing all this logic should be a part of this, not this. So here, we can simply say root is equal to insert record. So every time you call insert, it will call insert rec, in which you are passing the root node and the data. So when you say recursion, it will go into recursion. We will be using recursion on insert rec, not on insert. So we have to change some logic here. So this is correct when you say root. I'm only concerned about this part. So how do we implement this one? So when I say I want to add element on the left hand side, so if you have, let's say 2, now we know that 2 should go here, but then we have to jump from 8 to 7, 7 to 2. That's a recursive process, right? So what you will do is, let me uncomment this now. This is not how you do it. So basically you say root.left and then you call the function once again by passing the root.left, because now we need to follow the tree, right? As I mentioned before, when you talk about the subtrees, if it is not 8 left, then we have to consider this subtree. Now this 7 becomes your root. So how will you send this as a root? So you have to say root.left. Now this becomes a new root. So when you call this function, which is insert rec here, this becomes your new root. And then you have to pass data as well, so you're passing data. But what if this is not smaller? Then you have to go on the right hand side. So you have to say root.data. If data is greater than root.data, then you do the same thing but for the right hand side. So we'll say paste here. So this should be right and this should be right. And then at the end, you know your root node, so just return root. That's it. So this is the recursion call which we are getting here. So that's how basically you create a tree. Now tree is created. But how will we know that this tree is created? We want to print also, right? And the way you can print it is like this. So if you want to print this tree, so let's say we have this tree here, and this tree is created by the way we have defined this example here. How will you print this? Now to print, we basically have to traverse, or we have to travel to different elements here. The way you do that is we have different traversal for tree. So when you talk about tree traversal, we have to follow certain things. First, there are three options here. We have in order traversal, we have pre-order traversal, and we have post order. The difference between these three is the way you print your root node. Okay, so when you talk about in order, basically what you do is you first go to the left, then you go to the root, then you go to the right, so which is 7, 8, 12. When you talk about pre-order, here you first go to root, which is 8, so it will print 8, then 7, which is left, and then 12, which is right. When you talk about post, it means first it will go for left, then right, then root, which is 7, 12, and 8. Okay, that's your post order traversal. Here we are going to go for in order. So in order simply means first you print the left one, then you print the, also not exactly printing, but you go to the left one, then you go to the root node, and then you go for the right one. So that's your in order. Now the way you can do that, of course, this is also recursive, right? So in order to do that, what I will do is I will create a function called public void in order. Then you can work here. But then since we know that in order is actually, or traversal is basically a recursive operation where you go to each subtree and print it or do some operations. For the recursion, I will create another method which is public void, is because I don't want to return anything. So I will say in order rec. So here we just want to print it. Now, when you say print it, how exactly we are going to print? How we are going to travel this? Of course, the output will not be similar to the value we have inserted. It will have a different order. So what it will do is first it will print the left one, right? So when you start from here, it goes to 8, but then we cannot work on the 8 because that's in order. Then you go to the left one, because in order you first go for left hand side, left subtree. And then from 7 also, you can't print 7 because 7 becomes a root node for the 2. So we have to go to 2. Now we don't have any left here, right? This is empty. So in this case, you will first print 2. Okay, so you will go for 2. But then you go for right. Since we don't have a left, we print the root node because we are considering this subtree now. So you will print 2 and then you will print 5. So here we have 5. Then you go up. Then you print 7 because we don't have anything. So that's a parent for 2. So we'll go for 7. Then we print on the right hand side. We don't have anything right hand side, right? So this is empty. Then you go up, you print 8. Then you go for the right hand side. Right hand side is 12. On 12 left, we don't have anything. So it will not print anything, but you can print 12. And then you can go for right hand side, which is 15. And if you observe, you got a sorted values. So that's why we use BST, which is sorted values. It is easier to search as well. Okay, this is the in order traversal. Okay, so let's implement this. So how do we do it? So first we'll start from the left hand side. But also we want to verify if the tree is empty. If the tree is empty, how will you print something? How will you travel? And how do you know if the tree is empty? By using the root element. So we can simply check if root. But how do you know the root? Because root will keep changing depending on the tree, right? So we have to also accept root here. So we'll say node is root. And then you check if the root is not equal to null, then only you do it. Now, how will you do it? Now, first of all, this is a recursive function, right? So basically you have to call itself. So we'll say in order rec, and then you have to start from the left hand side. So always start from left and then keep going till you find the last left element, okay? And then once you do that, then you have to go for the middle one. Middle one is root itself, which we got here, right? So we can print this value here. So I will say print. And if you observe for every node, for every subtree, there is always a root node. If you observe for 8, 7 is left, right? But don't you think 7 in this subtree is a root node? So that's a root we are printing. When you go to 2, 2 becomes a root node, right? When you go 5, 5 becomes a root node for their child, which we don't have. Then we can print data here. So we can say root.data, and then we can print a space in between as well, just to differentiate the values. And also I can skip the new line. Now, once you are done with the root element, of course, not just printing, you can do some other operations as well. Maybe you can add all the values if you want. And then here, I can say in order, but this time you will go for root.write. That's it. This is how basically you print the values. But from in order, we have to call in order rec by passing the root node. So you will call this only once in order. So that means I can simply create a tree by adding values here first of all. Now what values we have, let me just do that quickly. Okay, so you can see we have added all the values and now it's time for traversal. So I will just print in order and it should do the job for us. Let's try. So I will just run this and you can see we got the values. We got 2, 5, 7, 8, 12 and 15. That's what expected. It is printing in order. But let's say if you want to do post order, so what I can do is I can just change their names, or maybe I can say pre-order. So I can say pre-order, and of course everywhere you have to do that. Now the only change you have to make is in pre-order, first you print the root. So that means this line will go up. That's the only change you have to make in pre-order. Okay, nothing much. Let's run this and see if this works. Save this code and run. And you can see this is now pre-order. So root element is something which will get print first. I think this is a sequence in which we have added. No, a different sequence. But anyway, you got the point. So this is pre-order. You can also do it post-order. Let me know in the comment section if you have done that. And yeah, that's how you implement tree.